Do you want to create a technology infrastructure that is unique, efficient, and trustworthy to support and maintain a company's growth? Then learning Java would be beneficial to your professional development as it allows you to create everything from little application to massive end-to-end business solution and is rightly known as the language of internet since it allows us to move freely in the cyberspace. We have developed this course primarily for beginners as we will be learning everything about Java programming from the ground up. We will look at not only why this program is important, but also the concept and philosophy underlying each programming construct. So even if you are a newbie in the world of programming, you will be able to grasp and master Java programming by the end of this video. So without further ado, let's get started with the learning process. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Hello everyone. Welcome to this tutorial where I'll be talking about Java programming. This is a full course related to Java programming. So before going ahead with the depth of the course, let me tell you what all I'm going to talk about in this course. So first we will talk about the basic fundamentals of Java programming. That is, what are different variables, literals, data types, what are different operators in Java programming, then what are the different control statements, looping constructs. All these basic fundamentals will be discussed related to Java programming in the very first topic of Java programming fundamentals. Going ahead, we'll talk about the applications of Java. Before understanding the complexities of Java programming, it is very important for you to understand where we'll be using this Java programming finally, right? Moving ahead, we'll talk about classes and objects. As classes and objects are two most important concepts when it comes to Java programming, because Java is an object-oriented programming language. And before understanding the complexities of object-oriented programming, you need to understand what is a class and what is an object. So that will be discussed in detail in this topic. After that, we'll talk about interface, because interface is also one of the programming construct of Java, which is widely used to implement various aspects of real-life problems. Going ahead, we'll talk about object-oriented programming. The three different pillars of object-oriented programming, that is encapsulation, inheritance, and polymorphism, will be discussed in this topic. After that, we'll talk about collections. That is, how different data types can be used for representing collection of objects will be discussed in this topic. Moving ahead, we'll also talk about hashing. And hashing is also one of the techniques how we store data in memory. Right? So it is important to understand how, with the help of hashing concept, the data is stored in memory. Moving ahead, we'll talk about multithreading. Java is a multi-threaded language. And why we call Java as a multi-threaded language, that is also important to understand. And you will get the clarity in this topic of multi-threading, which we will discuss next. After that, that is lastly, we'll talk about exception handling in Java. Exception handling helps Java to become a powerful programming language. And how it is possible, that we will talk and discuss in this topic of exception handling in Java. So let's get started with the topics.
Let's start off by understanding what exactly is Java. So Java is a free and open source software. It's just plug and play. All you have to do is install Java once and you can start working with it. Java is also a cross-platform compatible language. So you can run Java on any operating system. Whether you have a Windows, Mac, or a Linux system, you can seamlessly run the same project on whatever operating system you have. And Java is also an object-oriented programming language. It's actually a pure object-oriented programming language. So what do I mean by that? Well, to understand that, let's actually understand what are objects. Now, look around you. What do you see? You see a lot of objects, don't you? So let's say there's a bottle in front of you. What is that bottle? It's an object. Now, let's say there's a cricket bat in front of you. What again is that? That is an object. Now, if you want to represent all of these objects in a programming point of view, that is when you need an object-oriented programming language. So it helps you to represent all of the objects which are surrounded by you in a programming language. let's go ahead and install Java into our systems. So you can install Java from this site over here. So Java actually belongs to Oracle. So you'd have to go to oracle.com, Java Technologies, Java downloads.html. So you'd have to download something known as a JDK. So let's go ahead and download JDK first. So I'll just type in download JDK. I'll click on the first link over here. Now I'll click on JDK download. So JDK stands for Java Development Kit, which, as the name states, is a kit for you to program all of the Java concepts. And it also gives you something known as Java Runtime Environment, which helps you to execute your code. So it's basically a kit which helps you to create your programs and also execute your programs. So over here you have different versions of it. So if you have a Linux system, then you can download JDK for Linux. If you have a Mac, then you can download JDK for a Mac. Similarly, if you have a Windows system, then you can download JDK for a Windows system over here. So all you have to do is click on this download button, check this, and then click on download. So it is the latest version of Java, JDK 14.0.1. And as you see, the download is starting over here. Now I'll just click on cancel because I don't have a lot of Wi-Fi left. And I already have JDK in my system. So we've successfully installed JDK into our systems. Now it'll actually give you a tool wizard and you have to click on next, and that will successfully set up everything in your system. Once you download JDK, you'd have to install a development environment as well. So this is known as integrated development environment. So one such integrated development for Java is Eclipse. And you can download Eclipse from this particular site, eclipse.org/downloads. So let me click on this link over here. Let's just wait till the link opens up. So what Eclipse does is it provides you a proper platform, a proper development environment so that you can code in a very easy way. Now let me go to the bottom of this. So actually we have this download 64-bit version. And since I have a 64-bit version, I have clicked on that. And when you click on the download button again, the download would start. So as you see over here, the download is starting. Now, since I already have Eclipse in my system, I'll just go ahead and cancel this. Right. So I have successfully installed Java and Eclipse into my system. Now, let's see how does Eclipse look like. So let me just open up Eclipse and show it to you guys. So this is how Eclipse workspace looks like. Now our first task would be to create a new Java project. So for that purpose, I'll click on File, and over here we've got a new option and we have to create a new Java project. So I'll just click on this and you'd have to give a project name. So I'll name this as test_project. Now normally when you give a name of a project, you keep the first letter to be small over here. I'll click on Finish. So let's just wait for this to be done. Right. So the module name is also create. So we have successfully created our first Java project. Now inside this, you have the source folder. So this is where all of your code would exist. Now you'd have to right click on the source folder. Then you have this new option again. And inside the source folder, you'd have to create a package. So click on package and then you'd have to give a name to this package. So I am naming this as test project again. Let me click on finish. So we have created this project. Now again, I'll click on this new project over here, and inside this I'd have to create a class. So over here, I'll give a name to this class and I will name this as test project. Right. And over here, just click on this, which will give you public static void main. So if this seems confusing to you right now, just wait for a few minutes and then you'll properly understand what exactly is going on. Right. So I'll click on finish and this will give you your new class. So over here, as you see, we've got public class test project. So this is the name of the class. And as I've already told you, Java is a pure object-oriented programming language. So whatever you do with Java happens inside a class. So what exactly is a class? You can consider a class to be the blueprint of an object. Now let's say I've already told you what exactly is an object. So everything that you see around you is an object. So let's say if an object is a house, right? Now you would have to create a blueprint of that house, and that is what this class will give you. So over here, I am naming this class as test project, and this is a function. So main, what you see over here, this is called as a function, and the execution of your program starts inside this main method. So now that we've installed Eclipse and seen how it looks like, let's go ahead and write our first Java program. So we've already created our package, we've also created our class, and we also have this main function inside our class. And I've told you that the program execution starts inside main. So let's understand what are these exactly. So over here, class, you can consider this to be a keyword. So everything inside Java needs to be inside a class, and over here the name of the class is test. And by convention, you would have to give the name of the class with a capital letter. So over here, as you see, the name starts with capital T. Now we have something known as an access modifier. So over here, this access modifier is public. So what does this mean? This means that this is a public class. So this public class can be accessed by everyone. So that is, this public class can be accessed by everyone which is present in the program. Now inside this class test, we also have this main function. Now let's understand this properly. So before main, you have something known as void. So void is the return type of this function main. Now every function has a return type associated with it, and for main function over here we've got void. Now what is void? Void means that it isn't returning anything. And after that we again have public static. So public over here means that this is a public function again, and static means that this is a static function. So a static function, when you create, it can be accessed without an object. So normally if you don't add the static before a function, then you would need an object to invoke that function. Now inside this main function, I am writing my first line over here. So I'm printing out this is Sparta. So let's go to Eclipse and print this out. So this is our program over here. Now let's go ahead and write our first program over here. So inside this, I'll just type in system.out.println, system.out.println over here, and I will write my first program. So I'll type in this is Sparta. So let's understand what is happening. So we know what a class is, we know what a main function is, and all we have to do is whatever code is there, all of that code has to be present inside this main function. Now after this, it is important that you end each line of the code with a semicolon. If you don't add a semicolon, then the compiler, the Java compiler, would not know where the code ends. So that is why wherever you end a line, it is important that you put a semicolon over there. Right. Now, what does system.out.println mean? So for now, just understand that system is a class and println is a function which is present inside the system class, which helps you to print something out onto the console over here. And what are we printing? We are printing this particular sentence, which is this is Sparta. So we've written this program. Now let's go ahead and run it. So I'll click on run. Now again, I'll check this and let me click on OK. So we have successfully executed our first program over here, and this is the result. So as you see, the result is this is Sparta. So guys, we have successfully written our first program. So now that we've written our first program, let's go ahead and understand what exactly are variables in Java. So whenever it comes to programming, it's very essential that we understand what data we are dealing with. And since every programming language deals with a lot of data, it's important to store that data somewhere. And this is where variables come in. So let's say I've got these three numbers over here, 10, 20, and 30, and I'd have to store this data somewhere. So what I'll do is I'll take a variable with the name my number and store this value inside this variable. So in simple terms, you can consider a variable to be a temporary storage space. So a variable is a temporary storage space where you store a lot of values. And over here, I am storing this value 10 inside this variable called as my number. So this is done over here. Now, as I've told you, a variable is a temporary storage space. So once you store a value, that value can actually be changed inside a variable. So let's say initially I store the value 10 inside this variable. So after some time, I want to change this value and store 20. Similarly, after some time, I want to change this value and store 30. So variable helps you to change values inside it. So again, if this seems confusing, let's go to Eclipse and work with this. Now let's go ahead and create a first variable. You need to understand that every variable is actually associated with a data type. So first you give in a data type. So over here, I am creating an integer data type. So I'll type in int and then I'll give a name of the variable, which is a. I'll give the equal to symbol over here and the value is 10. And since the line of code ends over here, I'll put a semicolon over here. So what I'm doing is I'm basically storing the value 10 inside this integer variable. Now let me go ahead and print out this value. So if I have to print, you would have to use this system.out.println command and store a inside this. Now let me go ahead and run this code over here. Let me click on OK. So as you see, we have successfully printed out the value which is present in this variable. Now, as I've told you, a variable is a temporary storage space. So you can actually change the values which are present in this variable. So instead of 10, let's say if I want to store 20, now 20 is stored in A and I'm printing out A again over here. So I'll click on run. And as you see, this time we have the result 20 instead of 10. Similarly, let me go ahead and change the value to 30 over here. Now again, I'm printing out the same variable, which is A. I'll click on OK. And again, as you see, the value 20 has been changed to 30 over here. So this is how we can work with variables. So in simple terms, variables are just temporary storage spaces. So now that we know what variables are, let's also understand what are data types and what are the different data types we can work with. So every variable is associated with a data type. And we can have different types of data. So we can have integer values. So numbers such as 10, 500, 1000, -1, all of these would constitute into integer variables. Then we have floating type variables. So values whichever have decimal points. So let's say 3.14, 15.97 or 1000.0099. All of these are floating point numbers. And then we've got Boolean values. So Boolean values are just true or false values. And then we've got string values. So string values are stored in double quotes. So over here, Sam is a string value. Matt is a string value. So apart from this, we also have a lot of different data types. So for now, these are the most important data types, and let's work with all of these data types first. So we've already seen an integer data type, what it is and how to print it out. Now let's go ahead and work with a floating data type. So I'll type in float. And then again, I'll type in A over here and let me give in a floating point value. So I'll type in 3.14. Now, after you give a floating value, you would have to add the suffix F. So this would tell the compiler that this is actually a floating point value. And after that, you'll give in a semicolon and I'm printing it out over here. So let me click on run. And as you see, we have successfully printed out this floating point value. Now let me change this to something else. So I'll type in 12.76. Let me print this out over here. So this is our new floating point value. So we are done with the floating point value. Now let's go ahead and work with a Boolean value. So I'll just type in Boolean over here. And as I've told you, this has only two types of values, which is true and false. So I'll type in true. And I'd have to give a name to the variable. So let's say I name this as logit and I am storing the value true inside logit. Now let me print out logit over here and let's see what do we get. So as we see, we have the result true. Now similarly, I can change this to false. So I'll store false inside this and I'm printing out the same thing over here. So this time we've got the result false. Now let's go ahead and work with strings. Now I'll type in string. So over here you have to keep in mind that S is capital. S is not small over here. So once you type in string and then give a value, which is the name of the variable over here. And inside this, let's say I type in Sam And then let me print out A over here again. So let me actually change this to small s over here. So we have some error again. So this is actually capital S and I'd have to put in a semicolon over here. Now let's print this out. So as you see, we have successfully printed out this value Sam, which is a string variable. Now similarly, let me go ahead and change this value. I'll put in Bob, which again is stored in A, and I'll print this out. Right, so again we have printed out Bob. So these are the different types of data types which you can work with in Java. So till now we've looked at the basics of Java. Now let's go ahead and understand what are flow control statements. So the first flow control statement which we're going to work with is the if statement. So this is known as a decision making statement. Let's understand this through a real world example. So there are a lot of scenarios where we'd have to make certain decisions which would impact our future. Now let's take a certain sort of example. So over here, let's say it's raining outside, but you want to go ahead and play football. So the condition over here is this. If it's raining, then you can't go out and play football and you'd actually have to stay inside and do something else. But on the other hand, if it's not raining, so else, if it is not raining, then you can happily go out and play. So this is the if statement which you can use to depict the real world problems. So the idea is that if it's raining, then you can't go out and you'd have to sit inside and maybe watch a movie. On the other hand, if it's not raining, then you can go outside and play football. So similarly, let's take another example to understand if statement properly. So here, let's say you have given an exam, and if you score more than 70 marks in the exam, then you'll get an ice cream. On the other hand, if you score less than 70, then you'd have to go ahead and give a practice test so that your marks can improve. So this is the sort of if statement which helps us to implement real world problems in the programming paradigm. Now let's go ahead and work with the if statement in Java. So this is how the if statement looks like in Java. So you give an if, which is the keyword over here, and then after that you put in these round braces and you give the condition inside these round braces. So the condition is if 20 is greater than 18. So you're checking if the value 20 is greater than 18, and if this comes out to be true, you will go ahead and print out 20 is greater than 18. Now similarly, we have another example over here. We've got two variables. So 20 is stored in X and 18 is stored in Y. And we are checking if Y is greater than X. So if this value evaluates to true, then we'll go ahead and print this. So is Y greater than X? This is actually false because 18 is not greater than 20 and hence we'll not be able to print this. So now since this is false, we'll skip this and then go ahead to the else statement. So here in the else statement, we'll print out X is greater than Y. So what happens here is if this evaluates to false, then we'll head to the else statement and whatever is present inside the body of the else statement, that would be printed out. So let's go ahead and work with both of these examples. So let's work with the first example over here. I'll type in if, which is the keyword, and then I'll give the condition. So the condition is if 20 is greater than 18, and then I'll put in these braces over here. Right. So these are the braces. Now let me also close this brace over here. So it's very important that you close a brace whenever you open. Now also see that I have not put a semicolon over here because if is a condition. This is not a single line of code. Now let me go ahead and print out the body inside this. So if 20 is greater than 18, then let me just put in system.out.println, and I'd have to type out 20 is greater than 18. Let's execute this and let's see what is the result. So you see that there's an error over here. Now that error is I'd have to put a semicolon. Now that we've taken care of the error, let me go ahead and click on OK. And since this has been evaluated to true, that is 20 is actually greater than 18. So that is why we were able to print out this result. Now let me actually change this and let's see what happens. If 18 is greater than 20, then do this. Now we don't have any result over here. That is because this has been evaluated to false. And since this has been evaluated to false, whatever is there inside the body of this if condition, that has been skipped out. So this was our first example. Now let's go ahead and work with the second example. So the second example, we had two integer variables, x and y. In x, I'm storing 20, and then let me go ahead and create the second variable over here. I'd actually have to put in a semicolon, and then the second variable would be y, and I'm storing, let's say, 15 inside this. So I've got my two variables ready, and then I'd have to give in the if statement, and I want to check if y is greater than x. So if y is actually greater than x, then I would have to print out system.out.println, and I will print out y is greater than x. I'll put a semicolon over here, and if this evaluates to false, I'll put in else. I'll have to close this over here. Else system.out.println, and this would be x is greater than y. So before I execute this, think for a while, and what would you say is the result? Let me execute this now. So as you guys see, this is the second one, because y is not greater than x, or in other words, 15 is not greater than 20. So that is why whatever is present inside the body of if has been skipped out. And then we head to else, and whatever is present inside the body of else, that will be printed out. So we print out x is greater than y. So this is the if else statement. Now there is something known as if else if statement. So if we have multiple decisions to be taken care of, that is when we'll work with if else if statement. So over here we've got different grades, and according to the marks obtained by the student, we'd have to assign him a particular grade. So over here we see that the student has scored 65 marks. Now we've got different categories over here. So if the student scores less than 50 marks, then he would have failed the exam. If the score is between 50 and 60, then the grade is D. Similarly, if the score is between 60 and 75, then the grade is C. And if the score is between 75 and 90, it's a B grade. And if it is between 90 and 100, it's an A plus grade. And if he scores anything else, then we'd have to print out invalid. Now let's understand this code properly. We'll start with the if statement, and we are checking if marks are actually less than 50. So if this evaluates to true, we'll go ahead and print out fail. On the other hand, if this evaluates to false, we'll come down and we'll check over here. So over here we've got two conditions which have to be evaluated. First condition is we're checking if marks are equal to greater than 20 and marks less than 60. This means that the mark should be between 50 and 60, where 50 is inclusive but 60 is exclusive. So if the student scores between 50 and 60, we'll go ahead and print out B grade. Now again, if this is also false, that is, if the student has scored above 60, then we'll go ahead and check if the marks are equal to greater than 60 and also less than 75. If this is the case, we'll print out C grade. Similarly, if this is also evaluated to false, then we'll come down, put in else if. So keep in mind that here the keyword is else if. That is what we are writing over here. And inside the third else if statement, the condition is if marks are greater than equal to 75 and marks less than 90, we'll print out B grade. And then we'll check if marks are between 90 and 100. And if that is the case, we'll print out A plus grade. And finally, if none of these evaluate to true, then we'll just print out the last else statement, and inside the last else statement we'll put in invalid. This would mean that if the marks are greater than 100, right, which is actually invalid. Marks can be less than 50, but the marks cannot be greater than 100. So if that is the case, then we'll put in invalid. So let's go ahead and run this command in Eclipse. So let me first remove all of this. Let me cut out all of this over here. So I'll go ahead and create the marks variable over here, and let's say the student has scored 65 marks. So we've got this ready. Now I'd have to go ahead and put in my first condition where I'm checking if marks are actually less than 50. And if this is the case, I'd have to go ahead and print out. Let me put in system over here. System.out.println. So if the marks are actually less than 50, then I'd have to print out fail. On the other hand, I'll put in else if. So now I'd have to check if marks are equal to greater than 50. So if the first condition is false, then we are checking if marks are equal to greater than 50, and now I also want the marks to be less than 60. So if this is the case, then I will go ahead and print out. So instead of typing everything, let me just go ahead and copy this and I will paste it over here. So this time the grade would be equal to D. So I'll type in D grade. Then I'll put in the next else if condition over here. So this time, if these two conditions fail, then I'd have to check if marks are equal to greater than 60. I'll put in the AND operator, and also the marks need to be less than 75. So if this is the case, again let me put in the print statement, the grade would be equal to C. So I'll type in C grade over here. So if these three conditions fail, then we've got the next else if statement over here, and I'd have to check. So this is actually 75 over here, not 65. So let me put in 75 over here. Right. And I'd have to check if marks are actually greater than or equal to 75. And then I'll give in the next AND operator. I'll type in marks which have to be less than 70. I'll open and close the braces over here. I'll put in the print statement, and the grade would be equal to B. Let me put in B grade over here. Now if this is also false, we've got again the else if statement, and over here I'd have to check if marks are greater than equal to 90 and also marks are less than equal to 100, because that is the maximum a student can score. I'll put in the print statement over here again, and this time if the student scores between 90 and 100, the grade would be equal to A. Now if by any chance there's some printing error and it turns out that the student has actually scored greater than 100, which is not possible, so in that case we'll print out system.out.println, and we will type in invalid score. So we've got all of the code over here ready. Let me execute this and let's see what is the result. So we get C grade because the marks are 65. So we print out C grade. Now let me change this and let me put it to be 25 and let's see what is the result. So if it is 25, we get fail because obviously if we are checking over here, if it is less than 25, then this evaluates to true and we print out fail. Now let me put in 120 and let's see what is the result now. We get invalid score because a student obviously cannot get more than 100 marks. Now let me put in 99 over here and let's execute this, see what is the result this time. And when the student scores 99, the grade is obviously A. Now we've got another example over here of else if statement. So this time we're checking if the number which we given is positive, negative or 0. So over here the number is minus 13. So we start off with our first if statement and we are checking if number is greater than 0. So if the number is actually greater than 0, then we'll print out positive. If this evaluates to false, we'll come to the next else if statement and we'll check if number is less than 0. And if this evaluates to true, we'll print negative. On the other hand, if the number is not positive and also the number is not negative, then there's only one possibility, that is for the number to be equal to 0. And that is what we'll print out in the last else statement over here, 0. right? So let's go ahead and execute this program. I'll cut all of this over here. Let me remove the existing code from this. Now I will go ahead and create a new number. Let's say int. I will name this to be num, and I will store a value of 50 inside this. Now I'd have to give in the if statement, and I want to check if num is greater than 0. So if number is greater than 0, then I'd have to print out. So let me put in this properly, system.out.println, and the result would be positive. So I'll type in positive number over here. I'll have to put in a semicolon. On the other hand, if the number is not positive, then I want to check if the number value is less than 0. So if this is the case, again, let me just go ahead and copy this from over here and paste it over here. I'll cut this. Now, if the number is actually less than 0, then I'd have to print out negative number. So let me just type out negative number over here. And if this also fails, then I'll put in the last else statement. The value would be equal to 0. So I'll just type in 0 over here. So I've got all of my code covered. I'll hit on execute. Now, since the value is equal to 50, we get the value to be positive. Now let me put in a minus symbol over here. Now let's see what is the result. So when I put in minus over here, we get a negative number. Now let me remove this and let me set it to be equal to 0. And when the value is 0, we get this. So yes, this is how we can work with if else, and the else if statement. So those were the decision-making statements. Now in flow control statements, we've got something known as the looping statements. So these looping statements are used to repeat a task multiple times. So there would be a lot of real life situations where you'd have to keep doing the same task again and again. So what you're doing is actually looping. That is, you're repeating a certain task. Let's take this example over here. Now let's say you've got a bucket and you have to fill up that entire bucket with a mug of water. So what you do is you take in a mug of water, pour into the bucket, and you check if the bucket is full or not. If the bucket is not full, you again take a mug of water, pour it into the bucket. You check if the bucket is full or not. If it's not full, again you take the mug of water, pour it into the bucket. So you keep doing this process until the bucket is full. So over here the condition is until the bucket is full, you keep on pouring the mug of water into the bucket. So here you are going in a loop. Now similarly, we've got this example. So many a times if we love a song very much, we keep repeating the song again and again. So this again is a case of looping statements. So here the condition could be until you close the app, you keep listening to the same song again and again. Then we've got another example over here. Now all of us work for money, don't we? Right? And at the end of every month, we get salary credited into our accounts. That is a wonderful feeling, absolutely, isn't it? So this again is a looping statement over here. So at the end of every month, that is, now if you consider 30 to be the end of every month, this is a repetitive task. So every month on the 30th day, you get money in your bank. So this is a task, this is a repetitive task which happens at the end of every month. So these are some real life situations of looping statements. Now in Java, we've got two very important looping statements which are while and for. And we'll understand both of them over here. So this is the pseudocode of while, and this is how we can work with while in Java. So let's understand the pseudocode over here. So first we enter the loop and then we check the test expression. So if the text expression is true, we enter the body of while. Whatever is present inside the body of while will execute all of that. Now after execution of it, again we'll check the test expression. If that evaluates to true, we'll keep on executing whatever is there inside the body of while. And once the test expression evaluates to false, we'll exit the loop. Now if that sounds complicated, we'll understand it with the help of this particular code over here. So over here, initially we've assigned the value of x to be equal to 1. Now we enter this while loop. So here the keyword is while. right? You start with the keyword while, and inside these round braces over here, you give in a condition which is x is less than or equal to 4. So here you are checking the value of x. Initially the value of x is equal to 1. So is 1 less than or equal to 4? That evaluates to true. And since that evaluates to true, you print out the value of x, which is 1. Now after that you increment the value of x. So x plus plus would increment the value of x, it becomes 2. Now here you again check if 2 is less than or equal to 4. Now since this evaluates to true, again you'll print out x, which is 2. Then you'll increment the value of x. So now x becomes 3. So now you'll again check if 3 is less than or equal to 4, which is true. So you'll print out the value of x, which is 3. Now again you'll increment the value of x, which becomes 4. So this time is 4 less than or equal to 4. Well, this again evaluates to true. And then we print out the value of x. And now this time when we increment the value of x, it becomes 5. So this time when we check is 5 less than or equal to 4, this evaluates to false. And since this evaluates to false, we'll finally come out of this loop. So we'll print out 1, 2, 3 and 4. And finally when x becomes 5, we come out of this loop. So let's go ahead and work with this example. I'll remove all of this. So initially we'd have to assign a particular value. So I'll take num to be my variable and I'll assign the value of 0 in it. Now I have my while loop over here. So this is how you set the while loop, and inside these round braces you give in the condition. So the condition over here is num should be less than or equal to 5. And I have the body over here. Let me put in the print statement system.out.println. And what do I want to print? I would want to print the value of num over here. And after printing it, I want to increment num value. So I'll type in plus plus num. So this is known as a unary operator. So plus plus num. So there are binary operators and unary operators. So till now we had to work with binary operators. So when you have a single operand and when you apply this plus plus on the single operand, this is known as a unary operator. All right. So now let me go ahead and hit on run. And this is the result over here. Let me just increase the size of this. So this is the result. 0, 1, 2, 3, 4 and 5. So here when num value reaches 6, that is when this condition fails, because when num is 6, when we check if 6 is less than or equal to 5, that evaluates to false and we come out of this while loop. So we're done with while loop. Now we've got a different type of loop which is known as a for loop. So in for loop over here, you see that there are 3 conditions over here, or basically 3 statements inside this round braces. So you start with the keyword for, and inside the round braces, you've got the initialization phase, then you have the condition checking phase, and then you have the incrementation or decrementation phase. So you basically have 3 different things happening inside these round braces. First, you initialize the number. Next, you check the condition of that number which you have initialized. After that, this is upon you. Whether you want to increment or decrement, that is totally upon you. So here we have initialized the I value to be equal to 0. Once this is initialized, we'll enter the body of for and we'll print out I. So initially I is 0, we'll print out 0. We'll head back, and now from here we'll go ahead to this. I's value is incremented, it becomes 1. Now after it is incremented, we'll check whether this incremented value is less than 5. So is 1 less than 5? That is true. So we'll go inside the body and we'll print the value. So now we'll print out 1. Again we'll go back, and this time I is incremented, I becomes 2. Now we'll check whether 2 is less than 5. This again is true. So we'll come inside, we'll print 2. We'll go ahead, we'll increment the value of I, it becomes 3. So is 3 less than 5? Well, this is true again. So this is how we'll print 3, and then similarly we'll print 4. Now when I becomes 5, we check the condition. So if 5 is less than 5, that evaluates to false, and we head out of this for loop. So with the help of this for loop, we get the value 0, 1, 2, 3 and 4. Similarly, we've got another example over here. So this time we have initialized the value of I to be equal to 0. Now our condition is if I is less than or equal to 10. So 0 less than or equal to 10, that is true. So we'll print out 0. Of that, we'll head back and we'll increment the value of 5. So 0 plus 2 would become 2. So it's 2 less than or equal to 10, that is true. And then we'll print out the value of I, which is 2. Again, we'll head back, we'll add 2 more to I. So 2 was there, 2 plus 2 becomes 4, we'll print out 4. Again, is 4 less than or equal to 10, that is true. We'll come down, we'll print 4. So this is how it becomes 6 and it also becomes 10. Now after 10, when we increment the I value, it becomes 12. So this time when we check, is 12 less than or equal to 10, that evaluates to false and we come out of this loop. So let's work with all of these examples. So the good thing about using a for loop is you don't have to initialize a variable out of the loop. But when it comes to a while loop, you need to have an external variable initialized. So I'll type in for, I'll have my variable initialized over here. So again, if you have to initialize a variable, you would have to set the data type inside the for loop. So I'm setting for int I is equal to 0. So initially the value of I is equal to 0. Now I given the condition. So I want to check if, now let me actually change it to 10. So if I is less than or equal to 10 and I want to increment the value with 1. Now let me put in the body over here. Let me use the print statement. So I'll type in system.out.println and inside this I will print out the value of I and I'd have to give in a semicolon over here. So seems like we've got an extra brace over here, which I'll go ahead and delete. Now let me execute this and let's see the result. So this is our result. So this loop starts at 0, goes on till 10, and when I value becomes 11, this condition evaluates to false and we come out of this loop. So this is what we get. Now similarly, let's go ahead and set the I value to be equal to 5 and let's set the condition to be equal to 20. And I want to increment this with 5. So this becomes I plus 5, right? So we've got this set over here. Now let me actually, this has to be I equals I plus 5 because that is how we're incrementing this, right? So initially I value is 5, which is less than 20. So we'll print 5. Then it becomes 5 plus 5, which is 10. So it's 10 less than or equal to 20. This is true. We'll print out 10. After that, i's value is incremented by 5 again. 10 plus 5 becomes 15 and then we'll print 15. 15 plus 5 becomes 20. So 20 is equal to 20 and that is why this is true. So we'll print out 20. And finally, when 20 plus 5 becomes 25, this evaluates to false and will come out of the for loop. So these were some basic examples of for loop. Now let's go ahead and work with a very commonly occurring problem, which is known as the pattern problem. Now let's say if we want to print a pattern like this. So this pattern which you see, so we've got 1 star. In the second row, we've got 2 stars. Third row, we've got 3 stars. Fourth row, we've got 4 stars. And in the fifth row, we've got 5 stars. So if you want to do something like this, then we need the help of nested for loops. So what is a nested for loop? So in a nested for loop, you have one for loop inside another for loop. Let's understand this example over here. So since we want 5 rows over here, initially I am setting the value of 5 to this variable n. So n is initialized to 5. Then I start this for loop over here. So over here, the for loop starts at 0 and it goes on till n. So from 0 till it'll go on till 5. So that is 0, 1, 2, 3 and 4. Now once this outer for loop is set, we'll go inside the inner for loop. So this what you see is called as the outer for loop and this is the inner for loop. And in the inner for loop, I've got another variable. So here we had I, which started from 0, went on till n. Now we've got j inside the inner for loop. This starts at 0, but this will only go on till I. So here the condition is j is less than or equal to I. And inside this we'll print out star. Now let's understand this properly over here. So initially when i's value is equal to 0, so is 0 less than 5, that evaluates to true. So we'll come inside the body of outer for loop. And inside this, j's value is equal to 0, and we are checking if 0 is less than or equal to 0, which is true because 0 is equal to 0. Since this is true, we'll come inside the body of the for loop and print this star, which is what we have over here. Now once this is done, we'll go ahead and increment the value of j. So now j becomes 1. So this time we'll check if 1 is less than or equal to 0, which is false. So we'll come out of the for loop and we'll print out a new line over here. System.out.println will give you a new line. Now we'll again complete this, go back to the outer for loop. So this time i's value is incremented by 1. So I is 1 now. So is 1 less than 5, which is true. So we'll come inside the outer for loop. Now again the same thing will start. So j will start at 0. So 0 less than 1, which is true. So we'll print out a star. Again we'll go back. This time j's value becomes 1. So is 1 less than or equal to 1, which is again true. So again we'll come inside and we'll print out another star. Now j's value is incremented. So this time j's value is 2. So is 2 less than or equal to 1, which is false. So we'll come out of the inner for loop and we'll print out a new line. So we've got 2 stars, then we have a new line over here. Now we'll head back to the for loop, increment I value. So this time I value becomes 2. So is 2 less than 5? That is true. We'll come inside the for loop. Now again 0, which is less than 2. So 0, 1 and 2. That is why we have 3 stars over here. And when j becomes 3, this evaluates to false because 3 is not less than or equal to 2. So we'll come outside the inner for loop and print out a new line, right? So this is how this entire thing will go on. So when this becomes 4, when i's value, the outer for loop, in the outer for loop, i's value becomes 4, we'll head inside and 0 will go from 0 and j will go from 0 to 4. So we've got 0, 1, 2, 3 and 4. That means we've got 5 stars over here. And once we print the 5 stars, we'll come out of this. And after that, we'll finally increment the value of I when it becomes 5. So since 5 is not less than 5, we'll end the outer for loop as well. So this is how we can print out this pattern problem over here with the help of a nested for loop. So again, for all of the first timers, this might seem complicated. So let me just code and show you how this is done. So I'll erase all of this over here. So I'll set a value n to be equal to 5. So this is set. Now I would have to create an outer for loop. And inside this outer for loop, I am initializing the I value to be equal to 0. Now this will go on till 5. 5 is again exclusive. So this will be 0, 1, 2, 3 and 4. I'll put in a semicolon and then let me give in the incrementation over here. So I plus plus. I'll go inside the for loop and I'd have to assign the inner for loop. So this time I would have another variable which is j, and j is initialized to 0. Now I'll give the condition. So the condition over here is j needs to be equal to or less than I. I'll put in a semicolon again and then I'd have to give in the incrementation which is again j plus plus. Now I'd have to enter the body of inner loop. Inside this inner loop, what do I have to do? I'll put in the print statement. So this will be system.out.println. So this actually is just print, not println. We don't want a new line over here. So I would need the star over here. Once I put in a star, so what I'll do is I will come out of this inner loop. And then I have a new system.out.println over here. So let me put in system.out.println and I would need a new line over here. So I'll execute this and let's see what is the result. So we've got the desired result over here, right? So in the first row, we've got 1 star, second row, we've got 2 stars, third row, we've got 3 stars, fourth row, we've got 4 stars, and in the fifth row, we've got 5 stars, right? So if you don't understand this, you can go back and listen to the explanation again. So the underlying concept is this. We've got the outer for loop and the inner for loop. The outer for loop will determine the number of rows we have, right? So we've got 1, 2, 3, 4, and 5. So when I is equal to 0, this is our first row, I is equal to 1, second row, I is equal to 3, third row, I is equal to, so I is equal to 3, third row, and then I is equal to 4, this is our fifth row over here. Now, then we'll head on to the inner loop. So j will determine the number of stars which have to be printed. So when j is equal to 0, we have 1 star. When j is equal to 1, we have 2 stars. When j is equal to 2, we have 3 stars. J is equal to 3, we have 4 stars. When j is equal to 4, we have 5 stars, right? So this is how we can print out this pattern problem with the help of this nested for loop. Now let's go ahead and work with operators in Java. So the most important types of operators are arithmetic operators, relational operators, and logical operators. Let's start working with the arithmetic operators first. Now let's add a comment first. So put in 2 forward slashes and add arithmetic operators. Now what exactly is a comment? So let's say if you want to add a description and you don't want that description to be compiled by your program. So that is where comments come in, right? So basically comments are pieces of description, or basically those lines which are not executed by your compiler. And this helps a coder or someone who is going through the code to properly understand what exactly is happening in your program. So we were supposed to work with arithmetic operators. Now arithmetic operators simply put are plus, you've got minus, and then you've got multiplication, and then you've got division over here. So these are the different types of arithmetic operators. Now let's go ahead and work with some of these arithmetic operators. So I'll create one variable a and I'll store the value 10 inside this. After this, I'll create a new variable b and I'll store the value 20 inside this. So we've got two variables, 10 is stored in a, 20 is stored in b. Now let's go ahead and add these two values. So I'm adding a plus b inside the print statement. Let's see what is the result. We get a value of 30 because a plus b, 10 is stored in a, 20 is stored in b, and when you add both of them, you get a value of 30. Now similarly, instead of plus, let me put in minus over here. And when I execute this, I get a value of minus 10 because 10 minus 20 is minus 10. Now let me go ahead and change this to multiplication over here. And this would give a value of 200 because 10 cross 20 is 200. Now let me also divide these two. So a divided by b, let's see what do we get. We get a value of 0. Now isn't this strange? So 10 divided by 20 actually needs to be 0.5, but we've got 0. Why is that? Because we are actually working with integers over here. So 10 and 20 are integers and the result would also be an integer. So in that 0.5, 0 is actually the integral part of it, right? And your integer is 0. So that is why we have this particular result over here. And if you want the decimal part as well, you would have to store this as a decimal. So you'll put in 10f and 20f over here, and you will change the data type of a to float, and similarly you will also change the data type of b to float. Now let me go ahead and execute this. So as you see, we have a result of 0.5 over here. So we're done with arithmetic operators. Now we'll go ahead and work with relational operators. So I'll just put in relational operators over here. Now relational operators help us to understand the relationship between two operands. Again, let me go ahead and create my first variable over here. Let me give in proper spacing. So I'll store 10 inside a over here. Let me put in semicolon. Similarly, let me store b 20 inside b over here, and then I'll put in a semicolon over here. Now I want to understand whether a is less than b. So inside this print statement, I am checking if the value of a is less than the value of b. Let me see what the result is over here. So I get true because 10 is less than 20. Now let me check if a is greater than b. So again, let me click on run over here. And I get a false value because 10 is not greater than 20. Now let me go ahead and check if 10 is actually equal to 20. So this time I'd have to use the double equal to operator, which helps me to understand if the operands on the left and the right side of the symbol are equal or not. Again, I'll get a false value because 10 and 20 are not equal. Now I will check if A is not equal to B. So this is the not equal to operator. Exclamation mark and equal to operator, that gives you the not equal to operator over here. And we have a true result because 10 is not equal to 20. So these were the relational operators. Now let's go ahead and work with the logical operators. So I'll add a comment over here, logical operators, and let me just put in what are the logical operators. So we've got and, or. Now the and operator gives you a true result only when both the operands are true. While when it comes to the or operator, it gives you a true result when either of the operands is true. So let's work with some examples. Now I'll go ahead and create two Boolean values over here. I'll have Boolean A and I'll store the value of true inside this. And then I will also have Boolean B and I'll store the value of false inside it. So I've got two Boolean values over here. Let me also put an exclamation mark over here. Right. So I've got true and false. Now I will type in A and B. Let's see what do we get. So over here, this actually has to be and. So you will put in the and operator over here. Now let me click on run. So we get a false value because we have true and false, and true and false gives you a false value. Now let me change this to B and A. So when I put in B and A, again I get a false value because one of them is false. Now let me put in A and A. So when I have A and A, I finally get a true value because both of them are true. Now let me change this to B and B. So guys, what do you think would be the result over here? So obviously it's false because both of them are false. Now let's work with the or operator. So I'll type in A or A. So this is the or operator over here. So you give the pipe symbol, that is the or operator. You have a true result because both of the operands are true. Now let me change this to A or B. Again, you have a true value because if one of them is true, the result would be true. Similarly, I'll change this to B. I will change this to A. And when I click on run, again, you have a true value. And finally, let me change this to B or B. So this is the only case where you have a false result. So summing it up, when you're working with the AND operator, you get a true result only when both of the operands are true. While on the contrary, when you're working with the OR operator, you get a true result when either of the operands is true. Now let's go ahead and understand what exactly are arrays in Java. So simply put, arrays help us to store multiple elements of the same data type. So till now we were working with variables, and when it came to variables, the major limitation was you could store only one element or one value in a variable. But there are a lot of situations in real life where you'd have to store multiple elements in the same storage space. Now, let's say you want to store the names of all of the students present in a class. So what would you do? Would you actually create one individual variable for all the students? Now let's say there are 100 students present in the class. So if there are 100 students, then you'd have to create 100 variables for all of the students and store their names. Now let's say if you also have to store their marks, then you'd have to create 100 more variables to store the marks of all of these students. Now, the better situation over here is to actually use an array. So over here, instead of creating 100 new variables, what we'll do is we'll create one array which can store 100 names, all of the 100 names of the students. Now it has to be kept in mind over here that an array can store elements of the same data type. So you can't store one character value and one integer value in the same array, or one logical value and one string value in the same array. So you have to make sure that all of the elements whichever are stored in the array, they are of the same type. And this is the example of an array. So we've got an array over here whose size is 9. And the indexing in an array starts with number 0. So this goes from 0 to 7. So there are actually the size of the array is 7 over here. So this goes from 0 to 6. So 1, 2, 3, 4, 5, 6 and 7. So the size of this array is 7 and the indexing over here starts from 0. Now this is the basic idea behind an array. So array can store multiple elements of the same data type and the indexing of an array starts with 0. So now that we know that, let's go ahead and create some arrays in Java. So this would be the syntax to create an array. So first you will give in the data type of the array. So over here I want to create a character type array. So I'll type in char and then I'll give in the square braces. After that I'll give in the name of the array. And I'd have to allocate memory to this. Now I want 5 elements of the same type in this array. So I'll give in new char 5. So what I'm basically doing is I am creating a new character array with the size 5, or basically 5 elements of character type can be stored in this array named as A. Now once I do that, I can go ahead and assign the values to each of these individual indexes. So at A0 I'm storing A. A1 B is stored, A2 C is stored, A3 D is stored and A4 E is stored. So you have to keep in mind that since the indexing starts from 0, so if there are 5 elements, then you can only store up to index number 4, because again I'll repeat it, the indexing starts at 0. So this is how you'll store the arrays in Java. So now that we know how to store arrays, we'll go ahead and print out the values which are present in this array. So to print out the values, you would need this for loop. And since there are 5 elements in this array, the variable I inside this for loop will start at 0 and will go on till 5. So again over here 5 is exclusive. This would mean that I's value will go from 0 to 4. Now we'll go inside this for loop, the body of the for loop, and we'll print out A of I. This would mean A0, A1, A2, A3 and A4. So initially when I's value is 0, we'll print out A0, that is A. Now I's value is incremented, it becomes 1 and we'll print out A1. So we'll print out B. Similarly, I's value is incremented, it becomes 2 and then we'll print out A2, which is C. And then in the similar way, we'll print out A3 and A4 as well. So let's go ahead and work with this example in Eclipse. So our first task would be to create this character array. So it is actually char. I'll give in the square braces over here. I will name my array as A and I will allocate it memory. So this will be new character, and inside the parenthesis over here, I want a array which would store 5 characters. Right. So I have created this array successfully. Now it's time to store values inside this array. So the indexing starts from 0. So in A0, I will store A. Now what I'll do is I'll just do Control C, Control V so that I can just change these values. Right. So in A1, I am storing B. In A2, I am storing C. In A3, I am storing D. And in A4, I am storing E. So I've also assigned values inside the indexes of these arrays. Now it's time to finally print out all of the values, and to print out the values we've already seen that we need a for loop. So over here I'll set for int I is equal to 0 and this would be less than 5. So this will go from 0, 1, 2, 3 and 4, I plus plus, and then I'd have to print out the value. So this will be system.out.println and I'd have to print out A of I over here. Let's execute this and let's see what is the result. So we have successfully created an array and we have also printed out the values which were present in this array. Now let's go ahead and create another array where we are also inserting the values inside this array with the for loop. So over here we have an integer array with the size 10. That would mean that this will store 10 integer values and I's value will go from 0 to 9. So we actually seem to have the syntax incorrect over here. Since this is an array of size 10, we will set I to go on till 10 over here. And then what we'll do inside this loop over here is we will assign in AI. So AI is the value which gets stored in the index I, and we'll store I over here. So at 0th index we'll store 0 and I is incremented. Now at index 1 we'll store 1. Similarly at index 2 we'll store 2. At index 3 we'll store 3. So this is how we'll store all of the values, and once the values are stored, we'll go ahead and print out the values. Now let's go ahead and create that integer array over here. So this will be int, and again I'll name this array as A. So new int, and I am assigning the size of 10 over here. So now that this is done, I'd have to insert the values through this for loop. So over here int I would be equal to 0. And the value will be less than 10, and I'd have to increment this. So now that those 3 parameters are set inside the for loop, I'd have to go ahead and insert the values inside array A. So this will be A of I, and inside A of I, I'll just store I. So we have successfully inserted the values. Now it's time to print out the values. So again, for int I is equal to 0, I is less than 10, and this will be I plus plus. Now I'd have to print out the values. So this will be system.out.println, and this will be A of I. So this is how I can print out all of the values. I'll hit execute and let's see what is the result right now. So we have created a new array, and in that new array we had stored the values from 0 to 9, and we have also printed out the result. Right. So let me close this up over here, and let me go to the console. Now let's look at a very popular example when it comes to arrays in Java. So let's say we have 2 arrays over here. Let's call this array A, let's call this array B, and we've got these values stored inside these 2 arrays. So 0, 1, 2, 3 and 4 are stored in array A. 5, 6, 7, 8, 9 have been stored in array B. Now what we'd have to do is we'd have to add the individual values present in the indexes. So we'd have to add these 2 values present at index 0, and we'd have to store it in a new array. Similarly, we'd have to add these 2 values, store it over here. Add these 2, store it over here. So let's go ahead and perform this. So to perform that, we would need 3 arrays. Let me start off by creating my first array, int A, and over here I will set the size to be equal to 5. We've got array A to be ready. I'd have to give in new over here. So guys, you have to remember that if you don't give new, you'll get an error. So we've got our first array set. Now let me go ahead and create the second array. I'll name it as B. This will be new int, and the size of this array is 5 again. Now I'll go ahead and create array C. Int C is equal to new int 5. So we've got our 3 arrays set. Now let me go ahead and insert the values into array A. So I'll start the for loop over here for int I is equal to 0. I will go up to 5, where 5 is exclusive. That would mean I's value would be 0, 1, 2, 3 and 4. And I will increment it over here. So I'll just type in I plus plus. So now that this is done, I'd have to insert the values. So inside AI, I'll just go ahead and assign the value of I. So we've got our first array to be set. Now let me go ahead and insert values into the second array. So again, it will be the same thing. For int I is equal to 0, I is less than 5, I plus plus. Now once I go inside this, I'd have to assign values. But for this, I'd have to have another integer variable which is initialized to 5. Because the values inside the new array would start at 5 and will go on till 9. So what we'll do inside this is, we've got B over here. So in B of I am assigning num. And I will increment the value of num after each assignment. So in B0 we'll have 5, in B1 we'll have 6, in B7 we'll have 7. So this is how it will keep on going on, right? So now that we have also inserted the values in array A and array B, let me go ahead and print out the values of array A and array B. So again, I would need a for loop for that. So let me just copy this for loop. I don't want to write the entire thing over here. And before this, I'll just put in system.out.println. I'll add values of array A. Let me make it capital. And over here, I'll add another system.out.print statement. So this is, keep in mind, I'm adding a print statement, not println statement over here. And I'll be printing out A of I. So these are the initial values of array A. Now similarly, I'd have to print out the values of array B. So over here, system.out.println values of array B, and this would be B of I. So we've got the original values printed out. Now it's time to add the values of A and B. So I'll have a new for loop over here for int I is equal to 0, I is less than 5, and it will be I plus plus. Now we've got our new array created over there. So let's go ahead and add the values inside this new array. So this will become C of I is equal to A of I plus of B of I. So let me just add in B of I over here. We've got our new array as well. Now it's time to just print out our final array, which is the result. Let me copy this and paste it over here. So values of array C. Let me also just add a space over here so that it's easy for us to understand this. So a plus symbol and then a space. So we can't have a comma over here. That has to be a plus symbol. And similarly, I'll add a plus symbol over here and then I'll add a space. And that is what I'll do over here. This has to be array C, a plus symbol and then a space. So let me print this out and let's see what is the result now. Right, so we've got values of array A, which is 0, 1, 2, 3, and 4. So we've got a new line over there which has to be removed. So let's just correct this properly. So we have values of array A, and this I'll remove the println from over here. Now after this is done, let me hit enter and let's see what do we get. So we have values of array A, and after 0, 1, 2, 3, and 4, I would need, so this wouldn't be a println over here. I would have to add a new line over here and I'll execute this. So we've got this ready as well, and values of array C, I'd have to put in a new line over here which will be /n, and I'll also remove this. Now I'll hit run. So we've got all of this set. So initially we had created two arrays A and B. In A we had 0, 1, 2, 3 and 4, and in array B we had 5, 6, 7, 8, 9. And we had created another array C, and with the help of the for loop we have added these two values. So 5 plus 0 gives us 5, 6 plus 1 gives us 7, 7 plus 2 gives us 9, 8 plus 3 gives us 11, and 9 plus 4 gives us 13. Now if this seems confusing to you, I'll just go ahead and repeat the entire thing, whatever we've done over here. So we started off by creating or initializing three arrays over here, A, B, and C. Now after initializing these three arrays, I went ahead and added values inside array A. So inside array A, I've added 0, 1, 2, 3, and 4. After that, I have added values inside array B. So inside array B, I've added 5, 6, 7, 8, 9. Now that was done. I had printed out the initial values of array A and array B. So after printing out initial values of array A and array B, I created another for loop, and inside this for loop I have added the individual values of array A and array B and stored them into the indexes of array C. So AI plus BI, what you see is this will add the individual indexes values of array A and array B and store it to the corresponding index value of C. And once that was done, I have finally printed out the result of array C. So that was a single dimensional array. Now let's understand what is a multi-dimensional array and how can we create multi-dimensional arrays in Java. So in a single dimensional array, as the name states, it was in a single dimension. So you did not have rows and columns in it. But in a multi-dimensional array, you would have rows and columns. So as you see, this is a multi-dimensional array and you have rows over here and columns over here. So this cell over here, now let's say if the name of the array is A, this value would be present at A00. Similarly, if you take this would be present at A11. And if you take this, so this value would be present at A12. So this is how we can work with multi-dimensional arrays. Now let's see how can we create a multi-dimensional array in Java. So this would be the syntax to create a multi-dimensional array. So the name of the array is A, and over here, as you see, we are adding two parentheses or two square braces over here because this is a two-dimensional array. And new int 3, 3. This would mean we are creating a 3 cross 3 matrix. And over here, I'll start the for loop, and inside the for loop, I'll add another for loop. So this is the outer for loop. This is the inner for loop. The outer for loop over here, initially i's value is 0. Now when i's value is 0, we'll head inside the inner for loop. Now j's value will go from 0, 1 and 2. Now inside this, we'll add values in A00, A01 and A02. So in A00, we'll add 1 and plus num. So num gets incremented by 1. After that, in A01, we'll add 1. Again, num gets incremented. In A02, we add num. So num's value is 2. Now since j has reached its limit, we'll come out of the inner loop, we'll go to the outer loop and we'll increment the value of I. So now I becomes 1. We'll come inside over here and now we'll start storing values at I10, A11 and A12. Again, we'll go ahead, i's value is incremented, it becomes 2. So this time we'll come inside and now we'll start storing values at A20, A21 and A22. So once we've stored all of the values, we'll go ahead and print out the values. So again, to print out the values, we would need two for loops. This is the outer for loop, this is the inner for loop, and we'll just print out Aij. Now this Aij, after this, so after each row, I'll print out a new line. So initially we'll print out 0, 1, 2, and then there'll be a new line. After that, we will have 3, 4, 5, then we'll have a new line. Then we'll have 6, 7, 8, and then we'll have a new line. So let's go ahead to Eclipse and implement all of this. So let me cut out the earlier code from over here. Let me just go ahead and delete all of this. We would not require this at this point of time. So we have an extra brace over here. We also don't require this. Now it's time to create a multi-dimensional array, int a. So this is a two-dimensional array over here. I will add new int, and again, so I would have one more brace over here. So this is a 3 cross 3 matrix. So I'll add 3, 3 over here. So we have initialized our 3 cross 3 integer matrix. Now it's time to add values inside this multi-dimensional array. So I'll have my outer for loop ready. For int I is equal to 0, I is less than 3, I plus plus. So this is our outer for loop. Now I'd have to create the inner for loop. For int j is equal to 0, j is less than 3, j plus plus. Now I'll enter inside this inner for loop and I'd have to assign the values. So over here, to assign the values, I would need my integer num value. So I will store 0 inside this. Now A, I, comma, J. So initially this will be 0, 0. So in A, 0, 0, I will be storing num, and I will keep on incrementing it after each iteration. So this will be plus plus num. So we have successfully added all of the values inside this array. Now it's time to print out the values. So again, to print out the values, we'd have to do the same thing over here. So I'll type in for int I is equal to 0, I is less than 3, I plus plus. So we've got our outer for loop ready. Now it's time to create the inner for loop. For int j is equal to 0, j is less than 3, and then this will be j plus plus. Now I'll go inside this for loop over here, and then I'll print out the values. So to print out the values, I'll type in system.out.println. So I'll just keep it to be print over here, and this will be a of I, j, and let me add a space over here. So now that this is done, I will go ahead and add a new line over here. So after every row, I will be adding a new line so that we know how the matrix looks like. This over here would be system.out.println. So we are ready with our code. I'll just go ahead and click on execute. So we have successfully created a two-dimensional matrix or a two-dimensional array where we have 3 rows and 3 columns. 0, 1, and 2 is in the first row, 3, 4, 5 in the second row, and 6, 7, 8 is in the third row. Now let's go ahead and understand what are functions. Now, in your day-to-day activities, you would perform a lot of functions, such as eating, running, cycling. So what exactly are you doing over there? Well, let's consider eating. Eating is a function, isn't it? So that's a task which you do every single day. Now, similarly, let's take running. What are you doing? So you're moving your hands and legs. Now, that is a task which your body is doing. Similarly, if you take cycling, that again is a task where multiple parts of your body are moving at the same time, right? So all of these are tasks which you perform in your real life. Now, similarly, there are a lot of functions which you'd want to do in the programming paradigm. So basically, a function when it comes to Java is a specific block of code which performs a specific task. Now, let's say if you're writing a program and there are thousands of lines of code. So to properly understand what these thousands of lines of code is doing, then it'll be very cumbersome. So what you do is you take one specific task, put it into a function, and you can invoke that function whenever you want. So a perfect example for this would be the ATM machines. Now let's say when you go to the ATM machine and you'd want to deposit money, what do? You go ahead and press on the deposit button, right? So when you press on the deposit button, it automatically asks you how much would you want to deposit, and then it updates the balance in your account. Similarly, when you click on the withdraw button, it asks you how much money would you want to withdraw, and then again, it updates it with your balance. And similarly, when you click on the balance button, it would show your balance. So what is happening? Each of these 3 buttons are performing a specific task when you invoke them. And now, let's say if you want to implement this ATM machine in a programming paradigm, how would you do it? So this is where functions would come in. So what you'll do is you'll write one function to deposit money, and that function would have all of the code to, let's say, take money from the person and then update the balance. Similarly, you would create another function called withdraw, which would ask the person how much the person would want to withdraw and then update the balance. Similarly, when you create another function, balance, and then you write all of the code inside it, which would help a person to see the balance which is present in the account. So this is the basic idea behind functions. Now let's go ahead and see how can we create individual functions in Java. So till now, we've been only working with one function, which is the main function. And as I've already told you, the main function, as the name states, is obviously the main function in your Java program. And the starting of the execution and ending of the execution happens at the main function. And whatever functions you create are written separately outside of the main function. and you can invoke all of these functions from inside the main function. Right now, if this sounds confusing again, let's understand these two examples and then implement them in Eclipse. So let's understand what is happening over here. So over here, we've got a function with the name Sparta. Let's understand all of these words properly. So here, Sparta is the name of the function. Void is the return type of the function. Static is the access modifier of the function. And then public tells you what is the access. So whether it is public, private, or something else. And now out of all of these, here it is the name of the function, which you already know. Void is the return type. This means that this function doesn't return anything. Static over here tells the Java compiler that this function can be invoked directly from the main function. You wouldn't need an object of the class to invoke this function. And public over here would mean that any class can publicly invoke this function. And what is happening inside this function? This is just printing out the sentence, this is Sparta. Now over here, if you look inside this function, you see that it is blank. So when you compare this function with the second function, that is the difference between these two. Let's understand the difference. So over here, this is known as a non-parameterized function. This is known as a parameterized function. So over here, the name of the function is add, which is taking two parameters, int1 and int2. You have to keep in mind that if you pass in parameters inside a function, then you would also have to give in the data type of the parameter. So over here, we are passing in two parameters of integer type. And inside the function, we are adding those two parameters. So this is what the function is doing. So let's go to Eclipse and work with both of these functions, and let's understand functions properly. So this is our main function and this is our class. And as I've told you, whatever other functions you would want to create, you would create it outside of the main function, right? So this, what you see, is the body of the main function. And whatever other functions or other methods you would want to create, you will create them outside of the main function in Java. Now let's go ahead and create our first function, which was Sparta. So I would start off by giving the name of the function, which is Sparta, and then I'll give the return type. So the return type of this function is void. Then I will state that this is a static function, which would mean that this function can be directly invoked from the main function without the object of the class. And I'll also set the access to be public. I'll give in parenthesis over here and I will create the body of this function. So we have successfully created the template of this function called as Sparta. Now let me also go ahead and add in the body of this. So inside the body of this function, all I have to do is print in a sentence, and that sentence would be, so this is actually system.out.println, and I'd have to write over here, this is Sparta. So this is known as creation of a method. So now we have created a method. It's time to invoke the method. So we can invoke the method from inside the main class. Now all I have to do is give in the name of the function, which is Sparta, put in the parenthesis and then semicolon. So this is very important, guys. I'm reiterating it. The function, you will create it outside of the main function. So whatever subsidiary functions are there, all of them you will create outside of the main function. But the invoking of the function or the calling of the function, you will do it inside the main function. So let me go ahead and run and let's see the result over here. Right, so we get the result, this is Sparta. Let's understand what is the flow of execution. So first we will enter this main function. Now when we enter this main function, this is the body. And inside the body of this function, the main function would encounter this Sparta function. Now when it encounters this Sparta function, we will go ahead and come over here. Now, so this is basically redirecting to it. So this is known as calling a function. So from inside the main function, I am calling another function called as Sparta, and I come over here. And from over here, I'll go to the body of this function and I'll print out this is Sparta. Right? So guys, this was a simple example of how to create a function. Now let's go ahead and create a second function, which was a parameterized function. So just for practice for you guys, I'll delete all of this and I'll create the new function. So the name of the new function is void. Again, this does not return anything. So I'll add void over here, void add, and this again is a static function. So I'll add static over here, and this also is a public function. So public static void add, which is the name of the function, and inside this there'll be two parameters. So the first parameter is integer a, and the second parameter is integer b. And I have created the body of this. Inside this, let me just add in the print statement, which will be system.out.println, and this is printing out a plus b. So till here it's fine. Now a and b, these parameters, the question which needs to arise in your mind is, how are we going to pass in these parameters into this function called as add? So what we'll do is, inside the main function, we will invoke the function add, which is over here, and we'll pass in the values inside this add function. Now, to pass in the functions, we already basically need to have some integer values. So let's go ahead and create those integer values. So I'll type in int a equal to 10. Let me go ahead and create the second integer value. So this will be int b is equal to 20. So I've got my two integer values over here, a and b. Now let me pass in a comma b over here. Now let me hit execute and let's see what the result is. Right, so we get the result 30. Now let's understand the flow of execution over here. So we'll enter the main function because the program execution starts from the main function. So we'll enter the main function, and inside the main function we'll initialize the variables a and b. So a is initialized to the value 10 and b is initialized to the value 20, and we'll pass in both of these parameters inside the add function. Now when we invoke this function add, we go over here, and these two values are passed inside this. So this value, so the first parameter 10 goes into this. Similarly, the second value 20, which is stored over here, goes into this. So this is how we are transferring the values from the main function to the add function over here. Now once we pass in this values, we have 10 and 20 stored inside the local variables of this add function. And what we do is we just add up 10 and 20 because 10 is stored in a and 20 is stored in b. And when we add these two values, the result which we get is 30. So this is how we have created a subsidiary function called add, and we have invoked that function from the main function. So those were functions without any return values. So for them, the return value was void. So now we'll go ahead and create a new function which actually returns a value, and it is not a static function. So guys, can you have a look at this function over here? So here the name of the function is add, which is same. Again, this takes in two parameters which are num1 and num2. So this takes in two integer parameters. But these two which you see over here, these are different from our earlier functions. So this time the return type is int instead of void. So now in the earlier two functions, when the return type was void, that basically means that the function did not have to return anything. But over here, this add function has to return an integer value. And this again is of public type. And since we have not given the static value over here, this would mean that if we have to invoke this function from inside the main function, then we'd have to create an object of our class. So if it's clear till now, then let's understand what is happening inside the body of this add function. So this is the return type of int. We have two parameters, num1 and num2. Now instead of just printing out num1 plus num2, what we do over here is we'll add num1 plus num2. We'll store the result in this new object called as result, and we'll return out this variable named as result. So as you see, this is an integer variable, and that is what we are returning over here. Now this is being returned. So let's understand what is happening in this main function over here. So the execution starts over here. Now inside this, we will create an object of our class, and this is how we can create an object of our class. So the name of our class is test project. So we'll type in test project, and this is how we can create a new instance or a new object of our class. So given the name of the class, space, and then given the name of the object or the name of the instance. So over here, this is the name of our object, and that is obj. And we'll give an equal to, we'll add new test project. So this means that we are basically creating a new object or a new instance of the class test project, and we are storing it in this variable called as obj. So I'll repeat it. We are creating a new object or a new instance of the test project class, and we are storing it in this variable named as obj, right? So we have successfully created our object of this class with the name obj. After that, since we have to pass in parameters inside this function, we'll create in two values which are 10 and 20. So the value 10 has been assigned to x and the value 20 has been assigned to y. Now after this, we invoke the function add. And since this is not a static function, we'll have to invoke this function with the help of this object. So now the name of the object is obj. So we'll type in obj.add, and we'll pass in these two values which are x and y. So obj.add, and we pass in x and y, and we'll store this result in a new object called as getResult. Now before going there, let's understand what is happening over here. Now when I call this function with the help of this instance, so when I type in obj.add and I pass in x and y, this directly redirects to over here. So I am calling this function. When I call this function, my Java compiler redirects me over here. So x, the value which is stored in x, 10.1 gets stored in num1. Similarly, the value which is stored in 20 over here, y, this value gets stored in num2. So that is why we have 10 in num1 and 20 in num2. And when we add 10 plus 20, we get the value of 30, which gets stored in result. And then we return result, which is actually 30. So whatever is happening inside this, the final value returned by this function is 30, right? So this, when everything is done, it will give out the value 30, which is stored in this getResult object. And that is what we are printing out over here. So system.out.println getResult, and the value 30 is stored in this getResult object. So now, if this is still confusing, let's go to Eclipse as we always do, and let's implement this over there. So let me go ahead and delete this out over here. Let me also cut this out over here. Now my task would be to create this new function. So this is a public function, and this is actually returning an integer value. So it will be public int add, and it takes in two parameters. So the first parameter is int a, and the second parameter is int b. So I've got my two values set over here. And what I'll do now is I will create a new variable named as result, which will have the added values of a and b. And I'd finally have to return the value which is stored in result. So I've successfully returned this value. Now it's time to invoke this function. And to invoke this function, we need an object of this. So I'll give in the name of the class, which is test project, and let me create the instance which is obj. So here I'd have to type new. This will be test project again. So I have successfully created the instance of this test project class. And after that, I will type in obj, and with the help of this, I'd have to invoke the add method. And since we have to pass in values inside this add method, let me go ahead and create some values. So let's say in x, I would store the value of 10, and similarly in y, I would store the value of 20. So I've got these two values stored, and I will pass in x over here and y over here. So x gets stored in a, y gets stored in b, and we'll get a final result. So that final result I'll be storing in int get result. So all of this is done. Now the only thing which I'd have to do is print out the result. So I'll type in system.out.println, and I'd have to print out get result over here. I'll put a semicolon. Now let me actually just change these values. So I'll set X as 100 and Y as 200. Now let's see what is our new result over here. So we see that our new result is 300. So this is how we can create a function with a return value. Now there's this very famous example when it comes to methods in Java, which is known as a swap function. So what we do in this is we take in two values and swap the values which were earlier present in the two variables. So let's say we have two variables named A and B, and 10 was stored in A and 20 was stored in B. Now our task is to swap the values. So this is swap the values, then 20 needs to go into A and 10 needs to go into B. Right? So whatever is present in A should go into B, and whatever is present in B should go into A. So this is the function for it. So we'll give the name of the function as swap function. So this is totally dependent on you. You can give the name whatever you want. And once this is done, you'll go inside the body over here and you're typing out or printing out before swapping A equals A and B equals B. So basically you're showing what were the initial values of A and B. So this plus symbol is basically to differentiate whatever is there as a string and whatever is a variable over here. So this is a string. So you're typing out before swapping A equals A. And then you'll type out B equals B. So over here you'll get the value which is stored in A, and over here you'll get the value which is stored in B. So here you're basically showing the values which are there before swapping. And once you're done with that, you will go ahead and take the value which was stored in A and store it back into C over here. So let's say the value which was stored in A is 10. Then you'll take 10 and store it into C. So now C has the value 10 in it. Now you'll store the value of B into A. So if 20 was present in B, 20 will go into A. So initially A was 10. Now since I'm assigning B to A, A's value has changed from 10 to 20. After that, I am assigning the value of C to B. And since 10 was present in C, I am taking that 10 and storing it into B. So when you perform this entire action, what is happening is you are changing the value of A from 10 to 20, and you're changing the value of B from 20 to 10. And this is how we swap the values. Now once the swapping is done, all you have to do is show up the result. So over here you're typing out after swapping A equals 20 and B equals 10. So let's go ahead and create this swap function in Eclipse. So let me go ahead and cut this all out from here. Let me also delete this function and let me create a new function over here. So I'll type public and then I'll type in void over here. Now this is also static, so I'll type in static. So public static void, and the name of the function would be swap function. And this takes in two integer values. The first integer value is A and the second integer value is B. I'll have the body over here. Now my first task would be to store the value of A into C. So whatever was stored in A goes into C. Now what I'll do is I'll change the value of A. So whatever was stored in whatever was stored in B goes into A. And after this, I'll take the value of C and store it into B. So this is how we can swap the values. Now, once the swapping is done, I'd have to show the swapped values. So first, I'd have to show the original values. So I'll type in system.out.println. So let me take this original values. So A is equal to A, and I'll add another plus over here to separate the variables from the string. And then B is equal to, I'll add a plus, this will be B again. So A is A and B is B. I'll take the same thing and I'll paste it over here. So we have created this function. Now it's time to invoke it. And to invoke it, we obviously need some values in the main function. So let me take x to be equal to 10 and let me take y to be equal to 20. Now let me go ahead and invoke the function over here. So this will be swap function, and I'd have to pass in x over here as the first parameter and y over here as the second parameter. So I'll just click on run and let's wait for the magic. So as you see, original values 10 and 20. So these are not original values, these are duplicated values or swapped values. So I'll change this as swapped values. Now I'll click on run, and then we have perform magic. So what was stored in A has gone into B, and what was stored in B has gone into A. So A is 10, B is 20, and after swapping values, we've got 20 in A and 10 in B. Now we'll go ahead and understand what is method overloading. So many times it happens in Java that we've got multiple functions, and most of those functions can have the same names. Now, in this case, when you're invoking these multiple functions from the main function, there could be a possibility of ambiguity. So let's understand it with this example over here. So let's say we've got two functions with the name area over here, right? So as you see, we have two functions and the name of both of the functions is area. But what is actually differing over here is the type and the number of parameters inside both of these functions, and also the return type. So in the first function over here, we are finding out the area of a rectangle. And since to find out the area of a rectangle, we need the length and the breadth. So that is why this is taking two parameters. And over here, I am finding out n1 into n2, and then I'm returning it. So also I'm returning an integer value over here. But in the second function, I'm finding out the area of a circle. So the second function takes in only one parameter, and this returns a float value. So as you see over here, 3.14f into n. And since this 3.14 is a floating value, that is why I have added the suffix f after this. So this is how method overloading works. So we have two functions or more than one functions, and these multiple functions would have the same names. But what actually differs is the types and the number of parameters which go into these functions, and also the return type of these functions. Now, when we go ahead and load both of these functions into the main function, what tells the main function that both of these are different is the difference in the parameters and the difference in the return type. So let's go to Eclipse and work with these method overloaded functions. So let me go ahead and delete all of this first. So we would not require the earlier functions. Let me also delete this. Right. So we've got our main function. We've also got the class set over here. Now it's time to create my first function over here, and the name of the function is obviously shape. This is a public function, so I'll type in public, and this will return an integer value, so I'll type in int. And what I'm trying to calculate is the area of a rectangle, so I'll add area over here, and this takes in two parameters. Both of them are integers, by the way, so I'll add int n1, and after this there'll be int n2. So I've got both of these set. Now I'll go ahead and add the body over here. So I'd want to find out the area of a rectangle. So I'll add, so basically the result would go into this variable, and the area of the rectangle is basically length into breadth. So that would be n1 into n2, and I'd have to return this. So return of result. So we have created this first function. Now similarly, let me go ahead and create the second function over here. So again, this is a public function. Now the return type of this is float. And again, the name of the function is area, but this would take in only one parameter, and which would be of integer. So I'll add n over here. And this, since this is of, this is returning a floating type, so I'll add float result over here. So let me just add result, and I will add over here 3.14 into n, because n over here would be the radius of the circle, and the radius And the area of the circle would be pi r square. So this is the value of pi, 3.14, and pi r square. So this would be 3.14 into n. Now we just have to return the result. So I'll add return of result. So we have successfully done this. So seems like there's a problem over here. Let's understand what exactly is it. Right. So this is of floating type. So I'd have to add 3.14f. So both of our methods are ready over here. Now it's time to invoke both of them. So for this, I'd have to have my local variables over here set. So I'll have int x and I'll store the value of 10 inside this. Then I'll have int y and have the value of 20 stored inside this. Now I'll also have the radius of the circle set. So int r, and I want the radius of the circle to be equal to 5. I've got my local variables ready. Now it's time to invoke the function. Now, since this is not a static function, again, I'd have to go ahead and create an object out of this. So I'll type test project over here and I'd have to create an object. So I'll set obj over here and I'd have to create a new class. So new of test project, and I have successfully created an instance of this. Now with the help of this instance, I can invoke both of the areas. So as you see in the prompt, you have two area functions. The first area function takes in only one parameter. The second area function takes in two parameters. Now I'll invoke the first area function over here, and inside this I'll pass r. After this I'll type in obj. Again I have the area function over here. This takes in two parameters. Now I'll add x over here and I'll pass y over here. Right. Now since this gives me the area of the circle, I'll store this in actually a floating type. So float, I'll name this as area circle. And since this gives me an integer type, I'll have an integer type over here. So int, and this would be area of a rectangle. So let me type in rectangle over here. Right. So we've got the results stored in area circle and area rectangle, and I just have to print out the result. I'll type in system.out.println since we want a new line over there. So first I want to print out the area of the circle. So I'll type in, let me just put in properly over here, area of the circle is, and the area of the circle would be area circle. Now similarly, I would want to print out the area of the rectangle. So let me change this from area of the circle is to area of the rectangle is. So this will go from area circle to area rectangle. Now let me go ahead and just print this out and let's see what the result is. So we see that the area of the circle is 78.5 and the area of the rectangle is 200.
Now let me introduce you to what is Java. Although the kids from first standard to a working professional, everybody is aware what a Java is. But still, it's important to know Java is a high-level object-oriented programming language. And this is a programming language using which you can develop the simple to simple applications to a very complex application. Java is not only used as a tool, but also it's a platform. When I say Java is a platform, it means what? It means that Java provides a programming language as well as a virtual environment to develop the programs or the software using that programming language. Also, Java has a huge support of libraries and packages which are widely used in various fields to develop the software. Java is also a very powerful tool. There are different and many IDEs, integrated development environments, which supports Java, and using those integrated development environments, we can develop complex softwares on Java programming language. Recently, Java has celebrated its 25th anniversary. So it has become 25 years in 2021 since the Java was launched, and it is still counting. Not to mention here that Java is a programming language which has its reach in every field, not just a simple standalone application of a desktop or a laptop, but also you can develop applications using Java programming that has reached to Mars. Few of the Java applications is very important to mention here. The first one I would like to mention is JMars. So JMars is a software which was developed for analysis of remote sensing. This is a software which is being used still by NASA to analyze all the planetary data. Next application I would like to mention here is Wikipedia search. So Wikipedia is like an encyclopedia for the people and by the people, which was developed in Java. That is, the search engine which Wikipedia uses was developed in Java. In 2014, the search engine underlying Wikipedia was developed or was enhanced, and that is using Elasticsearch. So Elasticsearch is also a distributed RESTful application of Java. Next application I would like to mention here is from the gaming field, that is Minecraft. So Minecraft is a video game which is developed for kids and adults, and it is quite famous among them because of its creative universe offered to the players. SmartThings. SmartThings is an application which is developed in the field of Internet of Things. So using SmartThings, just through your laptop or your desktop, you can control everything in the house. Starting from the lights and fans in the house to the locks, as well as all other security options available in the house can be controlled using this application SmartThings, which is developed in Java. So you can see here that from your house to the other planet, from a simple application to a distributed application, from the field of mathematics to the field of machine learning and artificial intelligence, Java has its application everywhere. Let's try to understand that now. Now I'll talk about introduction to a class. So what is a class? How is it defined inside Java program? So class is a user-defined data type. For storing various primitive data, there are already defined primitive data types in Java programming. For example, to define a number, there is a int primitive data type. To define alphabets, there is char primitive data type. Similarly, to define decimal numbers, there is float primitive data type. So class here is used to define a user-defined data types. Let's try to understand this with the help of example. Whenever I say guava, apple are fruits, are a type of a fruit, or in other terms I could say guava, apple, banana, grapes belongs to a class of fruit. So what is a class here? Fruit. And apple, banana, grapes, guava are all objects of that class fruit, right? Now, every class will have a certain property and a certain behavior. The example which we took right now, let's talk about that. So when I talk about a fixed behavior of a class, that is of a fruit, so what behavior it can have? That is, it grows from a seed to a fruit. So this behavior will be performed by or will be possessed by every object that belongs to that class. For example, apple belongs to a class of fruit, so it will also have that behavior of growing from a seed to a fruit. Okay. Similarly, every class will have certain properties defined. Properties meaning, for example, of a fruit, there can be a property that the fruit is eatable. No, a person can eat that. So that's a property. So every object of that fruit will have that property. For example, apple, banana, guava, all are eatables. So all belong to a class of fruits, right? So now with this example, it's very clear that every class will have a behavior and a property, which will be possessed by every object that belongs to that class. Okay. So whenever I have to convert this example of fruits and its objects into programming, I will be using a concept of class to define this user-defined data type that is a fruit. So I can define classes in other terms also, like it is a process of binding the methods and data members together into a single unit. In Java, none of the implementation is possible without the help of classes. Any method definition or declaration, any variable definition or declaration is not possible outside a class. It has to be mandatorily inside a class. Let us talk about requirement of a class. What's the need of defining a class, or what is the usefulness of a class inside Java programming? Let's try to understand this with the help of an example. So when I say a car, that is Maruti 800, is of a type car. WagonR is of a type car. Or I-10 belongs to the class of cars. So car is what here? A user-defined type. And all the examples which I gave for a car, that is Maruti 800, WagonR, I-10, these all are objects of that class car. Another example I'll take. Banana, apple, grapes are all of type fruit. These all belongs to a class of fruit. So what is a fruit here? A user-defined type. And what are all these apple, banana, guava? These are objects of that user-defined type fruits. So similarly, there can be multiple user-defined types. If you look around you or in the entire world, there can be multiple millions and billions of these user-defined types, right? So is it possible for any programming language to provide an inbuilt user-defined type for every kind of an object or every type of a class which is possible in the world? No, it's not possible. For any programming language, it's not possible. So what can be done is a support for creating a user-defined type can be given. And Java provides the support of creating a user-defined type by giving the concept of classes. So that's the basic requirement of a class, to define the user-defined data types or convert these user-defined types into a data type when it comes to programming. Programmatically also, classes helps us in many ways. That is, it eases the enhancement. Let's try to understand this with the help of an example. Suppose I have created a class here, car. Okay. There are some properties of this class car defined, that is, color of the cars. So initially, two colors are defined, black and white. Now suppose there are multiple objects created for this class car. Objects and as in Maruti 800, WagonR, I-10, I-20. Later on, after some point of time, the car company introduced a third color for all these cars. Apart from black and white, there's a third color introduced, suppose blue. Okay. So if there would not be a concept of class, then what you would need to do? You have to go and add to this object the third color, that is blue. So black, white, and then blue. Then go to the WagonR object and add the third color blue. Then go to I-10, go to I-20. Individually to every object, you have to add the third color, that is blue. But as we are lucky enough to have a concept of classes in Java, so we have defined a class car here. Okay. Now, if the company wants to introduce a third color, that is blue, in this class itself, you can add one more property here, black, white, and blue. Automatically, all these objects will be binded with these properties. That is the third property newly added, that is blue color. You need not go to every object individually and add this color there. That's what I said right now, that enhancement becomes easy. Just a change at one place, automatically all the objects which are binded to this class will inherit or will be utilizing these changed properties. So that's one of the use of classes when it comes to programming. Also, maintainability and modularity gets improved with the help of classes. Maintainability meaning, as I gave this example right now, that When you have to add a third color to all the cars available here, you just have to go and add a third property of color that is blue inside this class, and automatically these objects will get that color that is blue. This is called maintainability as well. Later on, after 10 years, after 15 years of developing any project, if something needs to be added, this modular approach meaning all the concepts are defined inside one module, and a change to that module brings a change to the entire objects, brings a change to the entire project. And that's what classes does here. It improves the maintainability and modularity of the code, of the project, of the software. Let's talk about the elements of a class. That is, what a class is composed of, what it consists of. So broadly speaking, classes consist of methods and variables, that is, behaviors and attributes. So a class will have a blueprint of the object, what object properties are going to be, what is going to be the behavior of that object will all be defined inside a class. So that's what class consists of: a method, which is also a behavior, and it consists of variables and attributes. So behavior is nothing but the action or the task that is going to be performed by the object. And variables and attributes is nothing but the data members that an object consists of. Let's try to understand this with the help of an example. Maruti 800, Wagoner, i10, i20 are all of type car. So car is nothing but a class here. Maruti 800, i10, Wagoner are nothing but objects here. Okay. Now, inside the class, we'll define a behavior, an action that will be performed by these objects, that is, these cars, i10, Wagoner, Maruti 800, etc. What it can be, for example, let's have a behavior that is possessed by a car is we can drive a car. So drive is a behavior, is an action. Okay. Similarly, properties. So properties can be that the color of the car, the color that is black and color that is white becomes a property of those objects. Okay, so classes consist of these behaviors, the actions of the task, and these data members. Before defining any object, we design a class, because class is a blueprint for the objects. So once a class is designed, it is represented with the help of UML diagrams under UML design diagram concepts, which helps to define or design very clearly what a class consists of. Let's talk about how can we define a class in Java. That is, what is the syntax that is followed for defining a class. So following is the syntax followed. That is, we'll use a keyword class without changing the spelling. As I said, it is a keyword. So keyword are those words which is predefined in Java, which have a special meaning in Java programming. So class is a keyword. Without changing the spelling, you have to use CLASS. After that, a space, and then the name of the class. These angular brackets are not to be used. These are just for representation purpose. Then inside a curly bracket. So everything that this class will consist of should be enclosed inside these curly brackets. And what does a class consist of? All the methods and the variables. So all the method declarations and variable definitions should be given inside these curly brackets, which represents the complete class. Let's see this with the help of example. So I'll define a class car here, and we'll define its property, that is the color, and define its behavior, that is we can drive a car. So how we can do it in Java programming? We'll use a keyword class CLASS without changing the spelling. Then there will be a space and then name of the class. For this example, I'm taking the name to be car. Then curly brackets will be open, and at the end curly brackets will be closed. Here I'll have properties and behavior declarations, that is methods and variables declaration, because behavior is represented with the help of methods in programming and properties are represented with the help of variables in programming. So for a class car, suppose the property is color. So I'll define a string type color, okay, which is a property. Then I'll define a method that is drive. Okay. Other concepts like the implementation for this method, the other codes and blocks, all these has to be included inside this class. But importantly, these two, that is methods and properties, has to be defined inside a class. Now let's try to understand how is memory allocation done for the classes in Java. So classes have logical existence. They don't have physical existence in Java programming. What is the meaning of this? Try to understand this with the help of an example. When we define a class, now we know how to define a class. So class keyword, the name of the class, for example, car over here, and then define the property that is the color of the car over here, and we'll define the behavior that is we can drive a car. So till now, when you have defined a class car, there won't be any memory space allocated to this class. So when will the memory space be allocated to the class? When we create object of that class. How to create an object? The name of the class and then the name of the object. Name of the class, that is car, space, name of the object. You can give any name here, suppose C1 equals to new keyword. So new is again a keyword in Java programming, so it has to be used as it is. And then the name of the class. This is also called as the constructor for a class. End it with semicolon. So now C1 is an object for class car. If I take a realistic example, car, and I'll say I10 is equals to new, the constructor for the car. I10 is nothing but an object here for a class car. Now, when this object is created, then there will be memory allocation done for this class. That is, how will the memory look like? I10 will be pointing to a memory space, okay, which will consist of all the properties. So here only one property is defined, right? That is, one variable is defined, string color. So there will be only one property, that is color. So as it is of type string, so whatever memory space is required for a string will be allocated. So now after declaring or defining an object, that is I10, the memory space is allocated for this I10. So classes have logical existence. They do not have a physical existence. That is, memory space is not allocated as soon as you define a class. But when objects are defined, the memory space is allocated to it.
So basically, we are going to understand in this topic that what is actually interface. Now, to understand interface, we have to understand some of the pointers that I have noted down in this particular slide. So let's read it through and understand that what are the pointers written inside it. So the first one is interface is similar to class. Now, the beginners who are watching this video, there must be a prerequisite for you. That is nothing but you should understand what is class and object, right? Now, interface is basically similar to a class, right? How do you write a class in Java programming language? The same way we write the interface. An interface can have methods and variables. As I said, class is also having methods and variables. So does interface. Interfaces are the blueprint of the class. It specifies what a class must do and not how. Now, this particular point you should be keeping in your mind for right now. That means interfaces basically specifies what a class must do. And it is not telling that how you should do it. It is just saying that what a class must do. What is the meaning of it? Why we are writing this statement here? We'll understand when we'll write the program. So keep this statement in your mind. We will understand it once you will write the program on interface. The next one. Now here comes the major point of interface. The most important point of interface, which is an interface is a fully abstract class. Now, if you don't know what is abstract class, don't worry. Just in a minute, I'm going to tell you what is abstract class. But for a brief, I'm just going to tell you that abstract class are those classes in which some of the methods are defined and some of the methods are not defined. Okay, so that is what an abstract class means. An interface is a fully abstract class. That means interfaces are having all the methods as abstract. Now, this point you have to keep in your mind. I know that we are just reading the theory right now, but these theory things are important so that you can understand the practical program also. The next statement says the method declared in an interface are by default abstract. So all the methods declared in an interface are by default abstract. That means there'll be only the method signature and there'll be no body. That means that it will be only declared. There'll be no definition for any of the methods in an interface. So we have understood here some of the points. The next, another way to achieve abstraction in Java is with interface, right? Next, an interface is completely an abstract class that is used to group related methods with empty bodies. Now, if you look here, these 4 points are telling the same thing, right? Just in different statements. What is it? The thing is that an interface, suppose if this is an interface, inside this interface, whatever method you will write, these all methods will be and must be abstract. These all methods should be abstract. There should not be even one single method which is properly defined. All the methods should be not defined, only declared. So all these 4 pointers are telling the same thing, that interface is a fully abstract class. Now let's jump to the practical and understand that what is this abstraction. So if you look at an abstraction example, let's take a real world example and understand what is this abstraction. So if I talk about a TV, right, a television. Now, if I'm a small child and my father is telling it to me that, hey, I have bought a TV. Do you know how to use it? Obviously, if I'm a small child, I won't be able to know what is this TV, right? I must be only knowing the start on off button, correct? Only that much. So if I have a class television, I don't know how this volume works, so I have not defined that method. I don't know how the thumb scanner works in a television, so I have not defined that. I don't know how the camera works in a smart TV, so I have not defined that. But I do know how to switch on or switch off the television. So that I have defined here. So that method I have defined. Now the methods which you have not defined are abstract, and that is why we have written here abstract keyword. But in the start on of method, we have not written the keyword abstract. Obviously, because we have defined it, right? Now, the rule says of abstraction that if one of the method is abstract, that means your class also becomes abstract. And that is why in class also it's written abstract. Perfect. So that means abstraction is nothing but when you have some methods which is defined and some methods which are not defined. Those classes will be abstract classes. So now this particular abstract class, we cannot create an object of it. Why can't we create an object of it? Because all the details are not provided about this class. If all the details are not provided of this class, constructor cannot be used here. If constructor cannot be used, the new keyword cannot be used. If the new keyword cannot be used, an object cannot be created. That is the reason we have to use a class which will inherit some properties, not some, basically all the properties from this abstract class. And whatever method is not defined in the abstract class, those all methods will be defined in this class. So volume will be defined, then here the thumb scanner will be defined, then here the camera will be defined. So now we have a class, a proper class where all the methods are now defined, right? So now we can create a main method and we can create an object of that class. Now we are not creating an object of the television abstract class. Obviously, because we can't create an object of abstract class, right? So we are creating an object of the class smart TV, and using that we are calling the function volume and camera. So volume we have written here, so it will print I know how to increment, decrement the volume. And for camera also this I'll be written here. So it will say I know how to use the camera option in Smart TV. Right? So this is how abstraction works. But our video, this one is not related to abstraction. This is related to interface. Then why am I teaching abstraction? Because once you know the concept of abstraction, it will be very easy for you to understand interface, because interfaces are nothing but abstract class, right? So have a look. Now interface program, have a look what I have done. We have seen the 4 pointers and we have understood that interface basically contains all the abstract methods. That means there will not be any one method which will be defined. All the methods will be only declared. They will not be defined. So you'll have interface television. Start on off, I don't know. My dad is bringing me a TV. I don't know what the hell is that. I don't know what is it, right? I don't know any button. I can't see any button. It's just a black screen. So I don't know what is it. I don't know anything about it. Start on off, I don't know. Volume, I don't know. Camera, I don't know. So in this particular class, I don't know anything, and that is why these all methods are abstract. And that is why this class becomes interface. So it's very easy, guys. In abstraction, remember this particular sentence which I'm going to say and keep it noted if you have a notebook and a pen in your hand. So in abstraction, we have the methods defined and declared, and some of the methods only declared, not defined. The methods which are not defined will become abstract methods. And if there is at least one abstract method in the class becomes abstract class. When it comes to interface, a class becomes an interface if all the methods of that class are abstract methods. All the methods. So this is what is the situation. Now we have to create a class Smart TV which will implement television. Now what is this word implement? We will see later on. Void start on off, we have declared it here. Then volume, we have declared it here. Obviously the camera also we have to declare it here, right? Now once everything is declared and defined in the class, we can create an object of this class and we can call some of the functions which I want to call. So this is my whole program of interface. But is that it? We have understood what is interface and that's it? No, right? We have just now understand that what is interface. That's a very small thing. We have a lot more to do in this particular video. So now let's see, why do we use interface? What is the reason behind it? The 3 main reasons why do we need interface are, it is used to achieve abstraction, which I have shown you, right? You guys must have understood that yes, interface is used to achieve abstraction. But the question here is, if abstraction is already there, then why do we need interface? Good question, right? If abstraction is already there, if same concept is already there, then why come this interface is covering, right? We will see and we will answer that question for you as well. The next main reason is nothing but to support the functionality of multiple inheritance. Now, if you guys know and have learned about the basic concepts of Java, you must be knowing that multiple inheritance concept cannot be achievable in Java programming language. But using interface, you can do that. Do you want to know how? Just stick to this video. The last topic we are going to cover and we are going to see how multiple inheritance can be achieved using interface. The next main reason is it is used to achieve loose coupling. Okay, perfect. Now is the time that we have to understand the writing syntax of interface, that how do we actually write it. Now here, the main reason of covering this topic is that there are many versions of Java, and in each of the versions, there are some updations related to interface. Let's see one by one what are those updations. So we write the interface keyword in the syntax, and then we write the interface name. The interface name can be anything. Then we write the methods. Now, these methods are by default public abstract. Okay? Because obviously interfaces will have all the methods abstract, right? So even if you don't write the keyword abstract or public, compiler will cover it up. Compiler will tell that this method is public abstract. Okay? Next one, fields. That means data members or variables. So if you're writing that fields, by default, compiler will place public static final in front of your fields. So all the fields in your interface should be public, static, and final. These things you need to remember, guys, because these are some of the, you can say, syntax, which if you will give an error, if you will write here private fields, then obviously your particular program will give an error. Let's see what is the updation happened in Java 8 version. So in Java 8, they have told us that you can actually write the concrete methods also. What is the meaning of concrete method? Concrete methods are those methods which can be defined. Okay. So in abstraction, we can have concrete methods and we can have non-concrete methods, right? In interface, we can only have non-concrete methods, correct? Now it is saying that in Java 8, they have told that you can write concrete methods also. But then what will be the difference between abstraction and interface, right? Here they have mentioned that you can write default concrete method, not public concrete method. So you can write default concrete method where you will use the access modifier of default, but you can't use public, okay? So it's not the same again, right? Abstraction and interface, again, it's not the same. There is a difference. Okay, what next? So in Java 8, they've also told that you can also write static methods. That is also possible. You can write static methods, but public methods, they won't allow. Okay, next, Java 9. Now they have said that private methods also you can mention. So you can write now private access modifiers also, you can use that and you can write the method also. The only thing which you cannot use here is the concrete public methods. You can't define concrete methods here. Okay, perfect. So we have understood the syntax, and now is the time that I need to answer the question that why we use interfaces when we have abstract classes. Now understand this answer very carefully. The reason is abstract classes may contain non-final variables. Abstract classes may contain non-final variables because many abstract classes allow the concrete methods also, and concrete methods can be non-final, right? Whereas variables in interfaces are final, public, and static. All the fields are public, static, and final. Okay, in abstract, we can have non-final variables also. This is the reason. This is the main difference of abstract and interface. The first example will be very simple. Just have a look. So this is just a very simple example where I'm using all the kind of methods, all the kind of variables. Void show, which is undefined. So it's an abstract method. Then we have the public static final int a equal to 20. That means it's the variable, is the field, right? Now focus here that I have written the code like this, but in compiler it will come like this. Compiler will add all the default parts, okay? All default keywords. Then we have the default concrete method, right? It's concrete. Why? Because it is defined. Then we have the static method, right? We are using the static keyword. Then we have the private method, correct? So this is a very basic example of interface. And now we will jump into one of the example where we will be showing how this default method, which was, introduced in Java 8th version, correct? We will see how this example works. So now understand this example very carefully. So I have an interface which is named as place. Now obviously that means all the methods inside this will not be defined. It will be only declared. So, okay, I have one method which is void live, and that is only declared. That means it's an abstract. So public abstract void live. But I have also used here one default method where I've used the default access modifier, and I'm saying that's a message method which says this is the default method. Perfect. I can use this. There's no error. Next, I'm creating a class and I'm inheriting this particular interface. Okay. Now understand that whenever you are inheriting from a class and interface, we use the keyword implements. Okay. And whenever we do it from a class and a class, we use extends keyword, if you remember that, right? But don't worry, in the rules, when we'll come to the rules of interface, we'll again see this concept. So don't worry about that. Okay, now what we are doing is we are writing here. Basically, we are defining our method, which was not defined in the interface. So we did not define live method, right? Now here in this class, we are defining it. That living in Jharkhand, correct? Okay, now is the time that we should create our main method. So in main method, have a look what I'm doing. Place P equal to new Jharkhand. So basically, place P equal to new Jharkhand means P is an object of Jharkhand, right? Now P.live will directly go where? P.live will directly go to the Jharkhand's class, and inside that it will find whether the live method is defined or not. So yes, it is defined and it will print living in Jharkhand. Next is P.message. So P.message, that means it will directly go to again my Jharkhand class. But here the message is not defined. But Jharkhand class is inheriting the properties, all the properties from the place interface. So it will jump from here to interface. Interface, we have the default message, which is this is the default method. So now these both will be printed. This is how you will use an interface example with default method. I hope you guys have understood this. Now let's move to the next example in which we will see the static method example. So again, we have the same interface place. We have the undefined live method, which is public abstract void live. And then we have the static method, the area. Okay, that means the place area. What is the kilometer square space area? Okay, let's see the class. So in the class, we have done the same thing. We have defined our non-defined abstract class, right? We have defined it here. And now is the time for the main section. So in the main class, main method, what we have done, we have created an object of Jharkhand, which is P. Now P.live will directly go to the Jharkhand's class because P is an object of Jharkhand, and thus it will print living in Jharkhand. Next, what we are going to do is we are doing system.out.println place.area. Now see, if you remember about static methods, right, or static keyword, what happens in static keywords? Whenever you use a static keyword, you have to directly access those method or those variables using the class name or the interface name. Okay, you have to directly access those methods which are static by directly using the class name or interface name. So we are doing that. Place, we are directly using the interface name here, dot area 43. So it will directly go from here to place interface, and here it will go to area. In X, it will pass the argument 43. 43 into 43 into 43. You have to calculate that, and that much is the exact area of Jharkhand. Right? So this is how this program will work. So why have I written this example to show you the static method? Because of this particular line. The way it was happening in default method, it is not the same way it happens in static because it's static keyword, right? Static keyword always wants a class name or an interface name directly to be used. Perfect. Now let's jump to the next topic, which is our rules of interface. So now is the time that we are going to see one by one all the different kind of rules which is applied in interface. So when you're writing a program on interface, you have to make sure that these rules are known by you and you know about all these basic rules, right? So let's see the first rule. Like abstract classes, interfaces cannot be used to create objects. In abstract classes, we cannot create objects. Same likewise, in interface also, we cannot create object. That is why in the previous examples, we have used a basic class to inherit all the properties from the interface classes, right? Okay. The next one, a class extends another class. An interface extends another interface, but a class implements an interface. So this particular point is nothing but related to the inheritance. When you're inheriting a class from a different class, we use the word extends. When we inherit interface with an interface, we use the word extends. But when we do it from a class and interface, we use the word implements. And that is what we did in the previous example, correct? Next rule, interface methods do not have a body. This though we know now, right? That interface methods will not have a body. The body is provided in the implemented class. This also we have seen in the previous example, implemented class, that means the down class. So in the down class, all the methods should have the body and must have the body, correct? The next rule, interface methods are by default abstract and public. This we have seen in the syntax, correct? I hope you remember. And interface fields are by default public, static, and final. This also we have seen in the syntax. Next rule, on achieving inheritance on interface, you must override all its method in the class. All the methods. Even if you have 5 to 6 methods which are not defined, which doesn't have the body, you have to define it in the next inherited classes. You have to do it. The next rule, an interface cannot contain a constructor as it cannot be used to create objects. Obviously, because you don't have the total information about your interface or about your abstract class. That means a constructor use is not very much benefit there, right? That means you can't use a constructor, obviously followed by that you can't use new keyword. If you can't use new keyword, that means you can't create an object. Perfect. So these are the rules of interface. Now what? Now let's see some more examples and understand applying these rules, these all rules. So if you look at this example, the first one, the television one, right? Now you must be understanding this whole example that what I have written. So I have a television interface in which I don't know anything about it. So all the methods are just declared. These are not defined. All the methods are having only the structure, not the body. So you have understood the rules, right? The next, that your class should implement the interface. So another rule, right? Implement. And then whatever your class is implementing, then all the methods inside the interface should be defined. So first method is defined, second method is defined, third method is defined, right? And then done. So this was the third rule. Then again, in the main method, we are creating the smart TV object. And then because why we are creating the smart TV object? Because that is our class. Because we can't create the object of the interface, right? So we are creating the object of the smart TV and then we are calling whatever functions we want to call from there. So this is one perfect example of interface where we have used all the rules very effectively. Next example, let's see one more. Now, interface place and then void live. Okay. So this is one interface in which I have the public abstract void live method, which is not having the body. So it is just declared. Perfect. So this interface is good enough. Next one, what I've done, I've created a class which is called as Jharkhand. So obviously it will implement, right? If you're doing inheritance, it will implement the place interface. After that, what I'm doing, obviously I have to define my method which is not defined in interface. So I'm doing that, right? Next, what I'm doing, I am creating another class. And then again inside that, I am providing the body of my method. Can you see this? Now what I'm doing in the main method, what I'm going to do, I am going to create an object of only Jharkhand class. I'm not creating an object of Uttar Pradesh. I'm creating an object of Jharkhand. So if I'm writing p.live, obviously it will directly go where? It will directly go to this place, right? Why? Because this p object is of Jharkhand and we are using p.live. So it'll go to the live method of Jharkhand class and it'll print living in Jharkhand. Correct? Okay. If you will create an object of Uttar Pradesh here and then you will use that object to call the live function, then it will print living in Uttar Pradesh. But right now in this example, I am not doing that. Correct? So I hope you have understood this particular example in which you have two classes implementing the same interface and having the same methods. I hope you have understood this example because this is what is an example of overriding. Next, move to the next topic, which is nothing but multiple inheritance by interface. So in this topic, we are going to understand that why this multiple inheritance is not achievable in Java. And then we are going to understand that using interface, how can we achieve that? Now understand and focus in this particular topic because this is going to be really very beneficial for you because in most of the interviews, this topic is asked. This question is asked. Now, if suppose I have a class, okay, let's do a normal revision of inheritance. First of all, what is that, right? So there's no interface in this example, okay, no interface. This is just a normal class with having one variable, which is number of accounts, and then having one method, which is show, right? Very simple class. Then we are extending, that means we are inheriting a class son from father. Obviously, a son can be extended with the father. So all these properties, that means this particular variable and this particular method will come here also. Even if we are not writing that, in son it is there, correct? Now sun is also having its own property. What is that? Complexion, which is fair. So this is one property which sun is having on its own. I hope you are getting it. So now what we are doing the main method and then we are creating an object of sun, which is a. Number of accounts I'm printing, a dot number of account. So if this a is an object of sun, it will go directly where? It will go to son's class, but number of account is not here. So it will see that it is extending father, it will directly go from here to here and it will print 4. Why? Because I have the value 4 here, correct? Let's go to the next one. System.out.println a dot show. A dot show, that means a object. So again sun. So again this particular thing will go to sun. But here again we don't have that method. So it will again bounce back and come to the father class. Now here we have the show method and its printing balance amount is rupees 56 lakhs. Perfect. Next one. Complexion of the sun. A dot complexion. Again a, that means the sun's object. So this complexion will directly go to our sons and you can see complexion fair is given here. So it will print fair. Perfect. This is an example of a basic single inheritance, correct? Okay, great. Now that we have understood the example of single inheritance, there was no problem. Everything is perfect. We'll get the output without any error. Let's see what are the different types of inheritance. We have single inheritance where I've shown you the example of son and a father. The next is multi-level inheritance where I've shown you the example of father, son and grandson. Right? Now, if you remember the example where I've used the single inheritance, I can have the methods here, right? I can have the methods in father, I can have the methods in son, I can also have the methods in grandson, and there will be no problem. Similarly, in hierarchical inheritance, we can also have the same thing, right? So these all inheritance works fine in Java because we can write the program and we can write the methods, we can call it directly. When it comes to multiple inheritance, there comes the problem. But the question is, why multiple inheritance is not supported through class in Java? Why is it so? What is the reason? This question is very, very important, and it has been asked from last 4 to 5 years in most of the interviews. Whenever you're going for an interview for a Java developer, this will be asked, definitely asked. Now, what is the reason? Let's see. So, suppose that this is what multiple inheritance looks like, right? Father is having a method which is name, okay? Mother is also having a method which is name. When you will come to son, obviously this will extend both father and mother. Both father and mother class, it will extend. That means father's property, which is the name method, will also come in son. And mother's property, which is the name method, will also come in son. Right? Now, if you are creating a particular object of son, let's say A, and then you're calling the name method, now this particular object will get confused whether I should go to father's name method or whether I should go to mother's name method. So there comes the ambiguity. Because there are two methods of same name and there is one object, now you are confused whether I should print the statement which is inside the father's name method or mother's name method, right? This is the reason why there is an ambiguity and why multiple inheritance is not supported through class in Java. Through class, okay? What is the reason that this question is telling through class? Because through interface it can be. How? Let's see. I hope you have understood the problem which you face in multiple inheritance when using a class. But let's see what happens when you're using interface. So I have written a particular problem here, which you can see. Interface father. Now I know that father is the interface. That means my method will not be defined. Again, I have interface mother. My method will not be defined here as well because it's an interface. But my class is son and it is implementing father and mother. Now, because the son is a class, so it has to actually define the method which is not defined in mother and father interface. So it is defined here. Now, if you create an object of son, which is nothing but the object of the only class, which is the son, and it is written s.name, obviously it will directly go to only one of the method which is written here. Because in interface it can't go. In both the interfaces it can't go because there it is not defined. There is only one place where the name method is defined, which is here. And thus your multiple inheritance is achieved. So these two are having the same method void name, and the definition for the method void name I have written inside the class. And thus multiple inheritance is achieved, but using interface. So I hope you understood the concept behind the multiple inheritance. Why is it not achieved through class and why is it achieved through interface?
Let's talk about encapsulation. How does encapsulation related to classes? So what is encapsulation? As the name itself defines its meaning, encapsulation, which has been derived from a word capsule. So encapsule, meaning putting everything inside a single capsule. So capsule is nothing but a medicine which has small granules with different mechanism of different medicine strengths bind it together inside a single capsule. Similarly, this concept is used in programming as well. All the methods, the functions, the attributes, the properties are binded together in a single heading or in a single group. And that is nothing but classes. So yeah, one of the important pillar of object-oriented programming, that is encapsulation, is implemented in Java programming only by the help of classes. So that's how class is related to encapsulation. Along with classes, packages concept in Java is also an encapsulated component. With the help of this example, where the class is defined to be a bank,
and it has a property that is the name of the bank, that is bank name, and a method that is print name, which prints the name of the bank, that is name of the bank is State Bank of India. So this method and the property that is bank name is encapsulated inside a single heading that is nothing but a class which has a name bank. So the concept of class together represents an encapsulated component. So that's how encapsulation is implemented with the help of classes in Java.
Now, to understand inheritance, we have to understand the relationship of a father and a son. Obviously, because inheritance, when we talk about this particular word, inheriting is nothing but to inherit some properties from your father or, anybody, your father or mother, right? So imagine like, you are son of your father, right? And you must be having some properties of your father, like maybe your nose or maybe your face shape, right? Or maybe your ears, something will be matching, right? But it's not like all the properties of your father is within you. You have some of your own properties as well, right? Which is unique in you as yourself, right? So inheritance is something like that. So you are inheriting some properties from your father, father is inheriting some properties from grandfather, and it goes on, right? So this is what is inheritance when we talk about a real world scenario, right? Now, if you look at these pointers, will give you a much more clarification on what is this inheritance. It is a concept that acquires the properties from one class to other classes. Okay, like from son class to other classes, like father or mother, right? For example, the relationship between father and son, correct? In Java, a class can inherit attributes and methods from another class. What is the meaning of this? That means, let's say that I have a class father, okay? I have some variables of it. I have some methods of it. That means the attributes and the methods, right? Now I have created a class son, okay? And this particular class is inheriting all the properties from father. Okay, this is the case. This is the scenario. Then what will happen? Then all the properties which father has will directly and automatically come inside son. Okay, so you don't have to write these features here. You don't have to write these properties here. Okay, but automatically it is there. Now, as I told you that you will also have some of your unique properties, right? So that also you will write here. This is your variable and your methods. Okay. So now you have your father properties also and your own properties as well. This is what is a basic concept of inheritance, right? We will come back to this particular scenario in a programming way when we talk about different types of inheritance and other things. But right now, let's look upon the pointers as well. So as you can see, inheriting the properties and behaviors in a class or in an interface is called as inheritance, right? In an interface is something like a class, okay? In interface, basically, whatever methods you will write, this will be only declared. Okay, these methods will not be defined. It will be only declared. All the methods will be only declared. That means all the methods will be abstract. That is what is an interface. Okay, it's similar like class, but in class we can have a definition of a method, right? We can write anything in the class, but in interface we can't. We can't actually define any method at all in interface. Now, we will talk about interface later on because there is a scenario of some of the inheritance where we talk about interface as well. So we'll talk about that. Now, the next point, the class that inherits the properties is known as subclass or the child class. That means in our case, the child or the son is the subclass or the child class. And when you talk about the parent class, that is nothing but the father. Okay. The next point is the class from which the properties are inherited is known as superclass or parent. That is what I have told you, right? So in this case, father will be my parent class or superclass and son will be my subclass or child class. Inheritance allows us to reuse the code which already exists. Obviously, inheritance is useful for that. Inheritance represents the is-a relationship. What is this is-a relationship? Is-a relationship is something like in your environment, whatever things is having a is-a relationship, right? That is what is inheritance. So if you talk about son and father, there's a is-a relationship, right? So this is how we call inheritance as a is-a relationship, okay? Now let's see the examples of inheritance and let's try to understand what are those scenarios where we can actually talk about inheritance. So the very first example, as I've already told you, the father, son, the grandfather, great grandfather, it can be anything. So you can see the generation here, right? This is an example of a perfect example of inheritance. If you talk about any other examples, you can see here that a basic car, that a basic car will have some of its features, right? Like maybe 4 tires, one engine, or maybe it will run petrol or diesel. It will have a steering wheel, right? It will have 4 windows. These are some of the properties of a car, correct? So let's say that we have 200 methods of a car like this, okay? Tire, wheels, these all things. We have different methods of a car. Now, all the cars can be designed in a different way, right? So we can have an Audi, we can have a BMW, right? We can have a McLaren or Lamborghini or, Skoda or anything, or Maruti, right? Now, all these cars, Audi, BMW and Maruti, will have the same 200 methods. They will have the same amount of wheels. They will have the same engine, maybe upgraded one, or they'll have headlights. They will have steering wheel, right? So they have all the 200 methods. It's just that the appearance and the name is different, correct? So this is also an inheritance because these cars are inheriting from a basic car model, correct? So this is also one example of inheritance. The next example is a TV. Now you can see we used to have a CRT TV when, back in 1996 or 1997, right? We were having old CRT TV. Now, based on this model, we got to know that we have a screen, we have some buttons, we have a volume button, a switch on button, we have some of the things, we have some chips behind the TV, right? Now, based on this particular base model, we derived LED TVs and we derived smart TVs, right? So these are the subclasses. But old CRT TV is the parent. Okay? So this is what are some examples which we can tell about inheritance, right? Now that you have understood the basic concept or basic understanding of what is inheritance, let's see how it is written in Java programming language, right? So now we talk about the syntax. You can see that this is a basic syntax. How do we write our inheritance programs, right? So you can see we use the word extends to show inheritance, right? So suppose that you are writing a derived class. This is what is the name of the derived class. This is just a syntax, not a proper program. So just understand in that manner. Later we will write the programs. So derived class, that means the son, right? Or the grandson is a derived class. So we are extending with the base class. That means our father or maybe grandfather, like those things. Now the methods and the fields. Now a general format for that will be a proper program of that will be, you can see here. So superclass is written here, and inside that class we write the superclass data variables and member functions, right? That means the attributes, the methods, the data members, those things. Now we have another class which is son, and that is actually extending. That means that is actually inheriting the properties of the superclass. So all these things will obviously and automatically come here. But we don't have to again write it. See, here we are not writing superclass data variable, superclass member function, right? So directly these things, these two particular things will be coming inside subclass, but we don't write it. Okay, it is internally there. And it is also having, the subclass is also having its own properties and behavior, which is subclass data variable and subclass member function. Okay, so you can say that in total, this subclass will now have 4 things. First of all, its own data variable, subclass data variable and subclass member function, and then the superclass data variable and superclass member functions also. So this is what is the syntax of inheritance. If you have not understood, don't worry, because now we are going to understand the different types of inheritance and we are going to see some of the programs based on that, right? Now, before I show you the programs, first of all, please understand the different types of inheritance, because this is really very important. Now, when you talk about types of inheritance, we have the very first one, single inheritance, where we only talk about two classes. One is the father, which is the parent class, which we also call it as superclass. And the next is the son class. That means the subclass, or we can say child class, correct? So this is single inheritance, where we have the single inheritance happening. Only son is inheriting properties from father. This is the only thing which is happening here, correct? Now, the next is multi-level inheritance. Now, the name suggests multi-level, right? That means there are several levels. Let's see what are the levels. So there are several other people also. We have the father, son, and then we have the grandson. Okay? So we can have it like this also, that you have great grandfather, and then grandfather, and then father, and then son, and then grandson. Right? It can be like that also. That is what is called as multi-level inheritance. But here you have to focus on one thing, that grandson is inheriting the properties from son, okay, and not father. Grandson is inheriting directly the property from son and not father. Son is inheriting the properties directly from father. Okay, so it's like a level, right? Perfect. Why I am explaining that to you? Because the third one is hierarchical inheritance, and here we have a very different kind of structure. Now, if you can see here, we have two subclasses. One is son and one is daughter, but both of them are inheriting the property from father. That is the parent class, right? Now, this is very different from single inheritance and multi-level inheritance. Why? Because a father can have two child, right? A son and a daughter, and both of them can inherit the properties from their father, correct? So how do we write this? How do we actually write it, correct? So what you will do here is, let's say that I'm creating a class son, right? So what you will do, you will write extends, from whom it is extending from father, right? So you'll write father. And here for daughter, again a class will be there. Similarly extend, and here also you will write father. Correct? This is how you will write the classes in hierarchical inheritance. But in multi-level, this is not the case. In multi-level, what you're doing is class, let's say grandson, extends from whom? Son. Right? And if you will write the class of son, obviously it will extend from father. So I hope you are getting the difference. Can you see here what is the name of the class and here what is the name of the class? Right? So this is the difference between both of them. If you have understood this, so now is the correct time that I should go and I should tell you the programs. We should understand the programs. So single inheritance, when you talk about, here is the program. Let's see what is happening. So a class father is there. Let's say that this is the super class, like the parent class, and we have the number of accounts, 4 accounts my father is having. Okay, let's say not my father, but yeah, generally the number of accounts for a father is 4. The show method is balance amount is rupees 56 lakhs, right? So there's a one method which is of father, which is saying that balance amount is rupees 56 lakhs. And now there's another class, obviously, which is the child. Why? Because we are using the extend keyword. That means inheritance is showing up here, and the son is having its own property, which is complexion, and the complexion is fair. Now understand, as soon as you see this kind of program, you have to understand that these two things, the variable, number of account, and the method show of father is automatically coming here as well. We have not written it, but it is there. Okay. Now when we talk about the main method, let's see what is happening. We are creating an object of son, which is A, and then we are seeing number of accounts, A dot number of accounts. Now see, A is an object of what? An object of son. So when we are calling this A dot number of account, obviously it will go and search where? It will go and search in the sons class, right? So this will go and search in the sons class. In the sons class, do we have number of accounts? Like generally, if I look, then we don't have, but we do have it, right? Because it is inheriting all the properties from father, and father is having number of account. So it will print what? It will print number of accounts colon 4. It will print that. Next is a dot show. Again, this particular thing will go to the son, but within son, do we have any show method? We don't have it, but internally we do have it, right? Because show method is there with father. So it will also print balance amount is blah blah blah, is rupees 56 lakh, right? The next one, complexion of the sun, a dot complexion. Again, a is an object of sun. So let's go to the sun. Now directly we can see that complexion variable is there with sun. So it will directly print fair, right? So you can see this is how the single inheritance works, right? And here the total motto of this program is nothing but that a son is having all the properties of his father, right? So you can see this is a very basic example of single inheritance, right? Now let's look upon the next example, which is of multi-level inheritance. And if you remember, multi-level is something like level. That is how you can actually, remind about all the different types of inheritance. So that it will be very easy for you in interview that you know that which inheritance is which one, correct? So this is class father, parent. Class son is extending father. That means this feature is also here within son. So this is the child, and this is the main class. So you can see son is extending from father. So can I write like this? And grandson is extending from son. So we can write like this, right? We can have a program like this, correct? Now you can see what all objects we are creating. Father obj equal to new grandson. Now if you look at this program, what is happening? Basically, we are creating an object of grandson with the help of father class. Understand this. This is what is called as upcasting. Okay. What is upcasting? See, generally what is upcasting is when we basically create a class of when we create an object of the child class with the help of the parent class. Okay. That is what is upcasting. We are doing the casting there. So we are not directly creating the object of our grandson class, but we are indirectly creating the object of grandson by the help of father class. Okay. So obj.feature, obviously right now this will go where? This will go to the grandson's class. Why? Because obj is right now an object of grandson. So it will print nodes. The next you can see the line obj equal to new son. Now the same object, I am referencing it to son's constructor. So now this obj is not an object of grandson, but now it is an object of son's class. So this obj.feature now will go into the son's class. What is it printing? Eyes. The next one, again the same object, I am referencing it to father's class, father's constructor. So now this obj is not an object of son, but is an object of father class. So obj.feature will go where? This will go directly to the father class. What is it printing? Years. Do not worry, we are going to do this particular implementation in our Eclipse also. But right now, just to understand the different kinds of inheritance, we are doing this. I hope you understood this one. So now let's go to the hierarchical inheritance and let's see what happens here. Here is the very basic thing. We have the same code. It's just that this thing is changing. So now every child class or the subclass is extending or inheriting from the parent. Okay. So father obj. So obviously this will be working similarly, right? It's just the writing pattern which we have changed. So the type of inheritance got changed, right? So right now this obj is the object of son. So obviously it will go to the son's class. It will print what? It will print eyes. The next you can see is that now the object is referencing to the daughter class constructor, right? So it will directly go to the daughter one, which will print nose. And the last one you can see it is referencing to the father constructor. So obviously there is no question, it will go to the fathers. So that is ears. Correct? So this is how this particular inheritance works. Now that we have seen single inheritance, multi-level and hierarchical, now is the time that you should understand the one more inheritance, which is multiple inheritance. Now have a look at this particular example. Okay, now look at this example very clearly, because this is something which is really very different from the other three. Okay, now why is it different? Let's say that I have a father class, which is the super class, the parent class, right? Let me write here P. And obviously the mother will also be a parent class. So these father and mother are not extending from anything. Okay, and these are not child, these are all parent. Okay, so father will have the name method. Let's say a name method is there, and the mother will also have the same name method. Okay, now we have a child class, which is son. Okay, and we are creating an object obj of son, and we are calling obj name. Now here you need to understand what is this kind of inheritance. Here how you will write this class of son, you will write class son and you will write extend, but it is extending from two classes. It is extending from father also, it is extending from mother also. Now why there is a problem? Why I am sounding like that? This is a very difficult case. Why is it so? Because father and mother both have the same function, which is name, same method, which is name, and we have created an object obj of son, which is calling name. Now this object is confused that whether I should go and take the father's name method or whether I should go and take the mother's name method. Now there is a very big ambiguity. This is what is called as ambiguity, that the system is not sure what to do. Okay, and this is the reason why a very famous interview question comes into picture, which is multiple inheritance is not achievable in Java. Right? So this is the best part, because all the inheritance are achievable in Java, but multiple, the three which we have seen are achievable in Java, but multiple inheritance is not achievable in Java because of this reason, which I have told you now. Okay. But here is the fact. If somebody, some interview asks you that which is that inheritance which is not possible in Java, don't say multiple inheritance. Okay. I know that this is not achievable using class, but multiple inheritance is achievable in Java using interface. Okay. So any interviewer is asking you that, hey, can you tell me which inheritance is not achievable in Java? You should say there are none, because all the inheritance are achievable in Java. Okay. It's just the fact that multiple inheritance and hybrid inheritance, which we'll see later, is achievable using interface. This point you need to add on, right? Okay, so this is quite a twisting question, but we have understood, right? Now, we have seen that using class it is not possible. But how is it possible using interface? We also need to know that, right? So I've written a program where I've written the class father, father is having the name method, class mother, mother is having the name method, and in the son, which is extending father and mother, that means a multiple inheritance is there, and the son object is S, where S is calling the name method. Now it is confused and having an ambiguity that whether it should go and call the name method of father or the name method of mother. So this program is wrong. This is not achievable. So what we have to do, we have to achieve this particular multiple inheritance using interface. How do we do that? Have a look. Interface father. Remember, in the very first part of this video, I told you that interface is something where we do not define any of the method. We just declare it. Name method is just declared. We are not defining it. Name method is just declared. We are not defining it. So these are called as abstract methods, and interface is consisting of only abstract methods. That is why this father class is now an interface. This mother class is now an interface. Now there's only one place where we can actually define our method name, which is here. Okay. So we have a class son, which is inheriting all the properties from father and mother. So multiple inheritance is there. We can see this, that multiple inheritance is there. Now you'll ask me, sir, wait, what is this implements? So see, when you are talking with the class to a class, or that means when you're inheriting properties from a class to a class, we use the word extends. The same thing if you are doing for an interface to an interface. So we use the word extends to show the inheritance. Okay. To show the inheritance, we use the extend keyword when we are showing the inheritance for a similar kind of classes. But when it is about interface, inheriting some properties from a class, or a class inheriting some properties from an interface, then we use the keyword implement. Okay, so this you need to remember very carefully. Okay, and that is why we are using here implement. So extend and implement is not very different. It is just showing that inheritance is happening here. Okay, the only fact is when those two things are same, we use extend. When those two things are different, we use implement. Now that we have this, we have the definition of this function name, creating an object of son will directly go to this portion and it will print, hello, my name is Ritvik. That's it. Now you are getting the output. That means multiple inheritance is achievable using interface, right? So this was about multiple inheritance. So let me clear the particular slide and let's see what we have written here. So same method void name, definition for the method void name is done in the son class, and that's how we get the result. Now the last inheritance which we have is nothing but hybrid inheritance, and when you talk about this, it's nothing but a mixture of two inheritance. Now you have to understand with this diagram that what are those two inheritance, which is it is a mixture of, right? So you can analyze and think about what is this kind of inheritance, what is a mixture of two inheritance is hybrid, okay? And this is just this kind of a question which I'm giving it to you, right? Okay. Now here also, one of the inheritance which is there is multiple, and because one of the inheritance is multiple, so this is also not achievable using class, but it is achievable using interface. Okay. So normally in all the interviews, hybrid inheritance is not gonna be asked. Okay. Normally the interviewers or in basic software development field, we generally have only 4 inheritance in use, which is, single, multi-level, hierarchical, and multiple. Okay. So now that we have understood all the types of inheritance, let's move to the next topic, which is practical implementation, and let's see some of the programs. How does it work? Okay, so let's see some of the programs and let's do the implementation of inheritance in Java, right? So now here you can see I've opened the Eclipse, and this is one program which I want to show you. Now it's a very basic program of single inheritance, and you will see some more examples of single inheritance and some use cases also, so that you will have a proper understanding of inheritance, right? Now have a look here. We have a base class and we have the method of it, which is M1. And then we have the derived class, which is inheriting properties from the base class, and derived is having one of its own function or method, which is M2, right? Okay. Now in main method, let's see what is happening. So we are creating an object of derived class, which is D, and we are calling D.M1, right? So D.M1 will obviously go where? Will go to the base class and will print the base class method. Why is it so? Why is it not going to derived? It is going to derived, but it can see that derived is already inheriting properties from base. So it is printing the M1 method of base as well, right? Next, d.m2, obviously it will go directly to the derived class and will find whether m2 method is there or not. Yes, it is there, so it will print directly that, right? Let's do one thing. Let's run this particular code and let's see what it is printing. So if you can see, there is no error in this program. So obviously it will first print base class method and then it will print derived class method, right? But now have a look at this example. This is also the same kind of example, okay? And we have a class A, which is the parent class. We have two variables here. We have a method display. We have some statements written here. And then we have one more class, which is showing or inheriting properties from A. So it is a single inheritance. And we have another variable of its own, which is C. And we have another function, which is show of B class, right? So these are the things. Now you can see here, we are creating an object of B class, okay? And using that object, we are assigning the values to A, B, and C variable. And then we are trying to print the display method and the show method. Let's see what happens in this particular program. So if you look at the output, you can see the output is coming here and it says inside class A value 10 and 20. What is the meaning of that? The meaning of that is, if you go here, I was calling the display method and display method is there in my first class, which is the parent class. Here it is written inside class A value, but the value of A and B is not here. We are giving the A and value here. So that means when we are creating the object, we can give or assign the values to any variable of any class because the properties are of B, right? You can see the B is having all the properties, A and B variable also and C variable also. So if your object is of B class, it can assign values to variables of A class and its own class also, correct? So now it is printing 1020 and later when I am calling the show method, it is also printing me A, B and C value as well. So in this program, we are trying to understand that if you're trying to assign a value later on in the main method, you can assign the values of variables of A class also and B class as well. And similarly, you can print it out, right? Let's move to the next code, which is this one. Now, if you look here, we have the same scenario, okay? There's a class parent, we have the M1 method, we have a class child, which is inheriting properties from the parent class, and it is having its own method, which is M2. That means child is also having M1 method, right? And then we are creating an object of parent. Now understand, we are creating an object of parent, right? So when you're creating an object of parent, that means you're limited to only this class. You can't access the child because your object is of parent, not of child. So parent P, if you're calling P.M1, that is fine because parent is having that function M1. But when you're trying to call P.M2, that is where it will give you an error because parent doesn't have the access of your features, your own fetch features. It is similar like, your parent doesn't know that what is your own feature, what is your talent, okay? But you know your parents, right? Because you have inherited all the properties from them. So you know what are they, how are they, what they actually do for you, all those things, right? So this is how it works. Now you can see P.M2 is not going to work because parent class doesn't know what is M2 method. So how we can correct this program? How we can correct this program is nothing but we have to remove this parent constructor from here and we have to write child constructor because we have to create the object of child by the help of parent class, which is nothing but an upcasting. Okay, so we have to do an upcasting here so that the object P, which will be now of child class, can call M1 also and M2 also because child is having M1 method also and M2 method also, right? So this is what some of the use cases or some of the scenarios where you will get an error. It can happen that you will get an error in these cases. So you need to know how to sort this out, correct? So this was the practical implementation. Now let's move to the next topic, which is super keyword in Java, and let's understand what is this, what happens when we use the super keyword. So now super keyword uses as inheritance always refer to its immediate as an object. What is this word or sentence means when we say refers to its immediate as an object? Let's see. So there are 3 total usages of super keyword. We can use it to invoke the superclass variables. We can use it to invoke the superclass methods, and we can use it to invoke the superclass constructor. Invoke the superclass variable, superclass method, superclass constructor means that from child, within child, if you will use the word super, the time you use the word super, it will directly take you to the parent class. The time you use super keyword, it will directly make a jump and go to the parent class. That is what is super. Okay. So super keyword, if you write, it will take you directly to the super class, the parent class. Okay. That is what it is. It's work. Okay. Now we will see one example for each one of these. Okay. How does it do it in variable? How does it do it in method? And how does it do it in constructor? But before that, I have a very simple problem for you. Simple program. Let's see how does this work. So we have a super class, we have a variable here, and we have a method which is named as display. We have a subclass which is inheriting some properties from superclass, not some, basically all the properties. So this property I equal to 20 and the display will also be in subclass. We have some of the properties of subclass also of its own, which is I equal to 100 and void display. Now in void display, if you look here, we have something written which is called as super.display. We will come back to that, but we are printing some statements also here. Okay, that's fine. We are just printing it. Let's start the execution from the heart of the program, which is the main method. So what we are doing here, we are creating an object of subclass obj, and we are telling it to go to the display method. So we are calling the display method. So what it will do? Obviously, it will directly go to display method of what? Of subclass. So it is going here. Now, once it goes inside the display method, the very first line, what is written? Super.display. So it will directly jump from here to superclass method. That is what I told you. As soon as the compiler will see that there is a super keyword, it will directly jump to that superclass, the parent class. So it jumps there, and what are you calling? You are calling display method. So you are basically telling that, hey, please go to the parent class, check whether there is a display method. If there is a display method, print whatever he wants to print. So what is it? It is wanting to print superclass display method. This is what will get printed first. This will be the output first. Okay. Then it will come back. After completing the job of this method, it will come back. It will come back to the another line. Then it is printing 3 lines of code. Subclass display method, I value, and superclass I value. Now see here again. So it is printing first of all this statement, which is superclass display method. This is what it's printing. Next it will print subclass display method, right? Okay, cool. Now next is I value equal to. So I value equal to. Now it is written. We can see what it is written. It is written I. So what is the I value? Do we have the I value? We have the I value is 100. So it will print what? It will print 100. But now if you see, it is printing what? It is printing superclass I value. Let me remove this so that I can show you the exact answer, right? So now it will print superclass I value. Now see what is written here. Super.I. Again we have the keyword super. But this time using the keyword super, we are not calling the method. We are calling the variable. So it will say that, hey, you will find this variable in your superclass. Go there. So it will go directly to my parent class. What is the value of I? 20. So it will print 20. This is what is the amazing work of super keyword, right? So you can see how you can play around super keyword. You can play with method, you can play with variable. You'll also see how we can play with constructor, and this is how your output will come, right? Now let's see one by one. what are the ways how we can use a super keyword. Super keyword is used as a reference for the superclass instance variable. So you can see here we have a class rainbow, we have a string color indigo, we have again one class colorful, and that is inheriting the properties of rainbow. It is still having the color red, okay, its own feature. And then we have the print color method, inside which it is printing something blah blah. We will see that later on, because right now we have to directly go to the heart of the program, which is main method. Creating an object of colorful, that is d.printColor. Obviously, it will directly go to my print color method, which is here, right? Now here what is happening? Print color method, system.println color. Print color of, so you can see what is happening. Color we are printing. Color is what? Red. Directly print red. Next, system.println super.color. Super.color. That means once the super keyword comes in, directly go to the parent class and see what is the color there. Indigo. So it will print indigo. So what is happening here? We are using the super keyword to reference for the super class instance variable. Right? So this is how we use super keyword for a instance variable. The next program is for invoking a superclass method. So see the same thing. This time we have a void rain. Okay. Let's start from the main method. D is an object of colorful. D.work. So directly it will go to the work method of colorful class. Super.rain. So from here what will happen? It will directly go to the parent class. What is written here? It is written raining. So it will print raining. It will come back. When it is coming back, what is happening? It is calling its own function in this class. It is calling its own function, which is sun. So this will happen. Now in the sun, what is printing? Bright sun shining. So it will print bright sun shining. Right? This is how this particular super keyword will be used to invoke a superclass method. Okay. Now your question will be, what about this rain method? It will not be working here because we are not calling this particular rain method anywhere, right? Okay. Now let's move to the third one, which is super keyword can also invoke a superclass constructor. Okay. Now let's have a look. This is something which is very unique. What is a constructor? A constructor is a very special kind of method which is having the same name of our class. So one is this class rainbow, and we have the constructor here. Can you see? What I said, it's a special kind of method which is having the same name as the class. It's a method because you have the brackets, and the name of the method is rainbow, which is same as the class name. So it's a constructor. Let's start from the main method. We have a statement where we are creating the object of colorful class, which is D. And as you can see, this colorful constructor, whenever we are writing, we are actually calling that constructor. So this particular statement is actually doing two things. It is also creating an object D and is also calling the colorful default constructor. So it will directly go where? It will directly go to the colorful constructor. We have it. And then we are writing super. You can see now here is the main part. We are writing super and then semicolon. That's it. There is a bracket. Earlier, what we used to do? Earlier, we used to write super.rain method because we are invoking a different method. When we talk about variable, we used to do super.color because that's just a variable. But when it comes to constructor, we are just writing super. That's it. So what it is actually invoking the super class constructor. So it is invoking this particular rainbow. It will print rainbow is mesmerizing. First, this will be printed. It will come back. Then it is printing a second thing. What is printing? Colors are amazing. This is the second thing it will be printing. So this is how the super keyword will invoke the super class constructors. And this is how the super keyword also works in inheritance.
Now let us talk about polymorphism in Java programming. So before going ahead of different types and in depth of this topic, let me tell you what is polymorphism. So the name itself makes it very clear. So when you break down this name of polymorphism into two parts, you can see here one is morph and the other one is poly. Now, what is the meaning of this morph? Morph means form, that is different forms, and poly means many. So, literal meaning of this is that something which exists in multiple forms is called polymorphism, right? Now, when it comes to Java programming, what can exist in multiple forms? So, that is your method or maybe objects basically, right? So, the existence of objects in multiple forms is called as your polymorphism. Polymorphism is of two types. One is static polymorphism, or also called as compile time polymorphism. Next is dynamic polymorphism or runtime polymorphism. Static polymorphism is implemented with the help of a concept of method overloading, and dynamic polymorphism represents method overriding. So to understand polymorphism in detail or in depth, you need to understand these two topics. So let me talk about that. The first one is static polymorphism. As I said, it is represented, or it's also called as method overloading. Now, what is method overloading? Two methods which are defined inside a same class and they have same method signature but different arguments, right? That is called as your overloaded methods or the process of method overloading. That is, two methods with the same signature but different arguments are called as overloaded methods. Now, what is the requirement of it? A very simple example I'll state here, which will help you understand what is the requirement of it. Suppose I have to add two numbers. First, I have to add two integers, then I have to add two decimal numbers. For the simple activity of adding two numbers, I need to have two different methods, right? That is, one method with two integers, one method with two floating point numbers, and then I should call each and every method, two different methods depending upon what parameter I'm passing to it, right? But Java provides you a provision of having the same method name for these two methods. So it is basically the same method, right? Meaning it is having the same method signature. Return type, method name. Although the return type is not part of a method signature when it comes to Java programming, okay, you can have different return types here, but the name of the method and the number of parameters will be similar. So add is the name of the method. I'm passing two parameters to it, both is of integer type. Then there is another method inside the same class with the same name, that is add, and same number of parameters, that is two parameters, but are of different type, float and float here. So you can see here, I need not create two different methods. Same method is working for integers or also for floating point numbers. While calling these methods, suppose these methods I call from the main method, and there if I call this add method and I pass two integer values here, then for this particular method will automatically be called. And if I call add method and pass 2.5 and comma 4.5, then by default this particular method will be called, right? So you can understand here the use and usefulness of method overloading as well, right? You need not have two separate methods or different method names and all that. Same method, that is the method with the same signatures, can be used for different parameter types, right? So this is your method overloading. Now coming to method overriding. Method overriding, also called as dynamic polymorphism, represent two methods when they are defined in two different classes, and these two methods have the same method signature and same parameter but different implementation details. Then it is called as method overriding. So method overriding is used along with the concept of inheritance in Java, which is one of the object-oriented programming feature, right? So if there is a class A and there is a class B which extends the functionality of A, both of these classes can have the method with the same name, same parameters, but different implementation details. If I give you an example, like real life example, to understand this, suppose I'm defining a class vehicle. Okay, this is a generic class which is going to keep the detail of all the kind of vehicles, right? All the four-wheelers, two-wheelers and everything. And this has a method called as wheels. And this wheels is keeping track of how many wheels a vehicle has. So it is a general method here. So suppose it says that the vehicle can have 4 wheels, 2 wheels, and if it's a big truck or something, it can have 6 wheels as well, right? Now I have to create another class called as car. Now the car will have 4 wheels only, right? So I want to reformat these wheels method which was there in vehicle class and use the same method wheels here, but for 4 wheels only, for car class itself. So what I'll do, I'll extend this vehicle class here. I'll use the concept of inheritance. So extends vehicle, HICL, fine vehicle. And in this I can have these wheels method again, but here it will state that the car has 4 wheels. Here it would have stated that it has 2, 4, going forward 6 wheels as well, right? So this is the practical application. You can see here that certain property or certain behavior of a parent class, if it is occupied or extended by the child class, and if the child class wants to change the behavior a little bit from the parent class, then yes, it can, with the help of this concept of method overriding. Okay, so this was an example of method overriding when it comes to real applications. In programming, this is how it is done. To understand it more properly, let us try to see the demo of polymorphism concept in Java programming. So for that, I'll be using an online IDE. So let's switch to that. So here you can see I'm already at this online IDE, online editor platform, where I've created a class file, that is main class. And also I've created a public static void main method here. Now inside this, I'm going to write a code for method overloading or overriding. So first I'll be explaining you here the concept of method overriding. So I'm going to create a class here. The same example which I gave you of vehicle is what I'm going to write. So class vehicle has a method. Okay. Return type is void. Wheels. It's not taking any parameter as such. And inside this, it is going to have just a print statement. I'm keeping the explanation and the code here simple for you to understand the basic concept behind it. So number of wheels can be 2, 4, 6, right? Now, after that, in another class, car, which is going to extend vehicle class, in this also I want the same method. This is method overriding with the same parameters, but inside this I'm going to have, I'll copy paste the same code here. Okay, so number of wheels here will be 4. Okay. You can have multiple classes as well. Like I can have class bike as well, which extends vehicle class again. And there I can have a different implementation for this wheels method. So you can use it like n number of times in the child classes. That's not important. So this is what is called as method overriding. So you can see this green highlighted and blue highlighted methods are similar, but in different classes. The child class and parent class, basically, when I say different classes. How to call these methods? So inside the main method, you have to create an object of whichever class you want to call the method of. So if I create a object of car class, then if I call wheels method, by default, the method of the child class wheels will be called and output will be this particular statement, right? Let's execute and see. Yeah, so it compiled successfully. Now let's execute it. So you can see here, number of wheels will be 4. This is the output, right? So if you would have created the object of a vehicle class, then this particular method would have, this particular statement would have been the output, right? So this is how method overriding is implemented. Now when it comes to method overloading, I will just erase and try to modify the same piece of code here. So inside the main method itself, I'm going to have a method void info. Okay, I'll take the same example which we took while understanding the theory of it. So add int a and int b. Okay, and here it's going to print a plus b. Right? Now after this, start. So after this, I'll have again the same method signature, but different parameters. So I'm going to write float a comma float b, and inside this I'll have this printed a plus b. Okay, now from the main method, I'll delete this. From the main method, I'm going to call these add methods. So I have to create an object first. Okay, so main object is equal to main, right? Using this object, I'm going to call add. Now if I pass here 3, 6, right? So you can see with the help of parameter itself, by default, it is going to call the method which is matching with these parameter types. That is the first method, this one, right? And it will throw it will show the correct output. If I try to call the add method and pass the values as 3.5, 4.5, let's try to execute this and see what is the output. Okay, I missed the new keyword here. Okay. Okay, fine. Let's try to execute this now. Okay, it gives an error. Okay. You have to pass the float literal actually here. So I will do what is to keep it simple. I'll change this only as double so that there won't be any confusion. Okay, now let's execute it. It compiled successfully. Now let's run it. So you can see here, the first output was 6 plus 3, 9, and then 3.5 plus 4.5 is 8.0. So you can see the output is 8.0. It means what? That this particular method was called for this calling part, and for the first calling part, this particular method was called. So depending upon the parameter, the methods are called. So you can see this is overloaded method. Inside the same class, I'm having two methods with the same method signature, but different parameters. Right? And depending upon which parameter matches to the method, that particular method will be called. And so you can see here with the help of method overloading and as well as with method overriding, we are able to have flexibility in writing the program or writing the code. Right? And that is the main advantage of using polymorphism. So this was all about polymorphism in Java.
Now we will discuss what is collection framework in Java. So why do we need collection framework, right? So collection frameworks provides you an architecture to store and manipulate the data. You can imagine it is a container for your object where you can store your objects, right? And collection framework is basically a combination of class and interfaces. Later in the session, we will see what is interface, okay? And it has a various classes like array, stack, vector, HashSet, and interfaces. It also has some interfaces like list, set, and queue, okay? We can do various performance like sorting, searching, insertion using this collection framework. Okay, so yeah, this is all about what is collection framework. Now we will see why do we need a collection framework, right? When let me give you an example. Why do we need collection framework? Suppose you have a data that is already, you know the length of the data, so you can initialize an array for that. But what if you don't have that, like the number of the data, the size of the data? That data is like dynamic. Okay, so how can you use that? For using array you can do that, but this is very costly and your program becomes slow, right? But using collection framework you can add some data to your list or set or queue dynamically, and it will not decrease the speed of your data, the speed of your program, right? So this is why collection is one of the main reason we use. It actually provides you the dynamical addition of data in your program. Okay, or not even addition. It will like provide you addition, removing, searching, delete, everything. All the features you can use using this collection framework. Basically, it's a container again. So in that container, you can add anything, you can remove anything, you can delete anything, and and you can retrieve anything. So this is what is collection and why do we need collection. Okay. Now comes importance of collection. Yeah. So importance of collection is, again, it reduces the program effort. You don't need to write the data structure algorithm from the scratch. It has some pre-package where you actually get all the data structure, and it increases the program quality and it increases the speed of your data. I mean your program as well. So this is the main reason why collection framework is important in Java. Now we will see what is the difference between collection and collections, right? So what is the difference between collection and collection? So collection is an interface and collections is a class, okay? So collection used to represent a group of objects as a single entity. For the collections is basically defines the different utility methods for collection object. If you want to call the collection interface, what you need to do, it comes under the util package java.util.collection. You can call the collection interface. And for the collection, it's a utility class. Okay. Then it's like collection helps to derive data structure of the collection framework. We will see later in the section how it actually helps using data structure. And collections is basically give us the some of the methods, static methods that help us to manipulate the collection, right? And when I'm talking about static method, what is static method? Static method is something that actually very much memory efficient, and it is accessible. That method can be accessible by the class instances. Even if you don't have the class instances, you can call those static methods. Okay. And for the static method, static member can change the value of it and can access static data members. Okay, so this is all about what is the difference between collection and collections. Now comes the hierarchy we have in collection framework. So if we have interfaces, we have already used the color coding for the interface and the class. For the interface, we have the orange, and for the class, we have the blue color, right? So basically, before we start about interfaces and class, let me tell you that interfaces always implements and class always extends. Okay, so this is the main key point you need to understand. Here you can see collection, that is an interface, and collection interface encapsulates certain other interfaces like list, queue, and set. Okay, and collection does not have any implementation, but you can implementation the sub interfaces like list, queue, and set. And list have another 4 implementation like array list, linked list, vector, and stack. And queue has dequeue, array queue. Dequeue and dequeue are the interfaces, but array dequeue is the class. Okay, and parity also the class. Then we have set, and set also have the 3 implementation. One is HashSet, link HashSet, tree set. These are all the class, and sorted set, that is the interfaces. Okay, so this is the hierarchy we have for collection framework. And now we will see how this interfaces we can use in our program, right? Okay, but before jumping to the program, let me tell you there is one more thing we have, that is map. We use map. Map also have a 3 implementation. Map is also an interfaces. This does not come under collection, but when we talk about collection, we use map as well. Map actually provides a key value pair. We will see how map we can use in our program as well. For now, you need to understand that map also have a 3 interfaces. 3 implementation you can say. That is hash map, hash table and tree map. Okay. Now come Java interfaces. What is Java interfaces? The interfaces are similar to classes but with collection of abstract method. When I am talking about abstract method, what does that mean? That means that classes, that methods does not have anything written before. Okay. That interfaces is basically have it's something like class, but it has some methods that does not, like, we can declare those methods later. Okay, so you don't need to think about, like, you don't need to implement, like, the methods are the abstract methods. Okay, and interface does not have constructor like we have in class. Interface does not have constructor. All the methods are abstract in interface. Yeah, all the methods, there is no implemented method will be there in interfaces. Then multiple interfaces can be extended by interface, right? I mean, if you want to extend the interface, that time you need to extend the interfaces, right? Now, an interface can contain any number of methods. So you can write 10, 20, 30, any number of methods you can declare in the interfaces, and interface cannot extend by a class. You always need to understand that an interface cannot be extended by a class. It can only implement by a class. If you want to use an interface using class, you need to implement it. You can't extend it. Okay. So this is about what is interfaces in Java. Now let's see what is list. Okay. So we talk about that interfaces that we have under collection, right? So Java list is also interfaces and the child of collection, which extends the collection interface. Okay. So this Java list extends the collection interface. Okay. But in list, you can assure that the insertion of order of your input insertion order will be remain same. List contains the duplicate elements. When I'm talking about contains duplicate element, yeah. It does not care about the element you have in your data, but it cares about the insertion, the way you insert your data. Okay. List can have null value. Yeah, the list you have that can have a null values, null elements. It does not have any problem to contain a null value. List elements can be fetched using index number. So list element, if you want to fetch a list element, you can just directly call using the index number. Yeah, I will show you everything in the code. Okay, and obviously you need to understand, you need to remind that indexing of the list is start from 0, not from 1. Okay, and list allowed to do operations like you can add something in the list, you can remove something in the list, or yeah, this is the thing you will do using list. Okay, now comes the types of Java list. What are the types we have in Java list? We have array list, we have linked list, we have vector. Okay, so what is array list? Array list belongs to Java util package and it helps to create dynamic arrays like the normal array, you can say. But here is the catch, that normal array and the array list, I mean, in the normal array you need to provide the length of your data, but for the array list you can be dynamically add elements to your list, right? So this is the main catch between array and array list. Okay, array list implements list interface, right? It actually implements the list. Okay, that is under collection. Then array list is dynamically resizable and provides flexibility and functionality. Obviously, it's very dynamical. I mean, if you want to add some new element to your array list, you can directly using a dot add method. I will show you how can you do that. It's dynamically resizable. So it does not slow down your program when you do this dynamical resizable thing. And then it provides a flexibility. It's very much flexible when you use this array list. And then come the functionality. It has so many functions, right? Then comes array list class has predefined methods to manipulate the list easily. Yeah, there are so many predefined method we have in array list that will help us to manipulate our list easily. So this is about array list. Look, let's see how can we implement an array list in Java. So here I will show how can you do that, and then we will go for a practical implementation. Okay. So first, if you want to import package, what you need to do? Using import java.util.star. We use star. Basically, it will fetch all the things. Import java.util.star. Dot star is like something you don't need to specifically mention everything like separately. Star is something, it will actually fetch all the things. Okay, so if you use java util.star, you will get all the classes and the interfaces under util class. Okay, now how can you initialize? For initializing the list, you need to use array list. You need to call the interface array list. Then the type of the list you have, like string, int, anything. Then you need to provide the name of the list. Suppose I am using over here fruit list, right? Then you need to write new the way we create the object, same new, and then again you need to write the class name array list and then the type of the list, that is string, and the bracket. Okay, this is how we initialize array list. Now if you want to add some element in the array, how can you add that? So you need to do the list name dot add and then the data you have, that is apple. So I have apple, banana, orange, and lychee. Okay. So what I need to do, I need to call the list name. Then using dot add method, we can store all the data, right? And if you want to display the list, what you need to do? You need to call system.out.println and then the list name, and it will show all the list. Now comes the indexing number in list. What is indexing number? So we have 5, 9, 10, 23 number list. But when I'm talking about indexing number, it starts with 0, right? So 5, the index number for 5 is 0, for 9 is 1, for 10 is 2, and 23 is 3. So you have to remember all the time that indexing number in list starts with 0. Okay, and now we will see how can we implement list in a class. How can you make a class and how can you implement list on over there? Okay, so let's get started. We will do this in Eclipse. Now as we see that how array list work, let's see in the code file how we can actually implement array list. Okay, now we will see the implementation of array list in Eclipse. So I made this class in front of you guys. So let me make one more class where we will implement the array list. Okay, so what we need to do, we need to go to src, then we need to do create class. Okay, new, then class. Okay, so now I just need to write the class name. As I'm implementing array list, maybe I'm going to take the name as array list. Okay, so my class is public. I don't want to make my class private or protected. Then what we need to do, I just need to add the main method. Okay, now this is finish. Yeah, here you will get your class, that is I made my class, that is array list. Okay, now we need to add the package, right? What we need to write? Import java dot, it is belongs to util package dot util dot start. It will fetch all the things, and then we need to use semicolon. We need to understand, we need to remind that Java is a case sensitive language. Okay, so when I'm saying that a case sensitive language, for that you need to have a look at the capital letter, the small letter we are using over here. Okay, fine. So already we call the package. Now what we need to do, we need to write array list. This is the interface we have. Then you need to specify what type of array list you want, right? Suppose I want string type. This is string. Then you need to provide the array list name. So suppose I am going to write fruit list is equals to, you need to create the object new, then array list. If you want, you can add the type of the array over here. If you don't want, you don't need to mention that. Then the first bracket, then semicolon. This is how you need to call array list. Okay. Now you can see if I can run my program. Yeah, we actually, this is okay. You need to specify which Java class you want to execute. I want to execute array list. Okay. Then okay. Now let me click to run. Yeah, it's working, right? Now if I want to see that how can you add something to your list. So suppose I have orange apple in my fruit list. What I need to do? Fruit list dot add. And you can see this is showing that string type. I am allowed to add only string type of a data, right? So add, then I need to add into the invited comma. You always need to remember that whenever you are going to add something in Java in string, you need to add that invited comma. You need to basically you need to provide that data in between that comma. Okay, so I'm going to use orange, and then I need to specify the semicolon. You can see it already takes. Now I'm going to add apple. Yeah, so here again, but I didn't add dot add, so it's giving me error. So I'm going to use dot add method. Okay, sorry, I just wrote fruit list. Then comes fruit list dot add grapes. So guys, this is how you can add the data in your list. Okay, and now if I want to see this is working or not, let me check. Again, array list I want to execute. Yeah, this is working perfectly. Now if I want to print our fruit list, whatever the data we have, if you want to see, if you want to visualize that how your fruit list is working, so system dot out dot println, right? You can use print as well. Println we use for the next line. Okay, you have to remember that. So array list I'm going to use, and then okay. Yeah, you can see we got that thing in the console that we have orange, apple, and grapes, right? But when I told you that I will talk about static void main method. So Java has the main method that is public static void main. Okay, you can say this is the entry point to the application. If you write any class, any object, and if you write any method, if you want to execute that, you need to come to main method. This is the main key point of a Java program. Okay, and always the signature of the main method will be public static void main string args. Okay, and it actually pass a command line arguments through args parameter, which is a type of string s. So this is the thing you need to understand every time, and you need to remind all the time when you start working with Java. Okay, so yeah, we can see that how you can add something using array list to your array list, right? Now we will see how can you if we want to see that you want to set some parameter, right? So before setting some parameter, let me tell you how indexing works in an array list. So if you see that if I say fruit list of 0, right, and I just write I just want to print that. So system dot out dot print ln, and then if I want the first element of the fruit list, so now if we want to use the first element, right, so how can you do that? So just if you want to get the first element, we use dot get method. Okay, so let me print that for you guys. you can see that again you need to use the class you want to execute. You can say orange. So what actually happened in a list, it starts with 0. Whenever you are using any list, the indexing start with 0 with list, okay? You need to remember that, not with 1, it actually starts with 0, okay? Now if you want to go for set something, okay, and for list, you can say one thing, it actually maintain the insertion order. You can say first I insert orange, so it's actually takes orange first. Then I insert apple, it takes the apple, right? Then I insert grapes, it took grapes. So it does not change the insertion order, right? It maintains the way you insert your data into the list, okay? And then if you want to state something, right? So what we need to do, fruit list, maybe I just want to change orange with guava, right? So that time what I need to do, fruit list, then dot, then set. See, you can see first is int, that is your index number you need to provide, then the string, the data you want to replace with, right? So yeah, so this is one I'm gonna take. Now I am gonna do what? That first index, right? To 0. Then what data I want to give, that is guava, right? Now this. Okay. So let me see my program is working or not. Yeah, we are gonna use this. So this is, I didn't print it. Now let me print it. So let me write that the first list, we use plus sign. If you want to like concat something, this is the way you if you want to add some text with your output, this is the way we can do that. Now after setting this, we actually need to let me check that if we can do this. So now I am gonna print the list we have changed, right? Now I'm gonna write, this is the converted list. You can see, right? Let me run it. Yeah. See, the converted list has guava in the first index, right? We are able to change the first element of our list successfully using set and get method, right? But if we want to remove something, if we don't want anything from our list, right? So what we will do? So again, the same thing, you need to write your list name. Right now I'm writing fruit list dot remove. We have a remove function. Then you need to provide the index number, right? So maybe I don't want grapes. So this will be our 0, 1, 2. So that index will be 2. So I provide the index number and that semicolon. Always you need to write semicolon in your code. That is the main thing about Java. So let me check if my remove function works or not. Yeah, so that is after removing the list, after removing grapes, right, from the list. Okay, let me check. Array list I want to execute. Okay. So yeah, you can see the first list we had, that is orange, apple and grapes. After that, we have the converted list, that is guava, apple and grapes, right? Now we want to remove grapes from our list. You can see we successfully remove grapes from our list. That is guava and apple. Now we have guava and apple, right? This is how you can manipulate your array list. These are the main function we have for our array list. There are many functions we have. You can explore. These are the basic function you really need to know about if you want to use an array list, if you want to manipulate our array list, okay? Or maybe we can sort our list, but I just need to check that if we can do that. So these are the, you can see, these are the list, these are the methods we have for list. So if you want to see the size of your list, you can see this, right? I just system this, this, and this. You can see it is going to give me the list of the size of the list. Sorry. Yeah, it's giving me 2. So my array size, my list size is 2, right? So let me write it for you guys. Yeah, you can see I just need to use arraylist.java. Okay, so yeah, my list size is 2. Okay, so this is the main functions, main methods we have to manipulate or to use our array list. Yeah, so you can see I have already added those things, that that how can you use add function in a list, how can you use set function in a list. I have shown you guys, if you want to access any element from your list, how you can do that using .get function. And if you want to use if you want to remove something from your list, you can use remove function. But let me tell you one thing, guys, while you are actually increasing the number of the list, the number, like the size it grows in the array list, that is 50% of its size. So always remember that always array list grows with the 50% of its size. So these are the main key point you need to understand when we talk about collection. So when you go for any interview, so they ask you this basic questions, that what do you think how the array list goes, okay, or how can you add something in your array list. So these are the main thing you need to understand when you start learning collection framework. Now we will talk about linked list. But what is linked list? Linked list is a linear data structure and all the elements are linked with each other. When I'm talking about linked with each other, what does that mean? Okay, so basically linked list has a 2 part, right? One part contains the value you have and the another part contains the address for the next element, right? And each element has the reference to the next element. That is the thing, that each node, we referred every element in a linked list, that is node. And each node contains one part is the value and the next part is the address for the next element, right? So linked lists are almost same with the array. But in linked list, the memory location are not contiguous, okay? And they are linked with each other, right? Using pointers. Now comes the head of the linked list. But head of the linked list contains the address of the element, okay? But it does not contain the data. And when it comes the end of the linked list, the last element of the linked list does not contain any address, because that is last. It only contains the value of the linked list. Like, so these are the main thing you really need to know about linked list when I'm talking about. Okay, and yeah, every element in linked list is called as node, and linked list can contain duplicate value as well. Okay, and linked list implements the list interfaces that we saw in the before part as well. It implements the list interfaces and it maintains the insertion order as well, right? But why do we need linked list? Okay, because linked list has a good memory allocation. The alignment of the memory is nice. The inserting, deleting, searching element using linked list is quite easy. That is not easy with the array. Okay, and if you do some deletion or adding some elements in array, that is very expensive. For linked list, you can do it easily. Okay, and linked list provide the dynamic allocation as well. Its memory allocation is good. So this is why we really need linked list. Okay, linked list also had that set and get method as well. And in linked list, in the performance of linked list using add and remove is far better than array list, and but worst in get and set method. Right? This is the thing you need to remember when we start talking about collection framework. Okay. So now let's see what types of linked list we have. Right? We have singly linked list, we have doubly linked list. But what's the difference between singly and doubly linked list, right? Why do we need doubly linked list? So basically in the single linked list, what we have, the node we referred, it has two parts. One contains the data and the second one contains the address, right? But for the doubly linked list, we have three parts in our each node. First node, first part contains the previous element address, then the data, and the third part is going to store the next element address. Okay, but why do we need this? Because using single linked list, we can't traverse backward. So this is the limitation of single linked list. But when we come to doubly linked list using this part, this extra memory allocation part, okay, we can go back, right? We can go traverse as well. This problem, it actually solves the limitation we have in single linked list. Now we will see how we can implement linked list using collection framework. So first we need to import the package, the same package we are going to use, that it is the part of util, obviously util package, so we are using util. Then we will use the initialize linked list, right? How can you initialize linked list? Again, you need to call the linked list class, then you need to provide the linked list name, and we will see all the things how you can use this linked list in the code, right? Let's see how can you do that. Now we are going to create a class for linked list. Okay, so what we need to do, we need to go that our project, that is demo1, then we will go for the source file, source folder, yeah, and under that we are going to create the class. Okay, so new class. Okay, so I am going to get the name for the class, linked list. And when you are going to use the class, always maintain that your class name should start with a capital letter. Okay, so this is the convention we use for Java. So now I'm going to use again the public static void main, the main method we need to have, that I explained earlier as well. Why do we need it? Yeah. So now again I'm going to import java .util .star, then semicolon. I import the pre-package, the package we need for just to call the linked list. Now I'm going to call the linked list. Okay, linked list. Then you need to provide what type of linked list you want, right? So I want a string type. You can use int type, you can't use something different, but for my case I am going to use the string type, those string. Okay, then I am going to use curly list, that is equals to new. I'm going to make the object of it linked list. If you want to see that what type of linked list you want, yeah, I'm going to use string and then the bracket. That is complete. This is how you can call your linked list. Okay, right. So now we will see how can you add the element in your linked list. Okay, so adding the linked list element, what you need to do, you just need to use add method, the way we did in the same in the array list, right? Car list dot add. Now I'm going to use some car name, as I said, so maybe Alto, right? Let's give next I'm going to add something. Maybe the car name can be, I'm gonna use Lamborghini, right? Everyone's favorite. So this is how you can add the element in the list. Okay, so yeah, you can see I add 2 elements. If you want, you can add thousands of elements in your linked list, right? Their memory type will be the way I discussed, that it has a node, and that node is going to store the value of your the data you have, and the next the memory. Okay, so this is how linked list work. Each and every node is connected to each other. Okay, now if I want to print the list, right? System.out.println, and then we are going to pass the list name. Okay, so I'm going to use the linked list demo.java. So you can see that I put that Aldo and Lamborghini. You can see this two already there in our linked list, right? Now we will see some of the predefined function we have in our linked list. Okay, like how can you remove something? How can you like if you want to add something in the first element, right? If you want to add something in the last, okay, how can you do that? So for that, I can just do curl list dot add. You can see there are the method you can use for. I'm going to use add first. So what it will do, it will actually take the data from me and it will add in the first, right? As linked list maintain the insertion order, the way you insert it, right? So if I'm going to use BMW, right, you can see, and then if I going to print the new list, right? So I can add that add new element in the first, right? So you can see this is how you can add a element that is in your list. Let me check how it's going to work. Yeah, you can see that BMW came first and then it's come the Alto, then the Lamborghini, right? This is how it works, right? Suppose if you want to add something in the last, okay? So curl list dot add, you can see there is an option comes that last, okay? So now you need to provide your data. So I'm going to use Hyundai. Okay, and let me print my new list. Add new element in the last. So you can see that Hyundai came the last. Now this is how it works, that predefined function we have in linked list, okay? But if you want to just get something using, like if you want to add using index, but when I'm talking about indexing, you need to understand that indexing in linked list, that is also start with 0, right? So curl list dot add, okay? So I want to have something using like index. So maybe my index is suppose I want to use a 4, or I can take 0, 1, 2, suppose 2, right? 2, comma, the data I want to give, that is Toyota, okay? Now let me show how it's going to work, right? So add element in the third position, as our indexing starts with 0, right? Always remember that our indexing starts with 0. So you can see, let me do that, linked list demo.java. Okay. So you can see that add a new element in the third position. Yeah, it came, Toyota comes in the third. So how it's calculated? That 0, 1, 2. So it will be third, right? So we added Toyota in the third. So if you mention the index and then if you want to add some data on that specific index, you can do that using linked list, right? So these are the basic predefined function we have in linked list. Now let's see what are the other predefined function we have. Suppose if you want to remove something from your list, right? So how can you do that? So maybe I want to remove Toyota from my list. I don't like Toyota, okay? So this is the thing, I'm just giving the example, not real in life. Yeah. So this is curl list dot remove function. You can see we have remove. So we have two functions. One, if you give the string value, that which one you don't want, or if you give the index value, right? So I'm going to take the string. I'm going to give the proper data that I don't want, right? Suppose Toyota, right? I don't want it. And then I will print our list. That let's say it's worked or not. So let me just execute my program. Okay, you can see I don't have Toyota in my new list, right? I actually removed Toyota from our list. So this is how you can, if you want to remove something using index or using string, right? You can go for it. Okay. Now, if we want to clear all the list. What I have, I just want to delete it, right? So what you will do, call list dot clear. So what you will do, it will clear your list properly. Okay, then system dot out dot print. Let's see what we have in our list after using the clear function. Yeah, you see, we don't have anything in our list. It's an empty linked list. Okay, so this is how, if you want to do something with your list, you can do it, right? But if you want to use a pop function, right? If I don't want to clear it, okay, I don't want to clear. I just want to show you that how the pop function works, right? So let's see. We have the pop function in our list as well. Now you can see our list has BMW, Alto, Lamborghini and Hyundai, right? Now I'm going to use pop function, right? Dot pop. Let me see what's going to happen with my list. So we all know that pop is like just to remove the first element from your list. Check. Yeah, you can see that BMW, we don't have BMW. It will pop. It will actually remove the first element from your list. So this is how actually our linked list works, and this is the predefined function we have for our linked list, right? So when you start working with linked list, you really need to have idea this predefined function. It makes your life more easy that how can you manipulate your list, right? How can you add something? How can you delete something? How can you, like if you want to add within a specific index, if you want to add in the first, last, everything you will do, just what you need to do, you just need to call the functions, okay? So this is the thing we actually do in linked list using collection framework. Now we will talk about vector. But what is vector? Vector is also a part of collection framework. Vector is like dynamic array, which can be expand and shrink. Both you can do with the size of the vector, right? You can store an n number of element in vector as well, right? It is also similar to array, you can say. Okay, so it is a part of Java collection framework since Java 1.2, not from the beginning. Okay, in Java 1.2 they added vector in the part of collection framework. Vector is also a part of util package. Okay, and what is the difference between vector and array list? So the basic difference between vector and array list is vector is synchronized, and vector has contained many legacy methods that are not part of collection network, right? And the default size or the initial capacity of vector, you can say that is same. Now we will see how can we implement vector in Eclipse. Okay, so how can we call vector, right? How can we use vector, right? So as anyway, it is a part of util package again. And we, for the initialize vector, I will use Eclipse to show you how we are gonna use. Now we are going to use class, right? So making the class, the same process we will do. We will use and then new, then class, and now we are gonna get the name, that is vector demo. And now we will select the public static void method. Now first we will import util package for it. That java.util.start. Okay, first we actually import the vector, import the package. Now we will use the start using the object. We will create the vector object. What we will do for that? That first we will write the vector and then new vector. That is your vector name, and that is equals to the way we create the object, right? New vector. That is how you are going to create the object of vector. Okay. If I want to execute the program, let me check is working or not. Yeah, it is working. Suppose we want to see what capacity it has for the initially. So what we need to do? Let's see. I said it is same. Let's check that it has what capacity it has initially. That is equals to new vector, your vector name dot capacity. The first thing we got, right? Then we print the number we have. Let's see what is going to give. Yeah, it is giving the 10. So what we say, the initial capacity we have for vector, that is 10. Okay, this is how you can initiate vector. You can check. As we see, how can you see the initial capacity of vector? Now we will see how can you add data to your vector, right? So what we will do, new vector, the vector name we have, we declare dot add the object, the same as list, the object you want to add. Suppose I want to add apple, right? Then if you want to add more data to your vector, that is dot add orange. Maybe I can add few more, like dot add grapes, right? So these are the things I have added. Okay, so let me check that it is added in our vector or not, right? How can you check that? We actually need to print our vector, right? And we can see the size of the vector, right? So let me print it, that what we have right now. You see my vector, what is that? Yeah, you can see I have added apple, orange and grapes, right? So at what data we have added in our vector, that is already added, right? If we now if we want to see the size of our array, so how can we check that? The same thing we are going to do, but we will use dot size. So if we want to see the size of the array, size of the vector we have, what we need to do, that and plus that we concatenate the vector in the when we are going to print new vector dot. Now what we use size, that will give the size of our vector, right? Let me run it. So let's see. It's supposed to give 3. Yeah. So it gives 3, that our vector size is 3. Okay. There is one more way you can add element to your vector, right? How you can do that? Same new vector. We have dot add element, right? In that also the same way it will add the element, the data you want to put in your vector, right? So suppose I'm gonna add dog, okay? Or maybe I'm gonna add new vector dot add element, that is cat, okay? So yeah, let's see the new element is added to our vector or not, and the size of the vector as well. First, let's see our like the elements we have in our vector. Yeah, so you can say that dog and cat is added, and obviously vector maintains the insertion order. Always remember that list, linked list and vector, they all maintain the insertion order, the way you insert the data to your list object or vector object or linked list object, right? So if I'm going to use the same thing, the size of the array, it should be 1, 2, 3, 4, 5, right? Let's see size of the array, what is going to show. Yeah, this is showing 5. So this is how actually we use vector, right? We implement vector using collection framework, right? So till now we saw that how can you use linked list, how can you use array list, how can we use vector, right? Now we will see the other part. that what are the other thing we have using collection framework. Now we will talk about Java queue. But what is queue, right? Queue basically is designed in such a way so that the elements added to it are placed at the end of the queue and removed from the beginning. And queue extends the collection interface and it follows the FIFO approach. When I'm talking about FIFO approach, let me tell you what is FIFO approach. So FIFO stands for first in, first out, right? Let me give you an example what actually I want to mean by FIFO, right? Suppose you want to buy something from a store, but that store has a queue, right? When you come to the store, you need to stand in the queue, right? So when you added in the queue, that time you will you will stand in the queue in the last of the queue. So basically for that you can say when you added in the queue, you added in the last. But when someone got the item from the store, they will leave the store, they will leave the queue, right? So the removing from the queue will be from the first. So same thing happened with the queue technique over in Java as well. They maintain the same thing. When you insert something to the queue, it will add that thing in the last. And when you remove something from the queue, it will remove from the beginning, right? So this is the thing I said, queue insert the elements in the end and removes from the beginning, right? Queue does not allow any null operation, and that will not support any null operation. You really need to understand that queue does not allow any null operation, okay? And queue has two interfaces. One is linked list, one is priority queue. But you guys have a doubt that what is the difference between queue and priority queue? Let me tell you what is the difference between queue and priority queue. So queue for the queue is where the insertion is done at one end and removal is done from the other end, right? Okay. But from the priority queue, what priority queue does, the elements can be inserted in any order, but removal of the element will be in a sorted manner, right? So for that, if you want to have a sorted queue, we use priority queue for that sometimes, right? So this is the basic difference between queue and priority queue. So let me show you how can you implement queue with using collection framework. So first we need to import the util package we have. Then we need to initialize the queue. How can we initialize? We can call queue or we can use priority queue. I will show you how can you call the queue and how can you use the priority queue, right? So how can you initialize them both? Okay. Now comes the elements. How can you add element? We use .add method to add the element in the queue, right? And if you want to display the queue, the normal thing, do write system.out.println, then pass your queue name, right? Now comes the predefined function we have in queue. So what are the predefined function we have? We have .pick. What is .pick? .pick will return the first element of your queue, okay? And when you use the remove function, I told you it use the FIFO technique. When you use the remove function, it will remove the first element, okay? First element from your queue, right? If you want to see the length of the queue, we use .size. So let's see, and let's go to Eclipse and let's see how can we implement queue in Eclipse using Java. So we came to Eclipse, okay? So already I have made a class for queue. You all know how can you make a class. Where I actually called initialize the queue using priority queue. You can see this. This is using priority queue. Then what I did, now we will see how can we implement the queue using Eclipse in Java, right? So what I did, I actually called a class that is queue demo. Now I actually initialize the queue, right? I first write priority queue, then the type of the queue, that is string, then the name of the queue want to have, that is I want a queue normal, then new priority queue, then the what type of a queue you want, that already I have specified. This is the optional. If you want, you can put, otherwise you can skip it. Again, I use string and then the first bracket, okay? And after that, I use .add method to add elements, to add data to our queue, that is orange. First I add, then I add apple, then I add grapes, then I add lychee. Maybe I'm gonna add one more, that is queue.add. I am going to add banana. Okay, so yeah. So I have added, right? Now, if I want to see that whatever the data I have added, that is added properly in the queue or not, Let me check it out. Let me run it basically. Yeah, you can see apple, lychee, grapes, orange, and banana is there. But it's not. It does not maintain the insertion order, the way we insert it. Because I told you that priority queue use the sorted manner. You can see we have A, L, G, O, B, right? We came to Eclipse. Now we are going to make a class. I make a class for it, that is queue demo, right? Now what I did, I actually call the priority queue. Called priority queue. Then you need to specify what type of a queue you want. That is string queue I want. Then I add queue, the name of the queue you want to put. That is, I want a queue name. That's normal queue. Then I use new priority queue. Then again, what type of a queue you want. This is the optional. If you want to put, you can. Otherwise, you can make it null as well. So I again use a string and then the bracket. Right. This is how we initialize queue. Then how can we add element to the queue? So dot add method we used. In the dot add method, I pass the data. That is, first is orange, apple, grapes, lychee, and banana. Okay? We actually give those data to the dot add method to see that our queue is taking that element or not. Let me execute the code for you guys. Yeah, you can see it takes and it stores all the data. That is apple, lychee, grapes, orange, and banana. Okay, so these are the this is the main method, we can say, dot add method, which actually help us to add something to our queue. Right now we will see that how can we use, like how can you get the first element from the queue, right? So let me just try to print that. System dot out dot print ln, and in that we will use queue dot, you can see these are the option we have. So dot peak I'm gonna use. Let's see what will happen with that. What is going to print, right? You can see the apple. It will give you the first element. Okay, it will give you the first element of the queue. That is how pick works. Okay, now we will see some other technique as well. Let's see. There is one more method we have, that is system dot out dot println. If you use dot element, that also will give you the first element of the queue, right? Queue dot element. Okay, let's see what is going to give. See, for element and pick, both are going to give you the first element of the queue, right? If you want to use remove method, if I want to use the remove, right? So if I want to remove something, dot remove. Let's see what is going to remove. According to the method, it should remove the apple, right? The first element of the queue it should remove. Now I am going to print the queue. You can see that using remove, what it removes, the first element. So it is perfectly using FIFO technique, right? This is all we really need to know about queue when we talk about queue, right? So these are the basic function again, guys. I am talking about that these are the basic function you really need to know. You need to understand. If you want to manipulate a queue, that time you need to understand that. Okay. And for the remove purpose, we will have one more function, you can say, the method we have, that is dot poll, right? Let me see what is like how it's going to work. Yeah, you can see first it remove apple when I use remove, and then when I use dot poll, it will remove the grapes, right? So this is how remove and poll works. It will remove the first element of your queue, the FIFO technique, right? So yeah, this is the main method, you can say, you really need to have an idea when you start working. Now we will talk about Java set. That is also the part of collection. Okay, so set is an interface which extends collection and implemented by HashSet, LinkedHash or TreeSet. Okay, but the main thing you really need to you need to remember, okay, that set does not contain any duplicate values. So suppose, let me give you an example what actually I want to mean that it does not contain duplicate value. Suppose you have a 5 set of data, okay, where you have 5 data points. Suppose 1, 2, 3, 3 and 4. When you put that data into your set, it will eliminate that 3. Okay, it will have 3 ones in a data set. So what you will get? 1, 2, 3 and 4. Okay, so this is how actually set works. So basically, when you want to have a distinct value in your data set, not a duplicate one, you just want to have a distinct value, right? That time you can use set. Okay, set is based on the normal mathematical set concept. The concept we have, it actually maintains that abstract concept of set from maths. Okay, then set allows the null values. Yeah, set actually allows you to have null values in your data set, but set does not maintain the insertion order. When I'm talking about the insertion order, the way you insert your data, it will not maintain that. Okay, so this is the basic thing you really need to know when we are talking about data, when we are talking about set, right? Set has some methods, like set has add method, set has contains method, set has is empty method, it has iterator method and remove and size. We will see all the method in the later in the video. We will implement all of them. Okay. Now come these types of set, right? So we have 3 types of set. Okay, set implementation basically. 1, HashSet, second, LinkedHash, third is TreeSet. Okay. So what is HashSet? Why do we need LinkedHash? Why do we need TreeSet? Right? So HashSet is basically the normal set we use. Okay, and HashSet is not order, but it is faster than TreeSet. But how it allocate the number? So HashSet put the number in a hash table. Okay, and for the TreeSet, what you will get extra in the TreeSet, when you put your data in the TreeSet, that time your data will be sorted automatically. So what it returns? It returns the sorted data. Okay, and the LinkedHash, it is use the linked format in a hash table. So this is the main 3 difference you can say about this HashSet, LinkedHash and TreeSet. Okay, so but TreeSet is slower than HashSet. Okay, you really need to remind those things that TreeSet is give you a sorted order data, but TreeSet is slower than HashSet. Okay, but HashSet will not give you a sorted data. Now we will see the implementation of set. How can we implement set, right? So when we are talking about implementation of set, first we need to import the package, the same package we are using throughout the collection, that is import java.util.star. Okay, now you need to initialize set. So next we need to initialize the set. How can we initialize the set? First, we really need to mention that set, the interface you need to call. Then you need to call the which type of set you want, right? String, int, what type of string? That I want string. Then what I need to add? The name of the set. Okay, that is food set I want. Now then we need to use new. Then we call the HashSet, and again you need to put which type of set you want, that is string, and then the bracket. This is how you can initialize set, right? If you want to add some elements in the set, we use .add method, and if you want to display it, we will display it using system.out.println, right? Now, what are the implementation? What are the predefined methods we have, right? So for the duplicate value, I will show how can we. I will go I will add the same data twice in the set, and I will show you how it's handle those things, right? Okay. Next we will go for implementation of set. Okay. Now we will see the implementation of set. Okay. So what we need to do? Again, I'm gonna create a new class for set. So in the source folder, I will go to new, and then class. I will give a set demo class. I need to have that. right? And then I will use the main method, then finish. Okay. So first thing we do import java.util.star. Yeah, we import the package. Now we will call set interface, right? So what we need to do, set. Then what type of set you want? I want a string type. Okay. So you can say then what name you want. I want new set is equals to new. I want a hash set. Then which type of set I want, that is string, and then the bracket. This is how we declare set, right? Now if we want to add some new data to your set, new set dot add, I'm gonna add the name of Sam. And now what I'm going to add new set dot some other name I'm going to add, right? J. Now again I'm going to add Sam. Let's see how the set is going to handle the same data twice. I said it's not gonna take the same data twice because it does not support the duplicate value, right? Next, new set dot, I'm gonna add some new one. Suppose Anil, new name. Right? So yeah, I have added all the things. Let me print the set for you guys. Let's see how set is going to take the duplicate value. You guys can see, right? It does not maintain the insertion order. First I insert Sam, but I insert Sam twice, right? One this and second one is this, right? But it takes Sam for once. So this is the way actually set take the duplicate values, right? It does not contain duplicate value. Or this is the thing you can say about set, but it does not maintain the insertion order as well. But if I want to remove something, so how can I remove? So new set dot remove function we will get. Then we need to give the thing you want to remove, right? So I want to remove Sam. Let's see how it's gonna remove it. So system dot out dot println new set. Let me see that it's gonna delete it or not. Yeah, you can see I did not use println for that. It came in the same. So yeah, I think you guys should know what's the difference between print and println. So basically, print is something. If you like use print, it will not go to the next line. But ln, we use ln just if the output will go to the next line, right? So it's up to you. How can you use your output? How can you see how you want to see your output, right? So you can see it actually delete the Sam from the set, right? This is how remove works. So now let me show you how tree set is different from hash set, right? How actually is going to make your data in a sorted format. To show you that I'm gonna use set, that is a int type, and again tree set, again a int type. Okay, so again I'm going to use set, but this time I am going to use integer. Okay, then I'm gonna use set2 is equals to new say hash set yeah, but for int I'm getting an error. Maybe I need to write int. Okay, so yeah, so again I'm doing the same I was doing the same thing, but it does not take int. You need to write the full word, right? That integer. You need to have a set that is an integer type. Okay, and I'm going to declare a set that is also an integer and set 3, but it will be the part of tree state. Okay, so let me check that. Yeah, so we actually need that. Now what we need to do, say2 dot add, I'm gonna add suppose 2, then say2, I'm gonna add 10, sorry, add use dot 2. Yeah, now I'm going to use say2 dot add again 2. Let's see it's gonna take the duplicate value or not. Next I'm going to add some more data on say2 dot add, suppose 5. Yeah, this is all, and let me print it out. System dot out dot println, and we will pass the HashSet. Now I am gonna add the same thing with the set tree using tree set object, right? Let me do that. Right, let me just run the code. Let's see what it gives the output. Yeah, you can see for HashSet for both the cases. Okay, fine. What I did, I take 5, 10, okay, 2, 2, 5. Okay, at any way, it both that give me the sorted order thing. But let me add something extra over here so that we can understand. Yeah guys, I added some more value to it, like 90, 87, 12. Okay, so these are the things we added in the HashSet. You can see in the result, this is not in the sorted order, right? So I am going to add the same thing to the tree set as well. Let's see what it will give us the output. So if it's going to give us a sorted output or not, we are going to check that, and how this is going to handle the duplicate element as well. We will see that as well, right? So at anyway, we know it's gonna eliminate those duplicate elements. Let's check. Okay, you can see in the tree set what we got, that all the for the both tree set and the HashSet, for the both duplicate values are eliminated, but for the tree set we got the output that is in the sorted manner. So this is the main difference you can say about HashSet and tree set. Tree set, for the tree set you can get a sorted manner or array, and the sorted manner set, sorted manner data. But for the HashSet, it does not care about the sorting, it just care about the duplicacy of your element. But one thing about HashSet, it is faster, it is more faster than tree set. Tree set is not as fast as HashSet is. Okay, so this is the main thing we used in set. This is the basic of sets, you can say, about the collection framework. Okay, and we also have linked HashSet the same way we do it, but for the linked HashSet, it actually stored the data in the hash table in a link format, right? So this is the main part of the set we really need to know about collection framework. Now we will see the map. But what is map? Map is not the interface or subtype interface of collection. Okay, so this is different from collection interface. This is not the part of collection interface. But why we are talking about map over here? But map is also used when we talk about collection. This is also actually a big factor we use in our everyday programming, that is map, that help us to pair the key and the value. And I will give you an example what is key value pair I am talking about. Okay, but one thing you need to remember, that map does not contain any duplicate key. Value can be duplicate, right, respect to the keys, but the key cannot be duplicated, right? And one key can contain one value only, not the multiple value. These are the things we really need to remember when we are talking about map. So Java map is basically like two interfaces are basically used to implement map, that is map and sorted map. and 3 classes, that is hash map, tree map, and linked hash map. Okay, and the order of a map depends on the specific implementation, that is depends on tree map or linked hash map or the hash map, right? So we will see all the things in details. Okay, and map is really a bit different from collection, and it is not the part of collection framework. Okay, and yeah, this is all we can say. Let's see how can you implement map. So implementing map, we first need to import java.util.stuff, right? The same package we are using. But before starting with that, I told you that we have 3 implementation of map, that is hash map, tree map, and linked hash map, right? So hash map is the implementation of map, but it does not maintain any order, right? So hash map does not maintain any order, the insertion order it does not maintain. And for the link hash map, it is also implemented by map, and it inherits hash map class, okay? But it maintains the insertion order, right? This is the basic difference between hash map and linked hash map, right? And for the tree map, this is implementing map and sorted map, and it is a sorted type map. If you want to have a map that is in a sorted order, you should go for tree map. So this is the basic 3 difference of hash map, linked hash map, and the tree map. Now we will see the implementation of map, and I will show you each and every types of map, how can you implement those, right? So first what we need to do, we need to import the package. So we need to import java.util.stuff, right? How can you initialize a map? So initialize a map, you need to do map, then what type of a key you want to input, right? Your key can be string, your key can be int, your key can be float, right? So here I am using string type, okay? Now comes the key, the value. What type of a value you are going to put in your map? Here I am using integer, okay? Now you need to put the map name, right? I gave it as a hash map. Now you need to create the object the same way, right? Now new hash map, then again specify the key value, key type and the value type, then the bracket, right? This is how we use. But when we are adding some element in map, we use dot put function. And how we can get the key, how we can get the values, how we can get the pair, everything we will see in the Eclipse, okay? So let's see how we can do that. So here again for the map, we are going to make one new class under source folder. New. I'm going to add a class, right? So here we are going to use map demo. Then we are going to select the main method and then finish. Yeah. Now we will import the package, right? What's the package? java.util.start. Okay. Now what we will do? We will check, like we will start doing the map implementation, right? So we will call map. I want a key type of string. I am going to add that is string. I want to have a value that is type of integer, right? I am going to write integer. So one thing you should remember, it does not take int the short form of it, right? You need to write the full form, that what type you want. Or string, for string, it does not take str. You need to write string, right? The full form. For integer, you need to write the full form. That's integer. Then you need to provide the name, right? Demo map, right? Equals to, I am going to call new. What type of map I want to call? I want to call hash map, right? Let me check, right? Here again, I am going to repeat what type of a key I am going to use. That is string, and the value type is integer. Right? So now this is how we can initialize map. Now we are going to add some value to it. Okay. So here I use demo map dot. Here what we do, we use put function, right, to add something. we use put function to add something to our map, right? First, I am going to add some name, and according to that name, I am going to store the value, right? So let's see, I am going to add Anil, and in the value, I am going to add maybe he got something around 50. I mean, he's not that good a student, yeah. So you can see this is how we can add the data on the map, right? So again, I'm going to add some more data to see other methods we have, right? Why it's getting confused, right? Okay. So again, I'm going to add Sam. It's a good student. I'm going to add 80, right? And I am going to add more, 2, 3 more value to show you guys how actually it's working. Right, so John, he is also a good student, maybe the best student. Okay, so what function let's keep? Okay, let's again take the computer. So put, add John, and he's a good student, so I'm going to add 90 for him. Yeah. And this is the last one I'm going to put. What? 76 for that, right? So this is how you need to explain, or you need to add your data to the map, right? It actually takes your data in a key value pair. For that, if you want to extract data using key, you can do that. If you want to extract data, just the values, there's the keys, you will do that, right? So it's kind of a pointer kind of thing. You can say like using key, you can extract the value, right? Let me just print system.out.println. I think you guys are quite clear why we use print and println. Yeah, you can see we got it. Like for the John, I got 90. For Ria, we got 76. For Sam, we got 80. And for Anil, we got 50. So one more thing. You can see it does not maintain the insertion order, right? As I said, HashMap does not actually maintain the insertion order. Let's see if I are going to use a tree map, maybe it's going to maintain the insertion order, right? But no, but tree map also does not maintain the insertion order. Only LinkedHash Map maintain the insertion order. So let me add something over here for LinkedHash Map. Again, the same thing I'm going to do. And here I am going to give demo map 1 the new name for our LinkedHash Map. Let's see how it's going to work. Does it give us that sort like that what to say, the insertion like insertion order is going to maintain or not? Let's see. Use this. Right, and I'm going to put the same value over here. Let's see how it's going to put, right? So we will get the difference between them. So when for the interview time, they actually asked you what's the difference between hash map, what is the difference between LinkedHash Map, why in the what scenario you need to use those things. Be sure guys you have the proper idea that what is hash map, what is the difference between hash map and LinkedHash Map and tree hash map, right? So I think this will guys help you out. Let's see what we will get as an output. Yeah, you can see I actually gave Anil first, then Sam, then John, then Ria. Yeah, it's maintaining the insertion order, the order we have, right? Let's see if we go for the tree hash map, if it's going to give us a sorted value or not, right? Now we will going to use a tree hash map. Let's see it's going to give us the sorted order, in a sorted order or not. Our output is going to sorted or not. Let's see. So yeah, what we need to do, we need to call map, then string, what type of a key you want, then the value, what type, like your value type, Then the name you want to give, I gave demo map 2 for tree map, and then comes new, then call the tree map interface, and then this is how you can call it, right? Now I'm going to add the same value for the tree map as well. Let's see what output we will get from them, right? So I just need to change the name for them. Let me change the name for them. Yeah. So here we go. Let me just execute the code. Yeah, you can see that first one we have, that is hash map. It does not maintain any insertion or order, or not even sorted order. For linked hash map, it does maintain the insertion order we have, but it does not give you the sorted order. But tree hash map will give you the sorted order output, right? If you want to have a sorted ascending order or sorted order output, you can use tree hash map. So this is the basic difference between three types of map. You guys should remember all these things, that actually in the interview they ask all these things, right? Now let's see what other things we can like. Suppose maybe you want to iterate, like in printing that map, you will get all the value. But if you want to have a only key, if you want to fetch the key, or just want to fetch the value, how can you do that? In that case, what we use iterator as well. We use for loop. So here I am going to use for loop, and I will show you how you can do that, right? So first we need to write for, then under that we need to write map, right? Then what we need to write, dot entry. Okay, I'm going to add entry method, and here you need to put the k and v, right? So here, if you want to iterate through each and every element of your map, how can you do that? Or if you want to have just the values, if you want to have just the keys of your map, how can you do that? You can use iterator, or you can use for loop. So here I'm going to use for loop. So what I need to do, I just need to write for the for loop, and then I just need to call the map dot entry method. I need to call. Then I need to write map, and then semicolon your map name. That here I am using demo map, right? And then you need to call dot entry set. Okay. So this is the like signature you need to understand. You need to remind to iterate through each and every element in map, right? Now I'm going to write system dot out dot println, right? Now what I need to do, I just need to call my value or the key, right? So here what I am going to do, that is I'm going to write map. So as I say that we said like map, right? Map semicolon demo map dot entry set, right? So what basically it works as is like an alias to your map, right? So you can see this is map dot. If I write dot, you will get so many functions. So yeah, you will get dot get key. So what you will get, all the key from your map, right? Let me just show you guys how can you get all the key, not the value. So we'll get only the key, right, in the maps. Okay, so let's see. Yeah, you can see I got all the key, that is John, Ria, Sam and Anil, right? So if you want to have only the values, how can you do that? That's system dot out dot println, and then I will call map dot get. Did I get any option? Yeah, I got the get value option, right? So I'm going to use it. You can see. So let me just print it out for you guys. Let's see. Yeah, you can see I got what I got. It's actually let me just off this one. Maybe first it's giving me the value, then it's giving me the key, right? So yeah. So if I want only value, right? You can see that we got only the value, right? That using dot get value function, we will get all the values. Using dot key function, dot get key function, we will get all the keys. This is how you can manipulate your data using map. And this is why map is one of the most popular, like you can say, interface we use when we use for our network, like for our program as well. And when it comes to collection, we always go for map as well. We really need to understand, and we really need to have a good idea about map.
Now let's talk about the concept of hash tables. So what is hash table? How is this hash table implemented in Java? Now before understanding all that concept, we have to understand what is hashing. So because hashing is a concept which is being utilized when we talk about implementation or no, coding of hash tables or hash map and so on. So what is hashing? So hashing is a black box technique in which if you pass a key, the key can be anything, a number or a string. If you pass a key to that black box function, the output will be a code that is called as your hash code. Okay, now why this input and why this output? What is the whole concept? Why is it required first of all? Okay, so let me explain you. So suppose I'm talking about a function. Okay, let this be represented as h of x. Fine. Now this will pass a key. Okay, this key can be a string, it can be an integer, it can be anything, any number or a sequence of characters, anything. Okay, output will be a code, also called as your hash code. Okay, now what does this hash code is used for? So hash code tells the position where that particular key is going to be stored at the backend in the computer system. Okay, for example, suppose there are these many, this is your array you can assume, or this is a space which is there where your data will be stored. Fine. Suppose the data example I'll take is of a student. Okay, so a student will have its name, will have its roll number. Okay, now this data has to be stored somewhere. When we talk about the storage in RAM, that is a temporary storage, right? So when we talk about storage in RAM, this is how the storage is structured. So suppose this data about a student who has a name and a roll number has to be stored somewhere. Okay. Now that data or that name of a student suppose is a key. Okay. That key will be passed to this hashing function or hash function. And the output will be a code. That code will be nothing but that position in the storage area where that particular data of a student will be stored. That name or roll number of a student will be stored. Okay, suppose the key or the name of a student is something called as maybe ABC. Let the student name be ABC. So ABC will be the key which will be given to this hash function, and output will be a code. This code is suppose for ABC key is your 4. Okay, so starting from 0, 1, 2, 3, 4, and suppose there are more numbers, more storage space here, 4, 5, 6 and so on. So at fourth location we'll store the data of the student ABC. Getting it? Next, suppose there is some other another student or whose name is maybe Priya. Okay, so Priya name will be this key. It is a key here. It will be passed to this hash function, and the code or the output which we get out of this hash function is suppose 2. Now at second location, the information or the data related to Priya student will be stored. So this is how hashing works. Okay, this whole concept of finding a code out of a given key. That key can be anything, either a string or either an integer value. Like in this example, it was a name. So for the Priya name, the code was or the output of this hash function was 2, and we stored there. So this is the complete concept of hashing. Okay, so you can say it is a one-way function, meaning if you provide a key, it produces a code or a hash value. Okay, but if you provide a hash value, it won't produce a key. Right, now what is this function? So this function is designed in various ways. This function can be like as simple as picking the last character of a string and converting it to its ASCII value, and that ASCII value becomes the index or the hash code. Okay, or it can be as complex as some mathematical calculation over the ASCII values of a given string. So we are not bothered about what this hash function is going to be, although the complete hashing concept depends on this hash function itself. The more better and well structured your hash function is, that good the complete hashing technique will be. Why I'm saying that? Because a good hashing technique is only that where there is minimal collision. Now, what is this collision? So we'll take this example again and see. So the same hashing function, I'm going to take another example. Okay. Now, let's see here. Suppose there is a student called by the name of Priya. Okay. Then another student is there by the name of maybe Pooja. Then there is another student maybe by the name of, you can say, what, Rohit. Fine. Now, we have to store these three data or three names of a given student into the storage space. Now, Priya will be passed to this hash function as a key. Okay, it will produce a hash code. Suppose it produces the hash code as 2. So this Priya will be stored at location 2. Then there is another student named as Pooja. It will be passed as a in the hash function and it will produce the hash code to be suppose 4. Okay, at the fourth location we'll store this Pooja. Now next is your Rohit again. So Rohit is passed in this hash function and the hash code which it produced was again 2. But at the second location already there is another information about a student named Priya is stored. So where will this Rohit be stored? Now this complete situation is called as your collision. And a good hashing function should avoid this collision situation. Okay, so when we talk about its implementation in Java and where it uses hash map and hash table kind of a concept, there this collision is resolved. Now, how is this resolved there? It is resolved by using the concept of linked list. It means what? Like, suppose the second student here, Rohit, also had a hash code of 2, but 2 was already occupied by another student information that is Priya. So what will happen? There will be a pointer to from this place, that is second index, to another node. Okay, and this node will be having the information. This is a node of a linked list. Okay, and this node will be having the information of a student Rohit. This will also be like one node of a linked list. Okay, which will have the value that is Priya, the name of the student, and the address to the location where this node is. Like how in linked list it is. Every node of a linked list stores a data and a pointer to the next node, right? Similarly here, the data will be the student name Priya and then address to the next node, that is this node where the Rohit information is stored. Getting it? So this is how collision is resolved. So there are multiple techniques to design this hashing function. Then there are multiple techniques also to resolve the collision whenever it happens. So one of the way I told you is by using the concept of linked list. So all those keys which are mapped to the same location are linked with the concept of linked list or linked as a nodes. Okay, but we always try to have a hashing function which has minimalistic collision, and that's a good hashing concept or a good hashing technique. Now we'll talk about what are those ways in using which we can implement these concepts of hashing and how it works when it comes to Java programming language. Now let's talk about the implementation of the concept of hashing in Java programming. So for this, what will be the problem statement is that we are going to write a program using which I'm going to tell you how this hashing concept works or what is hash code and then what are different hashing functions which we can use in Java programming. So guys, there are so many hashing functions which already exist like MD5, SHA. All these hashing functions produces 16-bit hash codes. So you can do the direct implementation of these hashing functions also, but even if you don't do, like how in a most simplest way you can use the concept of, or is Java using the concept of hashing? So for that we will talk about two of the concepts of collection framework in Java. One is your hash map and the next one is your hash table. Okay, so hash table is an interface which is defined in the collection framework of Java, which we'll be making use of directly here to write down the code and understand the whole concept of hashing. So what happens basically is, so let's try to understand that first and then I'll come to the coding part. Suppose I'm using the concept of hash map. Okay. Now hash map is kind of a associative array where there are two fields. Okay. One is your key and other is your its value. Okay, so this pair is always stored in hash map as well as in hash table. Both is same, just with a few minor differences, which I'll tell you what is the difference between them. So key and value pair will be there in both hash map and hash table. Taking example of a student data. Okay, so every student will have a name, and suppose that student name will have a roll number as well. Okay, so every name of a student is associated with roll number. Let's take few examples. For example, Priya is a name and the roll number of student Priya is 3. Pooja is another name of a student. Roll number of the student Pooja is 2. Then Rohit is another student whose roll number is suppose 6. Okay. Now, how hashing works here. So what happens is when we create a hash map and store these values there, backend what happens is that this particular key, that is Priya is a key here, Pooja is a key here, Rohit is a key here, and these are the associated values with that. Okay, so for the key Priya, this Priya will be passed to the hashing function, which is an inbuilt hashing function when we use the concept of hash map and hash table. In fact, for every other objects which we create of the wrapper class in Java, there is a hash code. I'll show you the implementation or whatever I said right now in the IDE also. But try to understand first here the concept, the logic. That is, the student Priya is passed in the hashing function and it generates a hash code. Okay, and suppose this hash code is generally a very lengthier one, like it will have 10 digits or 11 digits or something like that. So which is you can do modulus operator on this and reduce it to a smaller number also, like suppose mod 10 I do, then I'll get one single value, right, of as a hash code. So you can do that, but normally, like by default, a longer 10 digit or 9 digits or 11 digits, some this kind of a hash value is generated. Okay, and depending on that hash value, suppose the hash value, and after doing mod operator or reducing it to a smaller size, I get a value of maybe 20. Excuse me. Okay, maybe 20. So in that case, this what will happen that at the backend at location starting from 0 somewhere at location 20, this information Priya and its roll number, the other value also, that is 3, both of these will be stored, Priya and 3. Getting it? Similarly, for the key Pooja, only as key will be Pooja here, the name of the student, which will be passed to the hashing function, and hash code, one hash code will be generated. And that hash code, suppose generated is maybe 25. So at 25th location, okay, the information about the key Pooja and its associated value, that is your roll number, both will be stored there. So Pooja and associated roll number, that is 2, will be stored there. Getting it? So this is how the hashing concept or hash code concept is being used by these two collection frameworks or the concepts of collections of Java. Now let's see the implementation or coding part of it, and let's go to the IDE now. Okay, so here you can see I have already created a class named as hash, and there is a main method public static void main here. So now let's go to directly seeing how the concept of hash code actually works in a real scenario. So for that, I'm going to create a hash map. Okay, so hash map, as I said, it takes two values, the key and the value of the other element. That is the example we saw, name and the roll number, right? So two values will be there. So similarly, you have to provide the data type also for those two values. So if I take name and roll number, the same example, continuing further as implementation, then name will be a string value and the roll number will be an integer. So let's take a string and then integer. Okay. After that, we should give a name to this hash map. Let that name be student. Okay. Then new keyword, which is equal to new keyword, which is used for allocation or creation of an object or allocation of space basically for the student hash map. So okay, new keyword, and then again hash map, and then again you have to provide the data types which we have already provided, that is string and integer, and then round brackets and colon. That's it. Okay, it's showing some error. Let's see. I think you have to import it. So yeah, let's import this hash map. Okay, so hash map is declared here now, or created here basically. Now let's add the student information, that is its name and roll number. So to do that, we use a concept of or we use a method that is called as put method. And how it is called? So let's see, student dot put, and in the bracket you have to provide two values. First will be your name, that is maybe your, let's take Priya as a name, and let its roll number be, this will be a integer value, so 3. Okay, so I'll just copy paste this again and again just to save time, guys. So if you put here 3 students, suppose I'm going to put, so Priya, Pooja, okay, Rohit, okay, these are not my friends, just simply I have taken the names, and suppose 7. Okay, now to get the information, like, okay, I have stored it, now let's check has it been stored correctly. So if you'll give a key here, it will give you the value, that is the roll number of that person, the student, as an output. To do that, how can you use, just see here, student dot get, okay, okay, we'll do one thing, let's put it under the for loop so that we can use it for all. Now, again, for before putting it in the for loop, there are two ways by which you can iterate over a given hash map. Let me tell you both of that. So two ways are there by which you can iterate over a hash map. Okay, one is by simply using the concept of set, and other is by using the concept of entry concept. And that, what is that, I'll tell you. So first, let's see the concept of set. Okay, so what you will do is we'll create a set here which is of type string. So all these data of the hash set will be converted as a type of set. So let's create a set first here. Okay, and to do that, we use set class and then string, the data type for that, and then any name you can give. I've given data as a name of the variable of that set variable. So data on, and then we can call student dot key set. Okay, so I'm going to make the student hash map as a set of data or a set of keys. Okay, I think we have to import this also. Okay, let's import that. Now we can use for loop on this. Okay, so I'm using for each loop concept where string I for data. What I'm going to do is I'm going to print. Now here I'll use the get method. So get method, put method was used for storing the data. Similarly, get method is used for fetching the data. So get of I. So we can see here. Now let's run this code. So you can see that with respect to all these names, all these keys, we got 3, 2, and 7 as here values for them. They're all numbers. Now suppose you want both to be printed, the key as well as its value, that is the name as well as their all numbers. So for that, you can use another concept is there, which is your entry set concept. Let's see what happens there. Okay. Okay, so after this. So in this, what we'll do is we are going to create entry set. Okay, and this takes map dot entry, and the data type will be a string and integer, because this time we are creating in pairs, this entry set. Okay, so it will be in pairs, a string and then integer, the name and the roll number. Okay, and then let it be data1. I just change the name of student dot entry set will be called as a function, then semicolon. Okay, this is how we create a entry set. Okay, now using this again for each loop on this entry set, we are going to iterate over the given hash map. So for again, but here there you see that data type was string, right? But here the data type will remain same, that is map dot entry. This will be the data type, and here you should write string, and then you should write integer I colon over data 1. Okay, so in this we are going to iterate, and then I'm going to write the same thing that is I dot. Okay, the here function is get key. So this will tell you the complete key, that that is your name of the student as well as its roll number together, because you've created the entry set. Okay, so get key will give you the key, and then you can have again I dot get. So you can see here the get key, get value, get class, three methods are there. Get key we used, which will tell you the string part of it. When get value you do, it will tell you that integer part of it. So we'll use get value. So both we can get the key and the value, that is the name and the roll number of the given student. Okay, so that's it. We'll save the file and then just let's run and check. So you can see here, this is the output of the earlier for loop. And then this is the output of the second one, that is entry set we used. So this is how we iterate over it. Now, let me here tell you where is the concept of hashing here used. Okay, although I have told you that when this particular set, that is the hash map, that is the name of the student and roll number is stored somewhere, first the hash code is generated for it, and then it decides the position of that particular data to be stored at the backend. Let's print here I dot hash code. So you can see here the hash code is an inbuilt function already in Java, which helps you to get to know what is the hash code generated for each of this data. So I here is nothing but the key, that is the string part here, that is the name of the student in this example, that is Priya, Pooja and Rohit. Okay, so let's see what is the hash code generated. So guys, you can see here, okay, I will just comment out some of the lines, okay, so that it's easy to understand the output. So you can see the output here. So it has generated the hash code. First one is for Priya, the second one is for Pooja, and the third one is for Rohit. Right? So this is the hash code generated. Okay, one more thing. Okay, it's not necessary always that this is how the order will be. So let's print this for that matter and check what is exact hash code. So 3 is the roll number. So 3 is Priya itself. So its hash code is this one. Then 2, its hash code is this. And then 7, its hash code is this. So you can see how longer hash codes are generated by default. So most of the time what we do is we get mod of n, and this mod of n we do. N is nothing but the total space that is there. Suppose initially we use a number of, suppose we are using arrays to decide the position. So suppose the array size is 10. So we'll do mod of 10. What is the total complete size where these data are going to be stored? That becomes your n, that is used as a mod here to bring the complete hash code to that range. So if you do mod of 10, it will come to the range of 10 storage space. Okay, 10 indexes. If you do 12, it will come to 12 indexes. Okay, so in that range it will come. So let's see what's the output after that. So you can see here for 3, the 3 roll number, that is Priya, the hash code is 9. For 2, the hash code is 2. For 7, hash code is 0. So you can see it is stored at that particular location ranging from 0 to 9. When you do mod of 10, it is 0 to 9. Okay, so these at the backend, what would have happened is that these particular data would have been stored at this particular indexes. So that's how the concept of hashing works inbuilt or by default in Java programming. If you can see this by the whole help of the concept of hash map, or even if you don't create hash map, like suppose directly I create a string here, a is equal to and hello suppose, and if I try to print, okay, this will be capital S, and if I try to print a dot hash code, then also you can print the hash code value. So it's always that there is a hash code generated. So this is the hash code for string A. Okay. So that's all about the concept and implementation of hash map and hash table. So hash table, guys, it's similar in implementation, just that here you have to use hash table in class. And then you have to import this as well. And that's it. It will work in the same way without any error. Okay, but there is a difference between hash map and hash table. Okay, one is your hash table is your synchronized and hash map is not synchronized. Hash tables are thread safe, so and hash maps are not. So that's a different concept here. altogether, but that's how hashing is implemented using Java programming.
Now we are in our next topic, which is linked hash map. Okay, so it's nothing but combination of your linked list and the hash map. So how linked hash map will help you in operations such as searching, deleting, and other methods, right? So let's check those with the help of a demonstration. So here's the code for linked hash map. So what I'll do is I'll explain line by line how linked hash map can be implemented and what are the different methods in regard to the linked hash map. Right? So first of all, we need to import this library, that is java.utility, completely. Okay, so because we are using different classes of this java.utility, that is the reason we have put a star here. All right, or if you want individual, you can do that as well. Now here we have our class LinkedHash Map, and then we have our main method. Fine. And then this is how we are going to create instance of your linked hash map class. All right, so linked hash map, here in the place of key and value I have string. Okay, it's up to you. If you want integer here, you can make it integer. If you want string, you can make it string. All right, so in this case I want to store the country names with the capital city. Okay, so wherein both are of type string, so that is the reason I have defined them as string in the angular brackets. And then I've given LH map as the name for this particular instance. And on the right hand side, I'm going to allocate the memory for my linked hash map. Fine. Now, the most important thing here is how different is this linked hash map from other collections. Okay. So it maintains the order in which you are going to insert the key and value pairs inside the linked hash map. Okay, so for example, if I have inserted Oman Muscat, that will be the first one in your linked hash map. Next, it is going to follow India with Delhi. Okay, so it is going to maintain that insertion order. Okay, we'll see that with the output. Fine. So with the help of put method, I'm going to insert these key and value pairs into my linked hash map. Fine. So after insertion, we will also check out few different methods. Okay, so first of all, we are going to print the contents of our linked hash map. Just simply use this object LH map. Fine. And then we are going to print the size of our map with the help of this method size. And then for any key, you can get the value. Okay, so that can be done with the help of this get method. Okay, so LH map dot get Oman. Okay, similarly, if you want to get for like Russia, okay, you can do that as well. So let me just change it. Fine. So you can pass any key here, and then I'm going to check, does it have Russia key, yes or not. So dot contains key is the method to check if a key is present in our linked hash map or not. Okay, it is going to return true or false, a boolean value. Fine. So this is your dot contains key method. And then if you want to delete any particular value, okay, so what you can do is you can use the dot remove method as I have typed it here. Okay, so I'm going to print that I have removed this particular element from my map. Okay, that is what this dot remove method will do. And then finally, again, we are going to simply display the contents of our linked hash map. Fine. So let's execute this first and then try to modify and see what are the different things related to a linked hash map. Fine. Let me just save it and then run it. Okay. So can you see here? This is the way I have inserted my values in the linked hash map, right? So first we have Oman Muscat, then India Delhi, right? And then Russia Moscow, and then Japan is equal to Tokyo, right? And the size of our linked hash map is 4, and the value present at the key Russia is Moscow, right? Key are nothing but the hashed code, right, which can contain some value, because the hashing code will help you for the faster operation for retrieval or deletion or any other operation. And then we are going to delete the element Oman with the value Muscat. Fine. And then we are going to simply delete the latest content of our linked hash map, which is India, Russia, and Japan, because we have deleted the Oman and Muscat key and value pair. So we have deleted that using this dot remove method. Now, this linked hash map can also contain null value in the place of a key. Let us check that. So what I'll do is I'll simply type null, and then let me store Tokyo itself. Let me try this. So LH map. Yes. Fine. Let me save it and let me run it. Fine. So can you see here? It is storing this value Tokyo with the null key. Okay. So one null key is allowed in a linked hash map. Okay. Can you see here? Now what I'll do is I'll try to store one more null key. Okay. And let's check what will happen. So what I'll do is this time let me store something like Canberra. Alright, and now let's check what will happen. Okay, so can you see here? It ignored the null comma Tokyo pair, and it has considered only the latest null key and value pair, right? Which is null is equal to Canberra, null is equal to Canberra. Okay, so it is going to store only one null key, not more than one. Okay, so that is how a linked hash map works, right? So can you see here? We have two, right? Now let me store null here as well. Okay, let me do that. Let us check what will happen. Okay, now let's run it. So null is equal to null. Can you see that? And then let me give null here, and this time let me Maldives. Okay, and this will be null. So let's check whether it will store two null values or not. Okay, so we have two null values and one null key. Okay, let's check whether it will work or not. So let me run it. Okay, so let me show you what is happening over here. So can you see here? It is storing null is equal to null. Okay, plus it is storing null as the value. So you can store more than one null value, but you cannot store more than one null key. Only one null key is allowed. That's it, not more than one. So this is how a linked hash map works, and this is how it is different from other collections. It will maintain the insertion order. You can store one null key, not more than one, but you can store more than one null values, right? So here I have stored two null values, right? Can you see here? So this is how your linked hash map works. So I hope with this you have understood all the methods and the instantiation part of a linked hash map. Thank you. Now we are in our next topic, which is HashSet. Okay. Now this HashSet collection implements the set interface. Okay. And here you cannot store the duplicate values, right? Because that depicts your set interface, right? So duplicate values are not allowed in a hash set, right? But the values can be null. Fine. So how does a hash set work and what are different methods of a hash set? Let's try to understand. So this is the code or the implementation of hash set. So we need to import java.utility to make use of this hash set in our program. Now this hash set needs only one argument, that is we are going for string in this particular example, right? Similarly, you can store or you can pass integer, string, float, any other data type, right? But in this particular example, we are going to use string. This is the instance what we are going to create for a hash set. And on the right hand side, we are going to allocate the memory using the new operator, right? So it's not mandatory to write string here as well, right? And then instead of put method, okay, we are going to use the add method to add the elements to our collection, right? So here we are going to use the add method to insert values to a hash set. Fine. So similarly, we are going to insert 3 values in our hash set, right? How do we do that? Simple. You have created an object of hash set here. So headset dot add a country name, Italy, right? So once you execute this statement, that particular country name will be added to the hash set. Now it's not mandatory that it should follow the order in which you are giving it, right? So set has its own set of rules, right? So here internally hashing is being applied for the values and a hash table is being created to store all the values with the hash code, right? So if you perform any operation such as search, delete or insert, that particular hash code plays an important role. Fine. So it's a combination of hashing and the set properties that gives you your hash set. Fine. And then once I've inserted, we are going to check the contents of our hash set. Now what I'll do is let me add one more content. So headset dot add, let me add one more country. So let me add Maldives. Okay. Let me add Maldives and end it with a semicolon. Fine. Now I've added 4 countries here, right? And then what I'm going to do is I'm trying to demonstrate the remove method. Okay. So headset.remove will find out this particular element, that is Cuba, and try to delete it from our hash set. And then here I'm going to type Cuba, right? So after removing Cuba, what is our latest hash set list? Fine. And then we are going to check using the contains method if this particular country, Italy, is present in our hash set or not. Okay. So it is going to return a Boolean value that is true or false. Fine. And then we are going to iterate through our list, right? So here we are going to iterate over our hash set. So for that, what we have done, we have used the iterator method, headset.iterator, while vals.has next, that is if any element is present, right? It will return true. And once it is true, we are going to print the contents using vals.next. So again, this next method will check if there is any element present or not. Fine. So first, let me execute this and let's check the output. So can you see here? We have 4 country names: Cuba, Maldives, Italy, Russia. But the insert order was Italy, Cuba, Russia, and Maldives. Can you see that? It is not going to maintain the insertion order. Fine. And then after removing Cuba, with the help of this remove method, we are seeing Maldives, Italy, and Russia. Fine. And then we are going to check if Italy is present in our hash set or not, in the list or not. So it returned true. That is the Boolean value. Fine. And then we are going to display the contents of our hash set. Fine. Now let us check few more things. Okay. Now what I'll do is I'll try to insert a duplicate value. Okay. Let me insert this Maldives second time. Okay. So let me write here duplicate value. Okay. So let's check if it will print this or not. So I'm running it. Can you see here? It is not going to print that particular duplicate value. Can you see here? Cuba, Maldives, Italy, Russia. That's it. Fine. Now let's insert a null value and check whether it will take or not. Okay. Let me insert null. Let me save it and let me run it. So let me just write a comment. So null value. So if I run it, can you see here? It is considering the null value. Fine. But it will not take the duplicate values. Now let me insert one more null value and check whether it will take or not. No warnings. Let's go and check. So can you see here? Only one null value, right? Because set property says no duplicates, right? So this is what it is depicting over here. Fine, let me just delete that. All right. So no duplicate values allowed in a set, but a null value is allowed. That too only one. Now what else? There are different methods on which you can try out your HashSet properties. Fine. So HashSet plays an important role because here it's a combination of the hashing technology plus the set properties, right? So this plays an important role whenever you are, building an application or writing a Java program using collections, right? So that is why a HashSet collection is a very, very important concept. Fine. Similarly, what you can do is you can create one more instance. So let me just copy this. Okay. And let me just write it here. So headset 1. Okay. So what I can do is using this, okay, I can insert some more values. Headset 1 dot add, let me write some country name, USA. Fine. And let me just display that as well. So this will be headset 1. Fine. So if I run it, so can you see here? USA. Right. Now this instance is different and this instance is different. Fine. So remember that. This is a different instance what you have created and this is a different one. So in headset you have these countries as values and in headset 1 you have USA. Fine. So I hope with this you have understood what is a hash set. Okay, how does it work, what are the different properties and methods with which you can explore hash set collection. Fine. Thank you. Now we are in our next topic, which is linked hash set. Now, what happens in linked hash set? So it's a combination of linked list with the set properties, right? But the most important thing to note here is it will maintain the insertion order. Okay, so unlike hash set, linked hash set will maintain the insert order in which you are going to insert the elements in a linked hash set. Okay, and it will also store a null value. But what about duplicate values, right? Will it store or not? What we'll do is, to try to understand this better, we'll quickly move to the demonstration part and check all the properties of this linked hash set. So this is our implementation part. So here we have this code. Okay, don't worry, I'll explain this line by line. So first of all, we need to import this java.utility.linked_hash set, right? Because all our collections are present in this java.utility library. Fine. So once you've done that, we can begin our programming with the class. And then we have our main class. All right. So first and foremost thing when we start implementing our main method is we need to instantiate our linked hash set. Fine. So for that, what I've done, linked hash set, I want string data type as my values. Fine. So I'm using that. You can use anything. You can use integer, float, double. Fine. And then I'm going to create an object of type linked hash set. And then using the new method, I'm going to instantiate the memory. Fine. And then what we're doing is we need to insert or add values to our linked hash set. Fine. So for that, what we are doing, we are using the add method, just like the hash set. Fine. Now the major difference here is in hash set, it does not maintain the insertion order, right? But here it's a combination of the linked list and the set interface, right? Combination will give you the insertion order method, right? So say for example, if I have inserted in this particular order in my linked hash set, so the same order is being maintained here. Fine, we'll check that. And then first what we are going to do is we are going to print the contents of our linked hash set. Alright, then we can also print the size of our linked hash set with the help of this size method. Okay, and then we can also check if any value is present in our linked hash set or not with the help of this dot contains method. Okay, so here we are checking if CCC is present in our list or not. Similarly, with the help of dot remove method, you can remove any content of your linked hash set. Fine, and then finally we will also print the latest collection of our linked hash set. Okay, so what I'll do is first let me run this code, then we will also check out few more properties of our linked hash set. Okay, so let me save it and let me run it. Okay, so can you see here it is displaying the same contents in which it was inserted: AAA, BBB, CCC and DDD. Fine, and the size is 4. And next we are going to check if CCC is present or not with the help of dot contains method. So this will return only the boolean value whether true or not. And then I'm going to remove DDD from my linked hash set. So the latest values present in my linked hash set are A, B, B, B and CCC. Triple D was removed with the help of dot remove method. So now what we'll do is we'll try to add same content. Okay, so what I'll do is let me add lset dot add. Okay, let me add AAA. Okay, and then let me also add a null value. Okay, let's check whether it will take or not. And this comment, let me put it beside this, and here let me just write add null. All right, so let's see what will happen. So semicolon outside, yes. So what is happening here? Triple A is being considered only once, that is no duplicate values are allowed here as well because it is following the set properties. And null is allowed, so it is being stored. And now the size is 5, C is present true, so the latest collection is AAA, BBB, CCC and null. Okay, so no duplicate values are allowed in linked hash set as well. Okay, because it is following the set properties and it says it will store only unique values, right? So it is not going to store the duplicate values here. Fine. Now the most important thing is whenever you're trying to store such contents or values in your collection, here internally a hash table will be created with hash codes, right? So whatever value you're trying to store, each value has an associated hash code, right? So for operations such as displaying the contents, displaying the size, or checking if any value is present, or delete using the dot remove method, all these operations are quicker because of this hash code and the hash table maintained in the background. Okay, so these play a very important role in our Java collections. Fine. So I hope with this you have understood how this linked hash set works. Okay, let me show you one more thing as well. So this is not mandatory. Okay, this will also work because on the left hand side, if you mention, it is understood that the same value you are going to pass it here. Fine. So let me also show you one more thing. So let me copy that and let me paste it here. Okay, so here I can create one more instance, okay, with the help of linked hash set class. So here it is going to implement the set interface. Okay, remember that. Now after this, what I'm going to do is here let me just write lset2. Okay, lset2, and here let me add null. Okay, that's fine. Okay, so now let's check what will happen. We should also print the contents, right? So what I'll do is I'll copy this, I'm going to paste it here, but this time it is for the next instance lset2. Okay, let's see what is happening. So can you see here linked hash set contains AAA. Now this is a different instance what you have created, right? And this is different. Okay, so here for the second instance I'm just going to print the content which is AAA. Okay, and then Let me add this null value as well. Okay, so now if I run it, let me add two null values and check what will happen. Okay, so will it take one null value or two null values? Let's check that. So what is happening? It is considering only one null value. Okay, so I hope with this you have understood what is a linked hash set, how is it different from a hash set. So here the important thing to note is it maintains the insertion order, unlike a hash set. Okay, so with this, let's conclude this linked hash set. Thank you.
So yes, now we will see about Java multitasking. Before start with Java multitasking, let me give you an example. For that, you can understand what is this multitasking stands for, right? Did you ever think how can a computer or a machine perform multitask concurrently when it has single processor, right? So do you ever think what is happening inside your computer when you browse a web or listening a song or writing an essay or playing game at the same time? The main idea behind this is sharing the same memory, right? Your machine divides its attention between separate time and in the ways it can use the maximize the resources of your machine, right? So this is where multitasking comes into the picture. Now let's see what is multitasking in Java. So multitasking is a process or an ability to perform multiple activity concurrently, and this can be divided into process based and thread based. So multitasking has a two part, right? One is process based and second one is thread based. And multitasking is used to utilize the CPU of your machine. And multitasking has two way. I already defined this previously. That is process based and thread based. So what is thread based multitasking in Java? Thread-based multitasking helps to run different parts of the same process simultaneously. Let me give you an example. For that, you can understand what is thread-based multitasking. Suppose a person using his or her MS Word to print and also format the text, right? This is also multitasking, right? So thread-based multitasking share the same memory, and communicating between two threads is less like communicating between two threads is less expensive and thread is lightweight, right? Where process is heavyweight. Now we will see what is process-based multitasking. So process-based multitasking stands for processing multiple processes to execute concurrently, right? Suppose an example is a person using his or her computer to listen a song as well as working on software, right? So each process has separate memory area in computer. This is the difference you can say in between thread and process, where thread using a same memory location and process use the separate memory area in the computer, right? And communicating between two processes costly and process is heavyweight, where communicating between two threads is less costly, okay? And switching from one to another thread is time consuming, right? So this is the difference between thread based multitasking and process based multitasking, right? Now we will see Java thread, right? So I was talking about thread based, but what is thread? Thread is the smallest part of the whole process, which is lightweight in nature and can run concurrently with other parts of the program. Okay, threads are small and independent. It has separate path of execution. And if one thread get the exception, it does not hamper the other exception because of its separate path. Suppose you have multiple thread in your program. So one thread suppose got the exception, but for that your program will not stop. The other thread will still remain continue executing because all the thread has its own separate path, right? All threads share a single memory, right? So because of this, thread is less costly and using thread is quite usable as well, right? You can say that. Now we will see what is multithreading Java. So multithreading is Java stand for execution of multiple threads simultaneously. In Java, multithreading and multitasking both are used to achieve multitasking in Java. Okay, but multithreading is popular than multitasking because it uses the same shared memory. When you use the same shared memory, your program will less costly and effective as well. So for that, multithreading is popular than multitasking. And if one thread get the exception, I told you before as well, if your one thread get the exception, it does not hamper the other exception because of its separate path. Multiple operation can be done using multithreading, and it saves times and money as well. So this is the concept of thread in Java and the multi-thread in Java. And we will see how can you create a thread and how can you create multi-thread in a single program as well. Now we will have a look at what is the life cycle of the thread, right? We all human beings have our life cycle. We born, we live our life, and we go for day, right? So there is for the thread also they have their own life cycle. So let's have a look at what are the life cycle, what are the stages they have in their life. So basically there are all total 6 parts in their life cycle. So life cycle of a thread has 6 parts, which starts from creating a thread till in the thread. So we have new, we have runnable state, we have block state, we have waiting state, we have time waiting and terminated. And now we will have a look at each of them. And after knowing all those states, we will implement those states in a Java multi-threading program, right? So first start with new state. So what is a new state? So a new thread begins its life cycle in the new state. It remains in this state until the program starts the thread. It is also referred to as a born state. So basically we can consider this state as a born a baby. The way a baby born, the same way the thread born by using new state, right? When the thread is born, we can call that this is in a new state. Now comes the runnable state. So in the runnable is basically after a newly born thread is started, the thread becomes runnable. Okay, a thread is in this state is considered to be executing its task, right? So basically when we say our thread is in a runnable state, right? So in that mean your thread is actually executing the task you have given to that particular thread, right? So actually it starts working. Okay, so in that case, we can refer that state as a runnable state. Now we will have a look at the blocked or waiting state, right? So what is blocked or waiting state? So sometimes a thread transitions to be waiting state while the thread waits for another thread to perform a task. A thread transition back to the runnable state only when another thread signals the waiting thread to continue executing. Right? Maybe you are working with multiple threads, right? So you want to a particular thread to be blocked for some times, right? In that time, we are going to use blocked or waiting stage. Okay. And after your work is done with the other thread, that time you can again say, no, this thread, I put that thread in a blocked or waiting, they can start working. Right? So in that meantime, when the thread is not working, the state is known as blocked or waiting state. Right? Now we will have a look at what is time waiting. Okay, the thread is in time waiting state when it's called a method with timeout parameter. A runnable thread can enter the timed waiting state for a specific interval of time. A thread in this state transitions back to the runnable state when that time interval expires or when the event it is waiting for occurs, right? So this is how where we use that time waiting state. Now the last stage of the thread is terminates. So terminates in state used to exit the thread, but this termination happen because of many reasons like normally or some unusual error occur, right? So basically if you want to stop some of the thread, like to just make them, no, we don't need this thread anymore, so that time you can use the terminate function. Or sometimes we got some unusual error for our thread, that time also with this terminated state can be come, right? So basically terminated a runnable thread enters the terminate state when it completes its task or otherwise terminates, right? Once you have give the task to your thread, it's already done, so it will go to the terminate stage, because that thread knows that it like they has nothing to do, right? They have nothing to do right now, and they are actually going for their last state, that is terminated state. Or some of the unusual reason can be occurred for that thread throws into the terminated state, right? So this is the life cycle we get from a thread. So this is the whole life cycle of a thread. Okay, now we will have a look at how can you create a thread. But before start with that, let me tell you that thread have a priorities as well. So every Java thread has a priority that helps the operating system determine the order in which threads are scheduled. Java thread priorities are in a range between minimum property, a constant of 1, and maximum property, a constant of 10. By default, every thread is given priority norm priority, that is a constant of 5. Threads with higher priority are more important to program and should be allocated processor time before lower priority threads. However, threads priorities cannot be guaranteed the order in which threads execute and are very much platform dependent. Right? Now we will see how can you create a thread. So creating a thread can be in two ways. First way is if you want to extend the thread class, and the second way is implementing runnable interface. So we have two ways to create a thread. You can extend the thread class or you can implement runnable interface, right? So what is class and interface? This is a basic concept of object-oriented programming. I hope you guys have a proper idea about what is the difference between class and an interface, right? Okay, now we will have a look at the code. How can you do that? So here my class name is thread2. And always remember that this is a convention of Java. When you start writing any code and if you are giving any name to the class, that class name should start with the capital letter, right? So here my class name is thread2 and I give like the T is in the capital letter. Now I'm going to extend the thread class. Okay, class is always be extend, and the interface we cannot extend. The interface we always implements, right? Now when you go for using the extend thread class, always you need to write, like you need to override the run method. That is, I have public void run, and in that what I said, I just said if I use the run, basically what it happened, I told you in the life cycle as well. When you just born the thread is born, right? But after that we need to invoke that particular thread to in the run state to say, okay, you have born, now please start working. For that we need to override the run method. Okay, so what we have done in the run method, I said, like I just want to print that thread is running currently, right? So I said system.out.println, we use this for printing, like if you want to print any object in the Java. So I said in the system.out.println, I just want to print thread is running currently, right? After that, we need to have a main method, because in Java, the program starts from the main method only, right? So I have declared in main method that public static void main string args. I said, I just want to create an object of class of my thread2. So what I did, I use object name m1. So thread2 m1 is my object name, and I create the new object. How? Is equals to new thread2. Right? Now I want to start my thread. How can I do that? By calling the dot start function. So m1 dot start. So you can see in the output we will get thread is running currently. So here we are seeing all these examples theoretically, and I will do all this program in Eclipse as well to give you a proper example that how actually we are going to do and what are the outputs we are going to get, right? Before that, I want you guys to understand the concept properly to go further with the multithreading in Java, right? Now we will see the second one, that implementing runnable interface. So when I'm saying that you are going to implement a runnable interface, that time we are not going to use extends, right? We are going to use implements function. So here my class name is thread demo1 that implements runnable. Okay, here also you need to override the void run function. I say the same thing, thread is running currently. Okay, but here there is the catch, right? How we are going to create the object for that. So first I need to create the object, that is thread demo1. T1 is my object name, and I'm creating the new object for my class using new thread demo1. Now I need to create an object for thread, right? So what I did, I said thread T2 is equals to new thread, and I'm passing my object of thread demo class, that is T1, right? After that, what I need to do, I just need to write as samely T2 dot start, and your thread will be started, and you can say it will give you an output of thread is running currently, right? I hope you guys can understand that how we can create thread in two multiple ways, right? Using one, extending the thread class, and second one is implementing the runnable interface, right? Now let's have a look at thread scheduler in Java. What is a thread scheduler? I have told you guys before as well what is thread priority in Java. Now let's see what is thread scheduler. So thread scheduler is a part of Java virtual machine which decide the sequence of thread. So basically we don't decide the sequence of thread. This thread scheduler is actually going to decide the sequence of your threads. If you use multiple threads, so then your thread scheduler is going to get the sequence of that. In Java, one thread can run at a time. Okay? So in Java, what we have, we can say that only one thread, right, can run at a time. Because if you want two thread will run in the same time, that is not possible. So there is a limitation we have that one thread can run at a time. There is no sequence guarantee for which thread to get executed, right? So you cannot give the guarantee if you have multiple thread in your system on your program. So you cannot give the guarantee maybe one will go first, two will go second, right? It's all depends on the thread scheduler. So we will have a look at that as well in the demo part. Now let's see what is sleeping thread. Okay, it's actually sounding little mysterious. Let's see what is sleeping thread. So sleeping thread is called as using the sleep method of thread class to sleep a thread for the specified amount of time. So basically, if you want to say, I don't want my thread to work right now, I want to make that thread sleep. Okay, so how can you do that? Using sleep method, you can make a thread sleep for specific time. Okay, thread class has two specific methods to call sleep for a specific amount of time. Okay, so first one is, if you want to just call this sleep function, how can you do that? So doing that, I can say public static void sleep function. Under that, I can say long milliseconds. So how many milliseconds you want that your thread should be in a sleep state. Throws interrupt exception. So it can be throw an exception. So in that case, we say that throws interrupt exception. Or the second way is, you can say public static void sleep method, and you can say long millisecond, and second parameter can be int nanos. And again, it's going to throws interrupt exceptions, right? These are the two ways by which you can actually call your sleeping method to make your thread sleep, right? Now, we will see a demo of it. How can you do that, right? So in this case, you can see I have a class called demo sleep thread, actually which extends thread, or you can use implement runnable methods as well, right? So it's up to you which one you want to go for, right? I just want to override the class of void run. Then I said in for loop int equals to 1 and less than 5. So basically my loop will go till 4, right? It's less than 5 and I plus plus. try, we use try and catch block to throw a exception, right? To check a exception and catch. If it's actually get an exception, it will show that what actually the exception we got, right? So we use try catch block for that. In the try, I said thread.sleep. I want to make my thread in a sleep position for 1000 millisecond, right? So you can see I give for 1000 millisecond. Then I use a catch function. I mean, in that I said what are the exception, that interrupted exception if we got, and E is the object of that interrupted exception, right? And I'm going to system.out.println and I'm going to see what the exception I got, that is E, right? And lastly, it will give me that if it's in the try block, if it's not in the catch block, if it's in the try block, then it's going to give me the value of I, right? So then what we need to do, we need to call two function over here, two thread, right? So because if the first thread is in the sleep, then second thread will start working, right? So in that, I created two object of the thread, right? How can I do that? By creating an object of my class, that my class is demo sleep thread. T1 is equals to new demo sleep thread, the function. Then I'm calling again demo sleep thread T2 is equals to new demo sleep thread, right? So I say just a start for T1.start. If you want to use, you can use T2.start as well, right? Then you can see that in the output you will get 1, 2, 3, and maybe you can get the same number 1, 1, 2, 2, 3, 3, because you actually your one thread is becoming in sleep when the other thread start working, right? So we will have a look at these things as well in the demo part, like what actually the output we are going to get, right? Now let's have a calling thread twice. If I want to call a thread twice, what will happen then, right? If I want to play with this thread thing, how can I do that? So twice calling the start method for one particular thread is not possible. But if you call twice, then a illegal thread state exception is thrown, right? So what I did, I just want to play with my thread. I just want to see if I want to call my thread twice, what it will give. But your thread will say, sorry, you will get an exception, right? I'm not going to take start for twice, right? So what I did, I have a class saying thread2 and I extend the method threads where I override the run method, that is public void run, and then I'm going to just print that thread is running currently, okay? Now what I want, I want to create an object of thread2 class. So I create m1 an object of thread2 class calling new thread2. Now I'm going to call m1.start, m1.start 2 times, right? You can see first time it took the start, thread is running currently. For that, we got the output. But in the second time, it gives me an exception in thread, that Java lack illegal thread set exception. So you cannot call twice a particular thread, right? Okay. Now we will have a look at call join method. So what is call join method? So join method in Java threads waits for a thread to die and it causes the currently running thread to stop executing until the thread it joins with completes its task, right? So what actually it want to say, right? So basically join method wait for a thread to die. It's actually wait for a thread which is going to die, okay? And it causes the currently running thread to stop executing, okay? Because it does not want that two threads will start like fighting with each other, right? Okay, so for that, the current running threads to stop executing until the thread it joins with completes its task, right? For that, we use join method. So you can see in my join method in Java class, I extend the thread and then in the run method, I'm going to write for loop, okay? That for loop is start from 1 and go till 4, okay? And after that, I'm going to use a dot sleep method. and the millisecond will be 500 millisecond. For that, your thread will be in a 500 millisecond state. Okay. Then what I did, I actually create some of the object of my join min method in Java. So I create T1, T2 and T3. Three thread in join method Java. Now what I do, I did this T1 dot star. Okay. Try, in the try block, I said T1 dot join. And I said in the exception, if you want to throw any exception, in the exception class, I called the object and I just said system.out.println e, right? And then I called T2 and T3 for the start, to start the thread. Okay, this is how we use join method. And we will have a look at all of them, that what will be the output you are going to get in the Eclipse. So now we are going to use Eclipse IDE, that is integrated development environment, to create our first thread, right? In this case, I will show you how can you create your first project with Java, right? So to create a project in Java, you need to go to File and there you need to click on New, right? From that, you will get a multiple options, but you need to choose Java project. I'm going to use Java project. Now you need to give the project name for your Java project, right? So here I want to give multi-thread maybe. Okay, so we have created the name of the project of a Java, that is multi-thread demo 1. Now we are going to click on next. So you can see there is a source folder. So if there is a source folder, it's basically a source folder for our project. So all your code, all your Java file will store under this source file, right? Now we are going to click on finish. And yes, I want to create a module info.java. Let me create it. Okay. So we have got our project multi-thread demo 1. Now I'm going to create the first class. How can you create your first class? Go to source folder and then click on over there. You will get an option of new, right? From that new, what you need to do, you need to go to class. This is the way you need to actually make your first class. So my class name will be over here, that create thread, right? So always make sure your class name starts with capital letter. This is a good convention of doing the coding, right? All the professional maintain some convention when they actually start coding professionally. Now comes the main method. This is actually the heart of Java program. So if you want to execute any program in Java, in that case, be sure always you have this main program. Say this main method. If you don't have this main method, your program is not going to run, because the main point, this first point when the program start executing in Java, that is from the main method. So we are going to tick on that, right? And now what we need to do, we need to go for finish. So this is how actually we are going to use our first class, right? Now as we have created our first class, that is create thread, now we are going to create a thread by extending the thread class, right? So how can you do that? So already we have our class name create thread. Now I'm going to write extends, and then what class name I want to actually extend, that is thread. As I didn't write the class name, it's giving me an error, right? So I'm going to write thread. Okay, so I want to extend my parent class, that is thread. Okay, now I'm going to override the void run method. So it is a public void. Void means actually it's not going to return anything, right? So then we are going to write run method. The name of the method is run and the curly bracket. Then whatever you want, you can give that, right? For my case, maybe I'm going to write system dot println. I hope you guys have an idea about what is the big difference between println and print. So basically, print is something if you don't want a space, right? So if you don't want to have a enter like a gap between two lines, so that time we are not going to use println. But basically, println, when you have multiple line of output, if you use println, it will give a one line gap between those outputs, right? So this is a very important question for the interview. What's the difference between print and println? right? Now I'm going to write, I have created my first thread, right? Okay, fine. Right, now I'm going to give the semicolon. Now what I need to do? I told you I need to create the object of my class, right? So my class name is create thread, and my object name maybe I'm going to write obj is equals to new create thread, right? And I'm going to use the round brackets. So this is how actually we create the object of our classes in Java. Okay, now I'm going to say that object dot start. So what it will do, it will start the first thread in our program, right? So I'm going to write obj dot, you can see I get multiple methods, right? So here I'm going to write start. So I got this start method. So I'm going to do that. Let's see what we will get. To execute your code, always remember that in Eclipse, you need to click this play button. It's like a play button, right? You need to execute your code. So here you need to actually say which class you want to execute. So for my case, I want to execute createThread.java, right? Okay, and let's see. You can see I got my first output that I have created my thread, right? So this is how we actually create our first thread using what? Using thread, extends threads class, right? Now I will show you the second way how can you actually create your thread using actually implementing runnable interface, right? So let me create one more class for that. Okay, so go to new, you need to go to class to create a new class. Maybe this is also create thread but two, right? Two class cannot be in same name. Now again we are going to click on the main method and then finish, right? So we got our class. Now this time we are not going to extend this, right? We are going to implement, because runnable is an interface and interface always be called by implementing that interface, right? So I'm going to write implements and then the interface name, that is runnable. Okay, so I have actually called. So I am getting a little bit of, so some of the reason runnable. Okay, so let's see, I'm getting a error. What error I am getting? The type create thread 2 must be implement the inherited abstract method runnable.run, right? So here it's giving me a error, but for the extending the thread, it was not giving me any error. But as it's an interface, it's saying you actually need to implement run method over here, right? So let's see what we can do that. What I am going to do, I'm going to write public void then run method, right? I'm going to implement the run method, then the curly bracket, right? So here you can write, I'm going to write the same thing, system dot out dot println, and I'm going to pass that I have created my first thread, right? Okay, I will write this. Oh my god. Okay, so you can see I have already implemented that and we don't have the error over here, right? Now we will see how can you call them, right? To calling them again, we need to make an object of my class. So what is my class? Create thread 2, right? And I'm going to write the object, that is obj again. I'm taking the variable name obj, that is will be my object for my this class, that create thread 2. Now I'm going to write new and I'm going to write the same thing, create thread 2 and the round bracket. This is how I'm going to create the first object of my class. But here I need to make a object of thread class as well. So thread maybe A is equals to new thread, right? And from this we actually need to pass the object of our class, that is obj, right? So you can say this is how if you want to call a thread using runnable interface, right? So now let me execute that. So what we will write, so you can see we actually our thread is running, right? Okay, but we did not get the output. So now, as we have already seen how can you actually create a thread using extending thread class, now we will have a look at how actually you can create a thread using implementing runnable interface, right? So let's first create a class for that, right? So creating a class, again I need to click on the source folder and then I need to get the new one, right? So I will get the new option and from there I need to create my class, right? So in the class I'm going to write my create thread demo, right? Again, always be sure that whenever you are going to make a class, the first element of the class will be capital letter, right? Now I'm going to click on the main method as it's the heart of Java program. Now I'm going to click on finish, right? So we get it. Now what we need to do? We need to implement the runnable class. So I'm going to write implements. Which interface I'm going to implement? I am going to implement runnable interface, right? So runnable interface, right? So you can see still I'm getting an error. But why I'm getting an error? Because my interface is an abstract method, right? It has an abstract method of run method. So I need to implement that method as well. Otherwise, I will get the error. Now I'm going to write public void. We are using void that will not return anything. And the method name is run. And after that, the curly bracket. Now I'm going to write the same thing. System dot out dot println, and in between that I want to pass I have created my second thread. I have created my second thread, right? So if when my thread is started, that time it will give me this message. Okay, now what I need to do, I need to create the object of my create thread demo class, right? So let me create that, create thread demo, and then I need to give the object name, right? So my object name is obj. I'm going to use that. Again, I'm going to write new create thread demo and then the round bracket, right? This is how we are going to create the object of our this class. Now we need to create the object of thread class, right? Always remember when you are going to implement runnable, that time you actually need to create an object of thread class as well. So thread, and again I'm going to write obj1 is equals to new thread, right? And in that round bracket we need to pass the object of our this class, so obj. Now this, right? So this is the main key over here when you are going to use implements runnable interface and we're going to use extends thread class, right? Now I'm going to start my first thread using implementing runnable. So I'm going to write start method. So I have already get that. Okay. So let's see. Let me execute it using this play button. Okay, so you need to actually select which class you want to execute. So for my case, I have only one class, so I have actually used this. I have marked this, right? And then okay. So you can see I got my output that I have created my second thread, right? So this is how you can actually create two types of thread using one implementing runnable interface and one is extending thread, right? Now we are going to see how can you implement sleep method using Eclipse or using Java, right? So let's create this, let's use the sleep method in multithread. For that we are going to use again a new class. I'm actually using new class to make sure guys you don't have any doubts, right? I can do all these things in one class. Again, that can be a problem or confusion for you guys. For that I'm making a class for each and every methods and each and every thing we are doing, right? So you guys will be comfortable with this Eclipse as well. You guys will get to know how can you make the classes, how can you make project when you start working with Eclipse, right? So again we are going to go for new and then class, and here I'm going to use demo sleep. So I'm going to make a demo for sleep method, right? So demo sleep, and again I'm going to take the main method, right? Okay, so how can you do that? For that I need to again extend the thread class. So here I'm going to make the thread using extending thread class, right? Extends thread, okay, and I am going to actually override the public void run method, okay. So I actually override that, and here I'm going to write system.out.println, and then maybe I'm going to write let's start using sleep method. Okay, so almost overriding this void run method is almost done. Now what we need to do, we need to create the object of the class, right? So demo sleep, and then we are going to give the naming for the object, that is obj. You can use anything, ABCD, anything, whatever your choice is. The new demo sleep, right? Okay, so I have created the object for my class. Now what do I need to do? Now I need to just use our try catch block in the run method, or again you can do something like for loop as well. Let's have something new in that. So in the run method I'm going to use a for loop, right? So we have done the basic, the way we actually create the thread. Now we are going to see how can you implement sleep method, right? So I'm going to use a for loop where I'm going to initialize I is equals to 1, and I will go less than is equals to 10, right? And 10. And from that I'm going to use I++ for my I incrementing, and in between the for loop I'm going to write try block. So why do we use try block? Try block is used to get, if you get any exception, if you feel like from that line maybe you will get exception, you can put that into the try block. And the catch block, if you get any exception, it will show what exception you get, right? For that in the try block I'm going to write that, okay, just a second, yes, I'm going to write that let's have thread dot sleep method. So this is how actually, so you can see we have two ways to actually implementing sleep. One is long millisecond, one is you can give long millisecond and int nanos as well. So in my case I'm going to take long millisecond. So here you need to give how much millisecond you want. So for my case I want 500, right? Or maybe I want 1000, right? Okay, now I need to give the catch block, otherwise he will give me a error for that, right? They always need to go for, if you implement try, you need to as well as implement catch block as well, right? In the catch block I am going to say, and again here you need to give the interrupted exception, right? So in that case I am going to write interrupted exception, right? And I'm going to write the object of that interrupted exception. So maybe A. Okay, fine. Now what I need to want? I want to see the exception I am going to get if my thread goes into the catch block, right? System.out.println, and then I'm going to write A. So it will give me the whatever the exception I got it, right? So this is how we are going to write it. And one more thing, if it's in the sleep, after that I want to see the I values as well, right? So system.out.println and then my I value, right? So let's see. And before that, one more thing we need to do, we need to call the start method as well, right? So let me start that. So what I need to do, obj.start. So these are the basic part we all know when we actually create the thread. Okay, so let me do that. Just execute the demo sleep. Yes, so you see I got this. Let's start using sleep method. But you can see I am getting 2, 3, 4, 5, 7, 8, 9, but with a time of interval, right? You can see I got it, but with a time of interval. Maybe I can make it to 10,000 as well. Let's see, it will take more time for that, right? This is how sleep method is working. After start doing your tasking, it will put into the sleep method. So you can see I am not getting any value. So it's actually taking 10,000 millisecond time. That is one I get. So it's taking more than the before one, right? So I change the number of millisecond, that is 10,000. You can see I'm getting 1, 2, it's taking time. So this is how actually sleep method works. Okay, so let's wait till the output we are getting over here, and then I will show you if we have two different threads, right, how it's going to work, right? So maybe here I have one thread, but if I have two different threads, three different threads, right? How my Java actually JVM is going to handle that. Okay, right. So you can see it's just 5 till now. So it's taking an actual time to get printed because they are putting the thread into a sleep method, and when your sleep is continued for 10,000 milliseconds. Okay, 10,000 milliseconds when your thread is in sleep. After that, your thread become activated, and again your thread start doing the task, right? You can see I got till 7. So let's wait for 8, 9, and 10. And after that, we will reduce the timing because it's taking on 10,000 millisecond time. So we will make it to 500. So it will not take a long time, right? Okay. So it's almost 9 and it's going to be 10. So let me just change it in the meantime. So 500 I have made. This is 500. Now what I need to do, I just want to make one more object for my class, right? So basically what it will do, it will actually call one more thread. So let's see how my JVM is going to handle that. So here I'm going to write obj1.start, right? Let's see what will happen for that. Okay, let me execute it. So you can see it's going 2 times. Okay, it's going too fast. Okay, let me do this for at least for 1,000 times, right? So it will be not that fast. Okay, so basically what my JVM is doing, it's actually taking the output, but you can see it's taking 1, 1, 2, 2, 3. What actually it is doing, it's taking the first thread, it's putting that thread into sleep, and then it takes the next one. Okay, so for that we are getting the number 1 to 10 twice, right? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, right? Because first it's taking one thread, then it's using the task, whatever the task that thread has, it's doing the task, and then it put that thread into sleep. Now the JVM taking the second thread, right? After this taking the second thread, it start doing the task, and then again put that second thread second thread to the sleep, right? This is how the sleep method works when you have two threads. Maybe I can have 100 of threads, right? But that can be handled by JVM only. And you cannot ensure the sequence of the thread as well, right? So let's see what next we have in the demo. Now we will have a look at some probability. If we can call a start method twice, then what will happen, right? Always, if you're learning something new, you should go for experiment these things, right? If you start experimenting with this, like that particular topic, you will learn more. So let's see what we have. If we just use the start method twice, what will happen? For that, again, I'm going to write, I'm going to create a class. Okay. So new and then class and twice. Let's see, twice. Twice. What? Start demo, right? This is how I'm going to write the name of the class, and I'm going to use the main method. So what are the common things we need to do? We first need to go for extending thread class. Okay, because I love to use extends thread one because I don't need to write 2 lines of code. But if you guys want, you can use implements runnable interface as well. Okay, so here I'm going to just override the class, right? Public void run. Okay, and then I'm going to write that maybe system dot out dot print ln, and then I am going to give you experiment with threads, because I always love to do something, if I am learning something new, to do experiments with that, right? So here I'm going to, now what we need to do, we need to create the object. So twice start demo, our class name, and then obj is equals to new twice start demo, right? Yes, so we have created the object of our class. Now what we need to do, we need to actually say start. So obj dot start, but in this case we are going to use start twice. Let's see what will happen for that. Let me just execute that. Okay, you can see first one we got it, that experiment with threads, but for the second start we got a lang illegal thread state exceptions. So always remind that you cannot use start function twice for a particular thread. You need to use start function one if you want to start a thread, right? You are not allowed to use twice the start function, right? So let's see. Now we are going to see what if we can call run method directly instead of start method, right? What our program or our thread is going to give us, right? For that, again, I'm going to write a class. So let me do that. So new and then class. So here what we are going to write, we are going to call run method directly instead of start method. So let's see. Run demo. Okay, public static void main string was the main one. Then we are going to extends thread, right? So then we are going to use the public void run method, and I'm going to write experiment. Okay, I'm sorry. Here I'm going to write that system dot out dot println, and then experiment with run method. Okay, let's see what I'm supposed to get with that. So I think like doing this kind of a experiment with a new thread, you will get a proper idea and a proper like vision about threads, how actually these threads are working, what's the life cycle of these threads, right. So now what I need to do, as I have said that, again I need to make a object of my class, that obj, maybe you can write is equals to new run demo, right? Okay, this is how I'm going to create the object of this particular class. Now what we need to do, normally we used to use dot start method, but here what we will do, we are going to use obj dot run method. So let's see what's going to give me. Okay, but here also we are getting the output, but what actually what's the difference between that, because each thread starts in a separate call stack, right? Invoking the run method from the main thread, the run method goes onto the current call stack rather than at the beginning of a new call stack. So this is the difference between when you are actually calling run method instead of start method, right? So let's see if we are going to call the second object, if you are going to create, right? So this is the difference between when you are going to use run method and when you are going to use start method. So yes, so obj1 dot run, right? So let's see what's going to give me. Okay, for the both cases we are getting the same thing, okay? But the thing is that that's the main problem. You are getting that invoking the run method from the main thread, the run method goes onto the current call stack rather than at the beginning of a new call stack, right? So this is the difference between run and start. How we are going to use join method in the thread? So what is join method? So we have discussed about join method earlier as well, but for the recap, let me give you a brief about join method. So join method waits for a thread to die. In other words, it causes the currently running thread to stop executing until the thread it's joined with completes its task, right? So there is a two way you can do this. So now we are going to do this in the Eclipse. For that, what we need to do, we are going to create a new class for that. Okay, so let me create a new class to do the join method. Okay, so new, and from there we will go for a class, and here I'm going to use a class name join demo, right? Okay, so this will be my class name, and I'm going to use the main method as well. So it's taking a little long time. Yes, so we got the class. Let me just click on that. So we got the class. Now what we need to do, the basic thing we need to do, extends from thread class, right? Okay. So here actually for each and every demo we are using a thread class and we are extending from that. But if you want to do these things from runnable interface, that is also can be done, right? Now we are going to do public void run method, and we are going to pass some new thing. Maybe we are going to take a for loop for that, right? So let me do that. Using for loop, it will help you to understand that how actually join method working over here, right? So int I equals to 0, I less than 10, and I plus plus, right? Okay. So now what we are going to do, we are going to use the try block, right? So why we are using try block? I told you that try block is basically, if you think that block, like the code block you have, can have an exception, can have an error, right? So in that time, we actually put that part of the code in the try block to handle that exception, right? So in this case, I'm going to write thread dot sleep, the way we are using sleep method, and I'm going to give 500 for this. So I want my thread should be in a sleep for 500 milliseconds. and here I'm going to use a catch, right? So in the catch, again, you need to write the exception. So exception is the parent class, right? So I'm using E for that. And let's see what I want to see. I want to print if it has any exception. Please show me the exception for that, right? So E, right? So this is why we are using try and catch block. Now what I want to see my I value. System dot out dot print ln I. So now I want to see my I value. Now what I need to do, I need to create some of the maybe multiple threads over here. So creating multiple threads, what we need to do, so for that we need to create the object of my this class, right? So join demo, right, is equals to maybe obj, the first object I'm creating is equals to new join demo and the round bracket. So this is how we actually create our first objects. So here I'm going to just copy the same line and I'm going to change the object name because we cannot have object in the same name, right? So yes, object 1. So maybe there will be object 2, right? So we have created multiple object of what? We have created multiple object of my class join demo, right? Now what we need to do, we are going to start our first object. So obj dot start, okay? Let's see. But now we are going to do one more thing. We are going to join as well, right? So in the try block, again, maybe in the try, there can be an exception we will get. So I want to put them in the try block, right? So obj dot join. You can see I got it already. Dot join method, right? And from there, I want to have my catch block. In the catch block, what I want? I just want exception. If I get any exception, please show me the exception. Okay? Okay. Now I want to print the exception. System dot out dot print ln, right? Just show me the exception if I have any exceptions, right? Okay. So now this is how we are going to join it. Okay, now I'm going to start the other two thread of my program. So let's see how it's going to work. Okay, I need to write obj. For that, it's giving me error. Okay, now here I'm going to write obj2 dot start. Right? So guys, whenever you are learning something, try to have increase interest for that, right? So for that time you will actually start loving that portion, loving that part of the coding. Coding is very simple. It's not at all first thing we came into our mind that coding is very it's very complicated, but trust me, it's not. It's just like a normal mathematics we do, right? So let's just execute the program. Okay, fine. You can see I'm getting 0, 1, 2, 3, but I'm getting 0, 0, 1, 1. I mean, there is no other option, right? There is no other way to find it out that what will be the sequence of your object, what will be the sequence of your thread, right? So you can see here, this is 1, 2, 3, 4, 5, 6, 7, 8 we got. Why this is so? Because we join our first method, right? So what it did actually said other thread, no, I'm not going to give you the chance to get started. So first let me get start, and then if you have time, then just go and just execute, right? So you can see, let me execute it once more time. So you will see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Why? I mean, you can see one more thing. If I can give it to 5000. So you will see that first thread we are having, that is obj, that is actually running first. The other object we have, they are not getting executed. But normally it's not the thing, right? Normally what it used to have, if any thread is in sleep, then the next one will come and start executing the task, right? So you can see I'm getting 1 and I'm getting 2. It's taking time because it's not like giving the other object of the thread like get executed, right? First the object obj will be executed, then obj1 and obj2 will be get executed. You can see 0, 1, 3, 4, 5. Right? So this is why actually we are using join method to execute our first, suppose you want that first this thread will be executed, right? The other thread will be on hold, right? So that is why we use join method. You can see 0, 1, 3, 4, 5, 6, 7, 8, 9. This is actually executing the first thread, right? That is obj, right? This is why we are using join method. Now we will have a look at how can you make your thread a name. Suppose I want to give a name to my thread. How can I do that, right? The thread class provides methods to change and get the name of a thread. By default, each thread has a name, that is thread 0, thread 1 and so on. We can change the name of the thread by using setName method. The syntax of setName method and getName methods are, we are going to check that in the Eclipse, right? Let's see if I want to change my thread name and if I want to identify my thread through the name. Let's see how can we do that, right? For that, I'm going to just create one more class, new class, and name thread demo, maybe the class name, and I'm going to use the main method as well. Right, now what we need to do, the same thing, extends thread. But guys, what I'm doing this thing so many times, did you ever think of? Because I want you guys to be used to with this extending the class from thread or implementing the interface from runnable, right? So this is one of the best part of Java. And if you want to start your career in Java, you really need to have a good idea about multi-threading, right? And whenever you go for any interview, right, in that time they will ask you about the multi-threads, obviously, because this is the most useful part, right? So this is why I'm just using classes each and every time, for that you guys can be quite familiar with the thing that how actually we can create a thread and how we can manipulate them, right? So let's see. Now what we need to do, already we did it. Now we are going to extend thread. Now what we will do, we will use the public void run method, right? And in this, what we are going to add, maybe we are going to say name changer has came, right? Already shown, right? So maybe I want this to be printed when the run method will be executed, right? Okay, now what we need to do, we need to write I'm going to write what? I'm going to go for a public static void main. Now I'm going for creating an object of my name thread demo class, right? So let's do that. But this time we are going to make two threads just to identify them. Okay. Name thread demo obj is equals to name. So what we did, we use new name thread demo and we have created the object of obj. right? So now I'm going to add one more object to my class. Okay, so let's just copy and paste. Okay, so I'm going to call obj1, and always remember we cannot have same name object for our respective class. Okay, now what we are going to do, we are going to get the name. Okay, so first we are going to see what is the name we are getting for them. So system dot out dot println, and we are going to use the what? We are going to use the getName method for to getting the inbuilt or default name of my thread, right? So let me do that. Name of default name for the first thread, right? And if you want to concat something in Java, how we are going to do that? We are going to write plus sign, right? Okay. Now I'm going to write what? Obj dot getName. Obj dot, and we got it that getName, right? So I want to get the name of obj. Now the same thing we are going to do for the second object or the second thread as well. So default for the second thread, this is according to us, right? So this is my first thread, this is my second thread, and then obj1 dot getName. So let me execute that first. Okay, so you can see, okay, I didn't use println, guys. You can see for that I get all the output in one line, right? So let me use the println because it's so easy to understand. Okay, so you can see I get for my first name of the first thread is thread 0 and the default name of the second thread is thread 1, right? Now what we need to do, we are going to start our thread. So obj dot start, okay, and we are going to write obj1 dot start, right? Now what we are going to do, we are going to set a name for our second thread maybe. So obj1 dot set, right? We got the function that is set name. Now I am going to write the first thread name. So what can be that, right? So maybe Game of Thrones. I'm a big fan of Game of Thrones, so maybe it will be Game of Thrones, right? Let's see. And one more thing, now we are going to see the name of these two thread after changing the name for the second thread, right? So I'm going to remove the default part because let's see what we will get now. Okay, let me just execute that. Okay, you can see we got it, right? Okay, so we got it, right? Default name of the second thread is thread 1. Name for the first thread is thread 0. Name of the second thread, Game of Thrones, right? Okay, so this is how actually it works. Okay, so this is how actually if you want to put a name for your respective thread, you can do that, right? So I hope you are quite clear with this part of the thread, and let's go and check some of the other demo as well with thread. Now we will look at isAlive method. What is isAlive method? So isAlive method actually to help you to understand your thread is alive or not. So let's have a look at the definition. To know whether the particular thread is alive or not, we use isAlive method, which returns the Boolean value like true or false, right? So let's go to the Eclipse and let's see how we can implement that. Now we came to Eclipse and I have already written the code in my Eclipse and we have created a class isAlive. Okay, so isAlive demo is my class name, and what we need to do, we need to extend thread class, right? So we have extend thread class, And from that, we actually implement the run method as well. So we write public void run, and in the try block, basically why do we use try block? We use, maybe if you think that that part of your code can have an exception, that time we want to handle them using try and catch block. In under try block, we are going to put our thread into sleep using .sleep method. And from that, we are saying I want to put my thread into sleep method for 500 milliseconds. And I'm going to show that print that what is the current state of my thread. Okay, how we will get that? We are going to use thread, right? Thread dot current thread, right? So you can see we have written that thread dot current thread method, and then we have called isAlive method, right? So it's going to give me that what's the current state of my thread. Okay, now what we will do, we will go for doing the other part of the program. And in the catch part, we are going to say, if you get any exception, please show me the exception, right? So catch exception E and system.out.println E. It will show you the exception you have get, right? Now what we will do, we will go for our main method, and there what we need to do first, we need to create the object of our class, right? First, we create the object of our class, that is isAlive demo, and we have decided the name of the object, that is obj, and then equals to new isAlive. This is how we create the object of a class. Then we are going to print that before starting the thread, right? So if you are not going to write that dot start, we all know that our thread is not going to start. In that time, I want to see the status of my thread. So what I did, I just write obj dot is alive, right? So this is going to give me the state of the thread before using the start method. After calling the start method, again I'm going to print it that what's the state of my thread after using the start. So let's execute it. So we will get that. So you can see first, before starting the thread, it's got false because we do not use the start method. And if you guys can look closer, you can see our main program has started from the main method, right? Not from the run method. So first is have printed that before starting the thread, it is false. After starting the thread, it is true, right? And lastly, it goes to run method, and it's showing show me the state of my current thread, that is true. So my thread is alive when the thread is in the run method, right? Now we will have a look at Java multithread synchronization. How synchronization actually help us to do the coding in Java. And let's have a look at the definition. So synchronization concept in Java stand for control the access of multiple threads who are using the same memory. So we'll all know thread is actually use the same memory. If we have 3 threads, so it will all the 3 threads will use the same memory. So let's go to Eclipse. Let's see. First we will see if you are not going to use synchronize method, what it will happen. And then we will see if you are going to use the synchronize method, how actually it help us to synchronize our threads. So we came to Eclipse, and you can see I have created a class called without synchronization.java. Right? I hope you guys are quite clear with how to make the class, how to create your class in Java project, right? So here I have make one class, that is class table. Okay, in that I have a void method, that is print table, where I'm going to send the int n parameter, right? Int n is my parameter. Now what I'm going to write, I'm going to write a for loop. Int I is equals to 1. I'm initializing I from 1. I less than equals to 5 and I plus plus. And then I'm going to print system.out.println n into I, right? So n is basically the parameter I'm going to pass, and I is the for loop range. Okay. Now I'm going to use again a try block to check just to put my thread into the sleep method. So thread.sleep, and it's going to be sleep for 400 milliseconds. And in the catch, we are going to do the same thing, that is system.out.println, and show me if I get any exception, right? And nextly, we are going to make one more class, that is my thread one, which actually extends the thread class, right? And we are creating an object of t, right? This is very important, right? So we are creating an object of table t, right? Now my thread table t, I'm passing this to my thread one is my constructor, right? So what is constructor? Constructor is something that is the name of the constructor is always that same name of the class. Okay, so we have three types of constructor. I hope you guys have an idea about that. So my thread one, and we are passing the object of table t. Okay, and we are using this function to refer the current object, right? So this dot t is equals to the new t equals to t, right? And we have a run method. Again, we are going to implement the run method as we are extending the thread class, right? So in the run method, I say t.print table, that is 10. So you can see in the print table, what I said, I am going to print the end, right? So I am going to give the parameter that is 10. So in this third class, I have class my thread 2 and extend thread. Okay, again I am going to create a table t, right? The same object of table t, but they are not synchronized. Okay, so let's see how these are going to work. And the same thing we have written over here as well. This dot t is equals to t, and we are going to provide 9. Okay, and lastly, what we will do, we will create a class of our class name, and we are going to create the object for that. First, we are going to create object for table obj, that is my table class, that is obj and new table. Then the second class that my thread 1, t1, and in my thread, and we are going to pass this obj as it's a constructor, right? And for the t2, we are doing the same thing, right? Now what we need to do, we need to start the thread, and we have started the thread, right? Let's execute it and let's see what we will get. So you can see I got 10, I got 9, I got 20, 18, 13. Nothing is like if you look at the output, you will not able to understand what is going on, right? So you don't know that what is coming first, what are the thread are actually working. So in that case, this is very impossible to manage this, right? So in that case, we want to go for synchronizing our thread. So let's see how we can actually use the synchronize method. Now we are going to use the synchronize method to get our result in a synchronized manner. And here also we are going to use the same class. I'm not going to write the other class, right? It's a big program and there is no point of writing the same thing. It's just a matter of synchronize method where we need to put it. So after the class table, I am putting that synchronize method to the void print table method, right? So let's see what we will get after that. After putting a single synchronized method, if you can look at the output, you can see I am getting an output in a proper synchronized manner, right? First I am getting 10, 20, 30, 40, 50, and then 9, 18, 27, 36, and 45, right? So first I am getting the 10, 20, 30, 40, and then I am getting the print table that n into I part, right? So this is why synchronize is needed when you have multiple thread in your class, right? It helps your class to understand which thread will go first and which one will go later, right? So this is how we are going to use synchronize method in our program.
Now let us talk about exception handling in Java programming. So before going ahead, it is important to understand what is exceptions. So let me talk about that. So what is an exception? The literal meaning, that is the English meaning of exception, is some unusual condition or a situation, right? Similarly, it applies to programming as well. That is, an unusual event or an unexpected event that occurs at runtime in any given program is called as your exception. And this exception makes the program terminate abnormally. That is, it disturbs the normal flow of the program execution. And this is called as your exception. Right? How is it different from error? So error is something which is unavoidable, right? If it occurs, your program has to stop execution and it has to be fixed to restart again, right? But exception is a situation which occurs at runtime. It might occur or it might not occur sometimes, right? It completely depends on the underlying situation that the exception in the program will be arised or not. Let me explain you this with the help of an example. Okay. For example, everybody nowadays, mostly after pandemic, uses Wi-Fi at their home, right? And you access internet on your mobile, on your laptop. Every day the internet works fine. There is internet connectivity, you are able to access the websites or the applications, right? But suppose one fine day you logged into your computer or mobile and there is no internet connection. What is that? Like all the days, suppose 7 days in a week, all 6 days it was working fine, but on the 7th day there is no internet connection. This is an exceptional situation. In programming, if I say, this is an exception. Now, what happens when this exception occurs? Before understanding that, two things you have to understand here. First, what is exception? That you understood. How is it different from error? That I explained you. Now, when it occurs, so exception will always occur at the runtime. It never occurs at compile time. Okay. So at the runtime, if something occurs, programmatically only you need to handle them as well. That what should happen if exception is arised, right? So now as you have understood what is exception, let's try to see how to handle the exception. But before that, I gave you a very simple example, right? Let me now programmatically give you some examples. First one is file not found exception. So let me give you some programming examples, okay? So the first example is file not found exception. Now, when this exception arises, suppose you are accessing a file which is on some particular server, okay? So this is the server and from your computer, you are trying to access this file, okay? It may be a video file, audio file, or a normal text file. Any file it can be. Suppose you are trying to access that. Every day you are able to access it properly. But one fine day when you try to access it, it gave you an error saying that file is not found. Okay, this is that particular exception, file not found exception. Right? Next exception example is arithmetic exception. Right? So what is this arithmetic exception? Division by 0 is not allowed when it comes to computer language, right? Because division by 0 in mathematics leads to infinity, right? So in computer, division by 0 is not allowed and it is an exception. Suppose you want to divide any integer number with a 0, it will throw an exceptional situation or it will throw an exception, right? So these are the examples of exceptions. Now, moving ahead, let us talk about what is exception handling. That is, when an exception arises, you need to handle it, you need to perform certain action, right? And what is that? So providing an alternative way to continue the normal execution of program is called as exception handling. As exception occurs at runtime, there should be some provision in program itself to take care of that exception at the runtime itself. And that is called as your exception handling. Exception handling leads to the graceful termination of the program, right? Let us try to understand this with the help of an example. So I'll take the example of file not found exception again, where I explained just now that there is a server and there is a file here which you're trying to access from your local computer. Okay, so this is your computer and you're trying to access from here the file. You were able to access every day, but one fine day it gave you some error, maybe error 400. Some error number I have given, okay. This is an exception. Now it has to be handled. So handling has two aspects. One is you can provide an alternate way to be executed when this kind of situation arises. Or second way is you can provide a graceful or a proper message to the user saying that this is the problem, please try again after some time, right? So the first way what is possible for the first way in this example? That is, when you're trying to access a file and it is not accessible, you can provide a alternate option here that from the local system or the local server, suppose there is another local server where the same file, the copy of the file is stored. So if it is not accessible from here, then access it from here. This can be an alternate path. So this is one way of handling the exception. Okay, the other way can be that if the file is not accessible, just you can display a message to the user saying that file is currently unavailable, try after 2 hours or try after 3 hours. Getting it? So this is another step. So these two options or alternate options we provide in case of exception. So this is what exception handling is. That is providing an alternative way to continue the execution of the program to make sure that the program does not terminate abnormally. We do exception handling. Okay. Now, in Java, there is a provision of default exception handling. So in JVM, there is a default exception handler that take care of exceptions, even though you are not providing any exception handling code in your program. Okay, now what is the functionalities of this default exception handler? To understand that, try to understand this flow which I'm going to explain you right now. So suppose in a method, the exception arised. Okay, I'll write down here. Suppose the method is m1, okay, not returning anything, so void. In this, I'm trying to divide a number that is of integer type, okay, having a value 4, and I'm trying to store it in value b. So a divided by 0. So I'm trying to divide by 0 here. And as I said, this is called as your arithmetic exception because division by 0 is not allowed here. Right? So now the exception has arisen here. If I have not provided any exception handling code, then what will happen? JVM will take care of this exception with the help of default exception handler. Right? So what will be the functionality? What will be the process that it will follow? So when the exception arises here, this particular method will create an object. This is called as your exception object. Okay. And it will send it to JVM. Fine. So this exception object will have 3 information. One will be the name of the exception. So exception name. Next part will be description of the exception. Okay. And then the stack trace, that is the address where exactly the exception has been arised, which line number, which class or everything, that detail, that is your stack trace. So with this information, it will create an object. The method in which exception has arisen will create an object and send it to the JVM. Now, what JVM will do? So the next step after this is that JVM will check that this particular method M1, is it having an exception handling code? If it is having, then well and good, it will handle. But if it is not having, then what will happen? So it will send, the JVM will send the control to the calling method who has called this method M1. Suppose this method M1 was called from the main method. Okay. So the control will go now to the main method. And JVM will check now in the main method that is there the exception handling code. If it is there, well and good. If it is not there, then it will terminate this main method also. Before this, as M1 was not having exception handling code, JVM would have terminated the method M1 as well. Now it went to main method, and as main method is also not having exception handling code, it will terminate the main method as well. And the control will come back to the JVM again. Right? So now what JVM will do is it will initiate the default exception handler which is present in JVM, and that default exception handler will terminate the complete program as the main method itself is terminated here. It will terminate the complete program and display a message to the user with the help of some information, and that information is something like this: name of the exception, colon, the description, and then below the stack trace. Fine. All 3 information which was sent by this method in the form of object to JVM will be now displayed as an output here by the default exception handler. So this is the complete process which a default exception handler follows, which is contained in JVM. So I hope you understood the flow of this and the functionalities of default exception handler. Going ahead, it is also important to understand what are the different exception types. So there are two types of exceptions. One is checked exception and the other one is unchecked exception. Okay, so checked exception is those exceptions which are handled or taken care before. That is, the compiler here will check when the program is compiled, the compiler here will check that is this particular exception being handled or not. This doesn't mean that the exception will arise at the compile time. It will arise at the runtime itself. But if you have not provided the exception handling code in the program for few particular exceptions, then the compiler will throw an error here. And these kind of exceptions are called as your checked exceptions. That is, the exception handling code has to be there, and this is checked by the compiler at compile time itself. The exception may or may not arise at the runtime. That is a different situation. But the handling code should be there in the program, and that is checked by the compiler, as I said. And this is called as checked exception. For example, file not found exception. Now, in real scenario, this exception of file not found may not arise also. It can be possible that the file is accessible each and every time. But still, you have to provide the exception handling code here, and it will be checked by the compiler. If it is there, then only it will compile successfully, else it will throw an error. Coming to unchecked exception. So those exceptions whose handling code may or may not be there in the program, okay, and it is not checked by the compiler. It is programmers' wish to have the exception handling code in the program or not. As it is not checked by the compiler, so it will not throw any error also. Right? Both of these exceptions, checked and unchecked exceptions, will arise at runtime only. But checked exceptions are checked at the compile time by the compiler. Unchecked exceptions are not checked by the compiler. Okay? Examples of this is arithmetic exception, null pointer exception, and many more examples are there for unchecked exceptions as well. Okay, so as now exception types are clear here, let us try to see how do we handle exceptions. So what is exception handling? I explained you. It is important now to understand that what programming construct Java provides with the help of which we can handle these exceptions. And that is your try and catch keywords. So try and catch both are the keywords in Java programming, which represents a block of code. Okay, so try is a block of code. Similarly, catch is also a block of code. Now, what does this try consist of and what does this catch consist of is important to understand. So whenever I talk about exception, there is two aspects of it. One is the risky code. I'm referring risky code to that code where the exception may arise. One example we considered right now, which was division by 0. Suppose to the integer 4, I divided by 0. This is not allowed in computer, right? So this is going to give me an exceptional condition that is called as your arithmetic exception, right? So this is your risky code. So risky code where there are chances of an exception to arise has to be put inside the try block. So this is your risky code. Okay. Inside the catch block, what do we contain? So inside catch block, we write the exception handling code. Exception handling code. In this example, suppose this is the exception. This will be placed over here, right? 4 division by 0, right? Suppose I am storing it into a variable a and I have defined here int a. Fine. This will give a exception condition. Catch consists of exception handling code. Now in this example, what could be the exception handling code? It can be that I am printing a message to the user or to the the programmer, system.out.println, and I'm writing here enter different value as the divisor, right? Meaning change the value of this 0 to any non-zero number. So this could be the exception handling code, and that is placed inside catch block, right? So I hope try and catch block is clear. Catch block also has some parameter passed to it. Now, what is this parameter? This parameter is an exception object. So you have to create an object of any exception class. So for this, you need to understand the hierarchy of the exceptions as well. So for that, I won't go into the much detail, but I'll tell you overall what are the different classes which we use. So the base class, which deals with all these exceptions and errors and everything, is your throwable. Okay. So throwable is a base class. This has two classes further, two child classes, exception and error. Fine. Error is completely different aspect, right? We are not talking about it. So we are talking about exceptions here. Now exception further has so many child classes. Child classes like IO exception, right? Then so many other classes are as well there, right? Then the further these exception has subtypes or subclasses, I could say, like file not found exception, right? IO exception subclass is file not found exception. So this is the hierarchy of the tree, right? So the base class when it comes to exception is the exception class only. So if you're not aware of that the particular exception being raised is of which belongs to which particular subclass, you can directly create an object here of the base class of exceptions, that is exception itself. Okay, so you have to create an object or pass an object of exception class here as a parameter to the catch block. So this is the programming construct that is used in Java for handling the exceptions. Okay. Now, there are certain variations to this try and catch block as well. One of the variation I will discuss over here. So you can see here in this programming snippet which I have written here, inside the try block there are two statements, statement 1, statement 2. Inside catch block there is one exception handling statement, then there is two catch blocks. So this states that one try block can be followed by multiple catch block. One catch block cannot exist independently. It has to be followed by a try block. Try block also cannot exist independently. Try block should be followed by catch block or it should be followed by finally block, either of it. Now, what will be the output or which all statements will be executed when the exception arises in different statements? Try to understand this carefully. So if in statement 1, okay, before talking about exceptions, if there is no exception, everything executes fine, then which all statements will be executed here? Statement 1 and statement 2, right? If there is no exception, then statement 1 and statement 2 will be executed. If there is an exception at statement 1, then will the statement 2 be executed? No, it won't get executed. The program will terminate here itself and the corresponding catch block will be executed. Now here you can see two catch blocks are there. So which will be executed here? Whichever exception class matches to the raised exception, that particular catch block will be executed. For example, suppose in statement 1 there was an arithmetic exception. So it will match to this particular catch block because this is having an object of arithmetic exception class, right? So this particular catch block will be executed. Getting it? If suppose it is some other exception which is not arithmetic exception, maybe file not found or some other IO exception, then the catch block which is very generic, that is the object of exception class. Exception class is the base class, right? So it's a very generic exception class. So this catch block will be executed. So depending upon where it matches, that is executed. If it doesn't matches to any, then the base exception class catch block will be executed. Okay. Now suppose the exception arises at statement 2. So when the exception arises at statement 2. So in case of when exception arises at statement 1, what happened? Statement 2 was not executed, but handling statement 1 was executed, right? This would have been executed. If the exception occurs at statement 2 and statement 2, the exception which has occurred is some maybe IO exception, then in that case, the statement handling statement 2, that is the second catch block, will be executed. So handling statement 2 will be executed, right? So these are the different scenarios with the help of which I hope multiple catch block execution is clear to you. One more thing important to understand here is that when you write multiple catch blocks, the hierarchy in which it is written should be child class to the parent class. Meaning, child class exception objects or the catch block for the child class exceptions should be first, then the parent class. So that hierarchy should be followed, else you will get compile time error. Right? So this is all about try and catch block. Next is try, catch and finally block. Whenever we study about exception handling and study about try and catch, it is important to understand what is finally block as well. Now, finally is a keyword which represents a block of code again here, like try and catch itself. But why is this finally needed? So finally consists of the cleanup code basically, right? So finally consists of the cleanup code. Now, what is cleanup code? There might be a situation sometimes when you want some particular piece of code to be executed in every situation, no matter what. May the exception arises, may it not arise, you want certain piece of code to be executed in every given situation. So if certain situation is there, you can put that code in the finally block. So finally block executes every time. Either the exception arises or it doesn't arise. Even if there is a return statement in the try block, that try block return statement will be executed after executing the finally block. Because after return, the method or the block of code exits, right? So whenever there is a return statement also in the try block, first the finally block will be executed, then the return of the try block will be executed. Right? Only there is one situation when the finally block is not executed, when you have system.exit code in your try block. Because this will exit the system itself, right? In that situation only, the finally block doesn't execute. Otherwise, in every situation, may the exception arises or not, finally block is executed. Now, one try block can have multiple catch blocks. One try block can have one finally block followed by it, or one try block can have one catch block followed by it. Finally block does not exist independently. It has to be followed by a try block. Okay? So you can see the example over here. So in this case, if there is no exception, then which all statements will be executed? Statement 1 will execute, statement 2 will execute, and then finally block statement will execute. If there is an exception at statement 1, then catch block will execute. That is, handling statement 1 will execute, and again finally block statement will execute. So you can see here, even if there is exception or not, finally block always executes. So the main purpose of finally block is to contain the cleanup code. That is the closing code if you want to have in a program, or you want certain code to be executed every time no matter what, then the finally block is required. Now, the next concept in exception handling in Java programming, which is important to understand, is a throw keyword. Now, why is this throw keyword used? So right now, when I was talking about default exception handling, I told you there that the method creates an object, right? And that is exception object, and it sends to the JVM. But if you want to manually create an exception object, that is, you want to create explicitly an exception object and hand it over to the JVM manually, then we use throw keyword. Okay? Syntax of this is throw keyword followed by the object, right? And in Java programming, we create object with the help of new operator, right? So new followed by the constructor of the exception class, right? That is the class name and parameters. This is what the constructor represents of any class in Java. So here it will be an exception class. And this will create an object, and you will throw this object to the JVM manually using throw keyword, right? You can see the example here. So there's a class example. Inside the main method, I'm throwing the thematic exception object or handing it over to the JVM using throw keyword. So throw new, this is the inbuilt exception class, or thematic exception, and there's a one parameter passed that is of string type. So this is the constructor basically of our thematic exception class, which is having one parameter of string type, right? So this is how we use throw keyword. Next is throws keyword. So it's a very common interview questions always asked, what is the difference between throw and throws, right? So just now we saw what is throw keyword. Now what is throws keyword? So throws keyword is not for creating object. Throw keyword was for creating object explicitly or manually, right? Throws keyword is for delegating the responsibility of handling the exception. So you want to hand over the responsibility of handling the exception to the caller or to the JVM, then we use throws keyword. Please remember here that the throws keyword is only used for checked exceptions. Right? Now what is the syntax for it? And what is example? So syntax for it is throws and then the name of the exception. Right? Now here few things are important to understand. The first one was that it is only used for checked exceptions. And whenever you are using throws keyword, you need not use try and catch block. Right? Because even throws keyword is going to do the same thing. It is going to hand over the responsibility of exception handling to JVM or the calling method, whoever is the caller, right? So you need not have try and catch block there. Whenever you write like the name of the exception here after throws should be a valid type. Otherwise, you will get compile time error. Now, what do I mean by valid type? So only it should be a exception, valid exception class. So here you see it is throws exception. So exception is a inbuilt base class for exception handling, right? Here also you can see here. Third point to remember here is that either the constructor or the method can use throws keyword. That is, you can use throws keyword only for a given constructor of a class or for a method of a class. For the whole class, if I write here throws keyword and exception, any exception name, this is going to give me an error and this is invalid. Right? So these are the few checklists which you need to remember while using throws keyword. So I hope you understood why do we use throws keyword. Now I'll take you to the online IDE and show you a demo related to exception handling in Java. So let's go to the online IDE. So here I'm using an online editor to write the Java code. Okay, so here I've already created a class by the name of main and there is a main method inside it, that is public static void main. Now I'm going to write exception handling code here. Okay, so inside this I'm going to write a code for arithmetic exception. So inside try block, if I define an integer with a value 4 and then I have another variable int b and b is equal to a divided by 0. Right, so this is definitely an exception. Now try should be followed by a catch block and here I am going to use the generic or the base class of exception, that is exception itself. So and then the object of it, followed by it the block of code for catch, and here I am going to just give a valid message to the user saying that enter a non-zero value for divisor. Okay. Yeah, so that's it, right? Now here what will happen, as you can see there is an exception here, right? I'm trying to divide by 0. The output should be that it should not execute this statement directly, it should execute this. Now after this, if I write suppose one more statement here, system.out.println, and if I write the value of p is b. Okay, I'll terminate this with this. The value of maybe I can write here division operation is something. Now let's execute this. Java C main.java. It should compile successfully, then we can execute. So you can see it's saying enter a non-zero value for divisor. That is, I should change this value, right? And this is how exception handling is done. Now in this, you can see this particular statement was not executed because exception arose here itself. So wherever the exception arises, after that, whatever statement is there in the try block will not execute. Now, In this, you can have a finally block also, right? As we studied about right now. So inside the finally block, suppose I am going to write again a print statement, system.out.println, and it says maybe finally block. I'm just printing a simple message here to demonstrate its execution. That's it. Okay. Now if I try to execute the same program, let's see that the finally block is executed or not. So you can see here, even if there is exception is raised, the finally block is executed. If the exception is not raised, like if I change the value of this to 2, and then if I try to execute this code, then also you'll see the output as the finally block will be executed. So you can see here the statement is executed, right? In this case now cache block is not executed and the finally block is also executed. So you can see how the try, catch and finally these three keywords are used. Basically try and catch is used for exception handling. Finally is used to represent or to have the cleanup codes if required in the program. Right, so I hope you understood this example of try and catch and exception handling altogether. Now let us summarize this course. So I'll tell you what all we discussed. So in this course, we discussed about the basic fundamentals of Java programming, right? Then we talked about the application areas of Java, like after learning or being thorough with Java, where all you can apply, what are the different diverse fields as we saw in this tutorial with the help of example also, that the Java can be applied in diversified fields. Then moving ahead, we talked about what are classes, what is an object, how these classes and objects of real world are represented programmatically in Java programming is what also we saw. Then we talked about interface and also how interface helps in implementing multiple inheritance. In Java, multiple inheritance can be implemented only with the help of interface, and that's also we saw in this topic. Moving ahead, we discussed about the three principles of object-oriented programming, that is inheritance, polymorphism, and encapsulation, right? Moving ahead, we discussed different collections, data types, or different collections basically, that is, vector, map, set, and all that. Then moving ahead, we talked about hashing. How is hashing implemented? What is the logic behind allocating memory to the variables or the required constructs, and how is it allocated? How the data is allocated with the help of hashing concept is what we saw. We also saw about the hash map and hash table in Java programming. Then moving ahead, we discussed about multi-threading, right? With the help of demonstration and example, we saw how we can create multiple threads and how we can make our execution faster when it comes to Java programming. And lastly, we discussed about exception, what is exception handling, and then we discussed about the finally block, throw and throws keyword and all that as well. So basically everything about exception handling was covered in this topic. So this long tutorial of Java will help you or would have helped you by now in understanding all the basic programming constructs when it comes to Java programming.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.